Hi, welcome to PyOhio 2023. For this edition of PyOhio, we have a day full of short talks and conversation in Discord. Before we get started though, there are a few important things for you to know. We want PyOhio to be a safe and welcoming place for people to be able to learn and grow. To help ensure this is the case, we've adopted a code of conduct that everyone must follow in order to participate in our events. Please review the code of conduct now at pyohio.org/conduct. To report any issues, email conduct@pyohio.org or follow the instructions in the code of conduct channel in PyOhio Discord. The PyOhio community uses Discord to stay in touch. If you're not already in our Discord server, you may join now using the link at pyohio.org/discord. Be sure to check out the Welcome README channel and introduce yourself in introductions. We use t-shirt sales and donations to help fund the conference. This year we have a few different cuts and colors, plus a hoodie that's perfect for the season. Proceeds from the sale will go directly to the PSF in support of PyOhio. You can order shirts through December 19th. Shirts will ship about 2 weeks after sales end. PyOhio is run entirely by volunteers, and we could always use more help, especially as we start planning our next bigger event. If you'd like to help, you can sign up for a volunteers mailing list at pyohio.org/volunteer, and we'll reach out as soon as we start planning. And stay tuned at the end of the day for an announcement about the next PyOhio. Talks are just about to get started. If you want to check out the schedule of talks for the day, go to pyohio.org/schedule. In case you miss anything or want to check back later, individual talk videos with captions will be published on YouTube shortly after their scheduled stream time. We're so happy that you're here and hope you enjoy.
Since time is limited, let's get started learning just enough computer science to be a better self-taught data engineer or data scientist. Go over this talk, I want to share my learning journey from being a business graduate to become a data scientist, data engineer. At the same time, I will discuss some computer science concepts that have been most beneficial for me to become a data engineer. My goal for me is to maximize your output at the same time minimize your learning time. So this talk is mostly for people with limited computer science education, and you're also on a journey to become a self-taught data scientist, data engineer. A shameless plug, St. Jude has helped to push survival rates for catastrophic childhood cancers from 20% to about 80%. And what's amazing is we don't bill patients. So please consider donation. So here are the topics I'm going to cover today. Hopefully I'll get to finish all of them within 15 minutes. Command line, I think, is the most important concept I've ever learned in my data engineering journey. I remember when I first started doing data science, I was doing fine with just 2 commands. One is to start Jupyter Notebook, and the second one is to pip install Python packages. Until one day, I had to train a model that doesn't fit into the memory of my laptop. Or if you want to deploy a real model on a cloud service provider's server, or you want to do any of web dev, version control, or even containers. Command line can be confusing, so let's look at common patterns of a command. Let's look at an example. Pip install dry run pandas. So pip is the actual command you want to execute. Install is the subcommand in this case. It's often used to organize and structure command in a way that's user-friendly and easy to remember and understand. And dry run is the option. Of course, it's optional and modifies the behavior of the command. In this case, dry run just means pip will show you what it's going to do instead of actually install the package. Pandas is the actual argument. Now that you know what a command usually looks like, let's look at what an actual command line interface looks like. Some of the most commonly used command is touch, which creates a new file. ls will list the files and directory in your target directory. And mkdir is to make a new directory. And of course, cd, which means change directory, where you can jump from one directory to another directory. And those 3 or 4 commands are probably will cover 50% of a data scientist's daily usage of command line. So for now, I think we're good on the command line. How can you make your script behave like a app software? Introducing argparse. Argparse is the built-in Python package that let you build command line interface into your Python scripts, and it's easy to use. You might have noticed I added a shebang into my Python file. It just tells the system to use the Python interpreter to execute the script. What's even more awesome is with these descriptions added to your argparse, it automatically populates documentation for your command line utility as long as you execute your script with -h. And if you notice over here, your script now behaves like a software. Next, I'll quickly mention Python virtual environments. There are many options regarding virtual environment. I mostly use Conda. Another thing I want to mention is the which command. Sometimes you can use which to quickly pinpoint or locate the problem with your environment configuration. Git is another essential tool you must have under your belt for securing a data science job. But here are 2 recommended tutorials you can look at. Just remember, Git and GitHub are 2 very different things. Now let's talk about computer networks. It sounds really intimidating because this image always comes to my mind when I think about computer networks. But actually, instead of focusing on those, we should focus on one single message that is sent to one computer to another computer. Just like writing a letter and envelope, you must follow certain rules for the post office to deliver your letter correctly. The messages on the internet follow Internet Protocol, and the addresses on the message are called IP addresses. Just like a letter, you have a from IP address and you have a to IP address. Now, in real life, letters are not always enough because sometimes you need to send packages. With packages, courier usually needs more information, like the dimension of your package and the weight of your package, meaning a more complex protocol needs to be invented. Similarly, in computer networks, when we have more complicated applications, UDP and TCP are invented on top of IP. Now, as you can see on the right side, TCP packets literally just have their own headers sit inside the data payload of IP packets. Of course, there is more to it, like handshakes, acknowledgements, but for now, this is good enough for us to build an intuition about the packets transporting along the cables between different computers. Here is an example message, or TCP packet, if you will. As you can see on the left side, it's the IP header, as we mentioned earlier, and I want you to focus on the source address and destination address. Right? You have your source IP and destination IP. On the right side, which is the TCP header, where you have source port and destination port. Now, I always had this question before I know what port is. Like, why would you have a port? Your computer will assign a port for different applications. Say your Teams will be running on port A501 and Slack will be running on port A502, so that when a TCP packet comes, it will specify which port it's for and the packet will be routed to the correct application. Here is an example payload of a TCP packet. Although over here is a HTTP request, but it literally can be anything. Just in this case, it happens to be an HTTP request, which is something we can talk about later about HTTP request. And HTTP requests and responses are how your browser can display a web page in front of you. For example, if you think of your browser as the client here, a Google server as the server here, your browser will send a HTTP request and Google server will process that request, sends back the web page, and your browser will process the web page and display it in front of you. I want you to focus mostly on the first verb of the HTTP request. A GET request, as the name suggests, it will retrieve data from a server. Basically, that's what happens when you hit enter after typing google.com in your browser. And another very common request is post. Again, like the name suggests, you post something to the server, often causing a change in state or side effects on the server. A good example is when you hit submit after filling out a form on the web. And there are other different types of request methods, but get and post are good enough for you to build an intuition around HTTP requests. Homepage is sent back an HTML file, which is correct. But I want you to focus on the 200 OK here, mostly the 200. That's a status code. It basically informs your browser, the client, of a general result of the request. And that's it. Usually 200 is very common, and 400 is another very common response. I believe everybody has seen 404 not found. And next, let's quickly learn how to build our own responding server and make requests to that server using Python. I would highly recommend look at Flask, especially for data scientists. These are already good enough to build a demo to showcase your machine learning model. With this, you already can deploy this to Azure or Google Cloud quickly. And don't get intimidated by the word deploy. It literally just means copy your files to another computer and configure that computer's environment and run these files on that computer. Okay, so don't focus on the syntax, but I want you to focus on the method, meaning this address will only take GET request, and this address or this endpoint will only take POST request. Now, if I go to my local host, you'll see my API is working indeed. And to get data from API using Python, it's as simple as Flask. Just import requests, get the correct URL, and do a GET. Here I use GET because this endpoint only takes GET request. And over here in this endpoint, I use POST because this endpoint only takes POST requests. And you can see I even sent in data of the name Jian, and it will respond hello. I also want to quickly show you what your browser does after getting the response. So you can see on left and right, the only difference is the H1 tag. If you're not familiar with H1, it's basically just another protocol where your browser follows that. When your browser see H1 tag, your text will look like this. If we don't have H1, it's just plain text. Next, I also want to quickly show you how you can pull information out of a web page instead of an endpoint. So for example, in this case, if our web page has this H1, we can use Beautiful Soup to extract that information out of H1. And yes, that's essentially how web scraping works. So now, with all the tools under your belt, what can you do next? You can sign up for my course no, I'm kidding. I don't have a course, but maybe I should. So really, what's next? I would do a project and more projects. Here's an example end-to-end project you can do. Here, I will also recommend learn MongoDB as an example of NoSQL DB. That's usually commonly used. And finally, you can build an UI. Here, I would recommend Streamlit. And here's just a quick example of your possible machine learning app. Nothing fancy. You just need a text box and output your prediction. And this app, literally, it only takes 8 or 9 lines of code, and that's it. And here are some more data engineer topics you can look at. If you're interested in similar content, you are very welcome to follow the self-taught DE account over here. So yeah, thank you very much. Here is the references and credits. Thank you very much.
Hello, and welcome to my talk, Better Living Through direnv. My name is Kyle Adams, and I've been doing Python development for about 15 years now. I'm a developer at a software consultancy based out of Columbus, Ohio, called TestDouble. If you haven't heard of us before, that's okay, because we have a bit of a reputation as a Ruby shop. We're also pretty well known in the JavaScript community. The truth is that we worked on projects across a variety of languages. In my 6 years at TestDouble, I've also done Elixir, C#, Elm, PHP, Java, even a little bit of Go and Rust. Oh, and we also do Python, which is why I'm here today. If you've ever spent much time doing Python development, you know that we have a problem. Setting up a Python development environment can be hard. There are tools like PyEnv, which can help with managing Python versions. Virtual environment management is getting better with other tools like pipenv, Poetry, or Hatch. But let's put a pin in that for a moment, because the whole point of this talk is to get into direnv. That said, before we get started, I need to be upfront about an important detail. Most of the content I'll be covering today presumes you're in a Unix-like environment, be that a Linux distro, Mac OS, or Windows subsystem for Linux. Technically, direnv can work with PowerShell, but I've never tried it and have no idea what quirks might be encountered. So with that said, almost all the content that follows will take place in the terminal, or a simulated version thereof. All right, let's get started. Level 0. Let's walk through installing direnv. First, we're going to install the direnv package using our OS package manager choice. Maybe that's brew for Mac OS. Maybe it's apt for Debian or Ubuntu, whatever it is. We're going to let the installer do its thing. And then we're going to hook direnv into your shell. Now, there are two things I want to point out here. The first is that these eval statements are the important bit. You can edit your shell profile and add them, or you can echo them in as I'm doing here. The key thing is that your profile needs to evaluate direnv's hook. The second thing is to use the right hook for your shell of choice. Bash for bash RC, zshell for zshell RC. Make sure that whatever hook you're using matches up with whatever profile you're editing. I'll also note that direnv supports and has documentation on hooking into other shells like Fish, TC shell, Elvish, and yes, even PowerShell. For expediency, we'll be assuming Z shell for the rest of the talk. Once we've hooked into direnv into the shell, we just need to restart it. All right, let's fire our terminal back up and see what exciting things direnv has for us. Huh, not much, right? Which brings us to level 1, setting up our first .envrc file. First, let's navigate into the project directory for a hypothetical Hobbit proverb generator. Now we're going to create a .envrc file. Oh, hi, direnv. Direnv won't automatically run .envrc files without explicit approval. And this is a security thing to prevent your mischievous coworker from checking in a .envrc file into your repo that deletes your entire hard drive when you change into the directory. So now we're going to give our explicit approval to allow the .envrc to load. And we can see mission accomplished. Direnv now loads this .envrc anytime that we're in the Hobbit Proverbs directory. So now what? Setting environment variables, that's now what? We can add a name environment variable to our .envrc file. If you've ever defined an environment variable before, the syntax should look pretty familiar. Oh, okay. Because our .envrc file has changed, direnv has stopped loading it automatically, at least until we've approved the updated version, which we'll do. Oh, nice. Direnv is now reporting that it's exported our name environment variable. Let's see if it works. And it did. Bilbo's bringing the sage advice, never laugh at live dragons. Uh-oh. Looks like our first boss is here. Let's see who we have. Okay. Yeah, I hear you, Pam. Some of you, especially if you've already used a .env file in your project, may be wondering what the difference is between a .envrc file and a .env file. Here's how I approach this question. I put environment variables that are specific to my local setup in .envrc. These may be issues of personal preference. What level of logging do you want to see when you're running an app locally, or something like name here that's going to vary from one developer's machine to the next. I then put environment variables like project name here that are shared across the team in my .env file. One note here, this approach assumes that you have some way, whether it's version control or notes passed via homing pigeon, to share that .env file with the rest of your team. A complete discussion on sharing .env files is beyond the scope of this talk, so let me just reiterate. Never version control files with secrets or credentials in them. One important difference between .envrc and .env that I wanted to point out. envrc uses export, while .env drops the export to just do variable equals value. Given all of that, if we have some of our environment variables in .envrc and some in .env, how do we integrate a .env into direnv? Direnv has a standard library of functions that can be invoked. One of those is .env if exists, which will load the .env file. Since we've updated the .envrc with this .env if exists directive, we have to reapprove it again, which we'll do. And now we can see that direnv has loaded both name from .envrc and project name from .env. That's great, but it's annoying having to reallow every time we edit the file. So let's talk about editor support. Direnv uses our editor environment variable to connect with the tool of our choice. We'll take a moment here to add that to our shell's profile, whether it's Vim or VS Code or some other editor. Don't forget to source your profile. Now you can use direnv edit to modify the .envrc file. For our example, we'll add a one ring variable in our editor, save and exit, and we now see one thing that happened and one thing that did not. First, our ring of power environment variable was loaded. Second, since we went through direnv to edit, there was no error and no need to invoke direnv allow. Nice progress. Level 4, it's time to start decluttering our profiles. We're going to start by going up one directory into the Tolkien parent directory and creating a .envrc file there too. We'll get our error message, but this time we're going to ignore it because we're going to use our direnv edit command to add a white wizard environment variable, and we're going to set that to Gandalf. Now that we see that direnv is exporting that white wizard and it's working for the parent directory, we're going to go back into our project directory and add the source up directory. Now, source up is also, again, from that standard library of functions that direnv has, and we can use it to include the parent directory's .envrc along with this directory's .envrc. And we can see here direnv loading the parent directory's .envrc. And here we can see the new white wizard environment variable being defined within our project because it's been inherited from that parent directory. But what does source up have to do with decluttering our profiles? Let's take a look at a typical profile and ask, do these environment variables spark joy? It's pretty typical to see organization and project-specific environment variables cluttering up a profile. For example, some Tolkien projects may need a specific version of OpenSSL sent to the compiler when building Python's cryptography library. Or there may be an API key that's needed for accessing an organization's private package repo. These environment variables build up over time and do not bring joy. So let's give them a boot. Or rather, we can now move them into the organization-specific envrc file we just set up. Once we move them out of the profile, how does our profile look now? Much better. And this is it, our final battle. Can direnv wrangle our Python environment? Direnv's standard library includes a variety of what they call layouts, including one for Python, which we'll add to our projects.envrc file here. Oh my goodness, that was so much easier than expected. Our boss is already on the ropes. But what happened here? Let's break it down. We can see that in response to our layout directive, direnv has now added a virtual env environment variable. It's also modified, that's what the tilde indicates, our path environment variable. Now let's take a brief moment here and talk about what happens when you type source bin activate as you would to normally activate your virtual environment. At its core, that command does two things. It adds a virtual environment variable, and it modifies the path, which we've done here with direnv. So does that mean our virtual environment is active? It does. But why isn't the virtual environment showing up in the prompt as it normally would? It turns out that PS1, which is the environment variable that defines how our prompt looks, is a bit of a special case. Direnv can't modify it directly. Consequently, we need to do a little bit more. We'll start by configuring a PS1 that uses another environment variable called a venv base. Don't forget to source that profile. And now we'll edit the .envrc to set venv base when virtual environment is activated. That's all that block of code does there, is it's setting venv base to the name of our virtual environment when that virtual environment is activated. What could this be? Could it be our virtual environment's activation is now indicated in the prompt? We see the virtual environment activated, and if we change to another directory, now it's not activated. Changing back in, and it's activated again. We did it. We defeated Python environment headaches with direnv. To recap, here's what I hope you remember from my talk today. First, you don't need to bite off everything direnv can do in one bite. You can do a little bit, learn, then level up when you're ready to learn a little bit more. Secondly, one of the first things you can do with direnv is using it to automatically load up or source any environment variables your project uses. And lastly, because virtual environment activation is just setting environment variables, we can make it happen automatically when moving in and out of directories. If I piqued your interest, here's where you can get more details. direnv.net is direnv's home on the web. Additionally, their GitHub project has a community-edited wiki that includes a Python page. This page goes into all sorts of details I didn't cover here, including direnv with pyenv, pipenv, poetry, hatch, anaconda, and a host of other Python-related tools. I'll be posting more Python-related content on threads, and you can always get a hold of me via kyle@testlevel.com. I hope direnv makes your life a little bit easier. Thank you for tuning in.
Hey, who put the Python in my browser? Hi, I'm Saduki, and I'm going to give you a quick guide to PyScript. So what is PyScript? Think of PyScript as you have Python in your browser. It's Python and WebAssembly. There are two different Python ports that are supported currently for PyScript. There's Pyodide and MicroPython. Today's demos are going to do Pyodide because I am using some packages from PyPy, which is very important to do. So the demos I'm going to show you today involve pandas, matplotlib, and Seaborn. So we're going to take a look at how we use these data science and data engineering and data visualization packages in our browsers. What does that look like? This demo is live at pyscript-demo.saduki.com, so you can take a look and see how it's working. Now, you may see other PyScript tutorials out there that say use pyenv. That's the alpha way of doing things. We're way past the alpha at this point, so that's no longer relevant. You may see demos that talk about pyconfig and PyScript tags mixed in the HTML. That's still supported, but it's falling out of favor. The demo I'm going to show you today uses the preferred way of doing things, which is you have your HTML for your presentation, you have your Python for your functionality, you have your TOML or your JSON for your configuration, plus any other supporting files. So as I mentioned, the configuration supports both TOML and JSON because PyScript is the marrying of both the Python community and the web development community. TOML is very much preferred in the Python realm, whereas JSON is more common in web development in general. So the PyScript folks are supporting both the TOML and the JSON configurations. You're going to see with my demo that I'm using the TOML, and the packages that I'm using are matplotlib, pandas, and Seaborn. So this is telling PyScript what packages do I need in order to run my code. You could also do this in JSON. JSON again, the curly braces, and instead of an equals, you're using a colon, but it is still a key and a value. Okay, so that's the configuration for what are you using in terms of PyScript in the config. But the next step then is in your HTML, you have to point a link over to the core.js file for pyscript.net. Some things to note. Again, this is not the alpha. This is a very specific release. You may see demos that mention the release as latest. That functionality is going away. It is deprecated in versions 2023.12.x. So do not use latest in the URL for your reference for PyScript, use a specific version. Now, PyOhio, again, I mentioned that there are 2 different ports of Python that are supported for PyScript. There's PyOhio and MicroPython. I'm using PyOhio. It's the CPython to WebAssembly and scripting. This is their compiler toolchain that they use in WebAssembly with the LLVM compiler framework. So that's how we're going from CPython to WebAssembly through PyOhio. The packages are supported using something called micropip, and it supports the Python wheels on PyPy as well as other packages, including NumPy, Pandas, SciPy, Matplotlib, and scikit-learn, which I use in data science and data engineering often. And there's also a REPL so you can test its limits. Okay, so we have the head tag that says, hey, we need to use PyScript, but then we have to talk about our configuration. So in our body tag, you're going to see I have a script. I'm going to have the type is equal to Py. Okay, browser, pay attention. This isn't JavaScript. This is Python in the browser. The source is going to point to my Python file, so my main.py. My config is also then specified. Am I going to the TOML or a JSON file? Whatever it is, this is your path to your TOML or JSON. In my demos, you're going to see PyScript.toml. Now, when it comes to actually wiring it up in HTML, I have buttons and I have an article with 3 sections. My article with 3 sections is already CSS stylized using FlexGrid, and it's going to display them in a row. But what's going to happen is when I click a button, it's going to go to my main Py and say, hey, do you have a function called show most tested list, for example? And then, so when I click that button, that gets triggered. And then my show most tested list is going to display output in the section with the ID called most_tested_list. Let's look at this. Let's dive into it a little bit. So we've got the script that type equals Py, source is equal to main.py, and the config. The script type equals Py. Hey, I'm using PyScript. Source, where's my Python? Config, where's my JSON or TOML file? That PyClick is a PyScript thing. When I click a button, PyClick gets triggered. And that ID equals most tested list is just to show you, hey, this is where my output's going to appear. So we've got the code on the left. We've got the output on the right. Some things to note. So I'm using PyOhio for the open URL so I can open up my CSV over the web. And then I am using PyScript, got document and display. Document I'm using to get the element, so it's document.querySelector and then my CSS selector. And then I'm using display, but not in this particular demo part. In the other 2 I use it. For this demo, I'm doing the output.innerHTML, and I'm setting it to the HTML that is generated by Pandas. So if you've used Pandas before, you'll know that you can do a toHTML. Now, I want to warn you that there's a gotcha with this. I have had times where PyScript has stripped the HTML and it has not looked so pretty. In this case, when I saw it look pretty, I was like, we're going to run with it. But keep in mind, PyScript is still actively developed, so there may be changes and little quirks that happen from time to time. All right, so that was just Pandas. Now let's bring Matplotlib into this. Matplotlib, again, using PyOhio to get my CSV content, using Pandas to read it. I'm doing some shaping and some building of the graph, doing my axis labels, things like that. But then I am clearing my inner HTML. And the reason why I do this is because when I click that button, it appends to the element. That display command at the very bottom of this, you're going to display a figure that target equals is that ID. So we had an ID of most tested graph. This will go back to most tested graph. But if I were to click my button multiple times, it would just append to most tested graph. So that's why I'm resetting my inner HTML, like, whoa, clear it out. And you'll see why I do this here in a minute. So when I click my button, this is where it goes. For Seaborn, so we add a little bit further to this, I'm creating a box plot showing the stars distribution, the rating of the ramen, grouped by style. Now you can see here that I'm also doing some cleaning of the data. So I'm using Pandas. I am using the conversion to take it to a numeric value to make it easier to display. I'm using Seaborn. I'm going to set a theme to dark grid. This is important. We'll come back to it in a minute. Create the box plot, find my output and reset it, and then display my figure. So this is what displays. So our ramen rater and his various ratings for the different styles of ramen, including can and bar. You can see the Kaggle link on the site for more details as to what can and bar lead to. So this is generated again with Seaborn on my website. Now I mentioned that whole clicking a button again. So I click the button again for the matplotlib rendering, and you'll notice that, well, my x-axis label got cut off. But you'll also notice that there's like these little grids behind it. And those grids are from the dark grid theme from Seaborn. Now, if you think these are cool, there are other things that you can do too with PyScript. And their PyScript examples website, so pyscript.net/examples, has some pretty cool things. There are two I want to show you. I want to show you the PyScript native to-do app. And the reason why I want to show you this is because this gives you the ability to do things like adding things. So do thing 1, do thing 2, thing 3. Notice as I'm typing, it's going there. If we take a look at the DevTools, and I select behind here, you can see that I am working with, you'll see div here in my lists. But you'll also see something up here called PyList. So this is another given thing from PyScript. This references PyScript here in PyConfig. So these demos still show PyConfig, but you can do this here. Now, the other thing I want to show you that's suspicious with this is there's this box here. This is the REPL. So you can put the REPL in the browser. This is PyREPL. And I could show you my favorite, which is import this. And Control Enter, or Shift Enter. There we go. The Zen of Python. And so you can see that that happens here. Now, that way you can understand what's going on. If we go back into F12 and we take a look at what this is like here, you can see that there's some outputs. There's my REPL box, and then there's my REPL. That PyREPL, PyList, these are some of the things you can do with PyScript. One last quick demo is this WebGL. So WebGL, their demo shows how you can interact between JavaScript and Python, which is another feature of PyScript. And what I like showing about this is that you have WebGL in your browser through Python and JavaScript. And if you're really not sure, I'll do the whole no tricks up my sleeve and press F12. We'll go ahead and we'll inspect. So there's a canvas. You're going to see that they have that PyTerminal, but they also have a PyScript. A PyTerminal. We're doing the ray tracing. And then you can see that if they have code there, that's what's going on behind the scenes for that. The other part, though, is with the script. So it's using 3. It's using PyScript. And then, of course, it's got its own CSS. I'll show you the head so you can see, are there any Py things going on here? Not really. There's a Raycaster demo. That's really about it. But this is using PyScript and doing some work with JavaScript. And these demos are all available through pyscript.net. So these are some of the cool things you can do with PyScript. I hope this gives you some ideas and inspires you to bring Python to your browser apps and give that JavaScript a rest. Hope to hear more about your adventures using PyScript. Happy scripting!
Hello everyone, this is Pandy Knight, the Automation Panda. Today, I'm going to show you how to do full stack Python with HTMX. Here, I have a small web app called Bulldoggy, the Reminders app. When I log in, I can create reminders lists. For example, chores. For each reminders list, I can add a bunch of reminders items for things like buy groceries or walk the dog. For any of these items, I can click them to strike them out to indicate that I've completed them. I can edit these items as I see fit. And I can even delete items if I want to. I can have any number of reminders lists as well. And as you can see, all of the interactions being performed on this web page are done dynamically. The code for Bulldoggy is open source. You can find the repository at github.com/automationpanda/Bulldoggy reminders app. Let's take a look at how the Bulldoggy app was built. The model is stored in TinyDB with Pydantic models to expose it to the code. The controller is Fast API. That's the web framework that is taking in the requests and returning the responses. The view is handled with Jinja templates and static files rendered in browsers. And then all of the dynamic interactions are handled with a library called HTMX. There's also a REST API with OpenAPI specs if you want to directly access the reminders data via some sort of client. And all of this is tested using Playwright with PyTest. Now, as you might notice, this entire web app is full stack Python. All the various components are implemented in Python or with Python adjacent technologies. In fact, even those dynamic web apps did not need explicit JavaScript code, thanks to HTMX. Let's take a closer look at how those dynamic interactions happen. And specifically, let's see what it means to create a new list. When I click on the new list row, it'll turn into an input field that I can type things into. If we pop over into the code, that content area on the reminders page is delivered by a template named content.html. And that template has a whole bunch of HTML code, as well as some includes for different partials for other templates. So we can see here how ultimately it comes down to the list content will include a list row for every one of my reminder lists that's likely in my database. And then it will also have at the bottom that new list row, which is what we just clicked on. If we look at the new list row template, essentially this is a div that contains a paragraph element for the new list, as well as a little icon next to it for adding something. And that's what we saw before. Now, what might seem interesting here is that we have these extra HX- attributes. This is where HTMX comes in. Basically, HTMX enables us to make AJAX calls without explicitly writing any JavaScript. So what we can do is directly in HTML, we can supply information about certain resource paths to hit and what interactions they take. And on the back end, those resource paths will return more hypertext that we can immediately then render directly on our page. This takes the place of needing to use a big front-end framework like Angular or React or Vue. HTMX is much more lightweight, much simpler, and also a lot faster. So let's see what that means for this particular new list row. HX-get says, hey, I want to call the resource path here, reminders/new list row edit, with an HTTP GET request. And based on the HX-trigger, I want to call HTTP GET at this endpoint whenever there is a click interaction done on this div element. And then whatever this resource path returns from the request, I want to take that hypertext and swap it, HX swap, with the outer HTML of this particular element. So that's why when I clicked that new list row, it switched to something different. It switched to an input field. So let's trace this down. Let's see the reminders new list row edit endpoint within the app. I'm going to go into my Fast API code. It's under app, routers, and inside the reminders module. And if I look for the new list row edit get request, this is the resource or the router path for it. Get, there's a prefix for reminders for everything in this module, and then new list row edit. When I look at what happens inside for this router path, what it does is it will bundle up that request and then generate a template response from this particular partial. partials, reminders, new list row edit. So it doesn't even do anything. It just is going to return some new hypertext. So let's take a look at new list row edit. And in here, oh my gosh, we've got some different hypertext. Only 26 lines, not too bad. But again, it's going to be a div. And this time the div is going to have an input. And it's going to have two new image icons that are going to be buttons. One for a check mark and one for an X. And so if we go back to our page, we can see when we click that, we got an input field that we can start typing things into, as well as the check marks and the X. If I were to click this check, what that's going to do is commit this as a new row and then make it the selected row. And then underneath of that, there will be another new list row if I wanted to add more lists after that. So let's see here. For the icon check circle, what happens with this? Whenever it is triggered with a click or even pressing the enter key on that input field from name, reminder, list name, which is this input, whenever I click or enter, this is going to trigger an HTTP post request to the reminders new list row resource path. We're going to also include some data with it. The HX include, when you give it a CSS selector for an input field, it will take the value of that input field and add it as a parameter being passed along. So that way you can take inputs and directly push them to your calls. Now this time when we get a response, we're not going to just replace this row. We are going to target another element, which is the CSS selector for the class reminders content. And we're going to swap that entire content there. Now this reminders content actually is the entire content body. We can see the class equals reminders content here. So let's trace this down real quick. New list row back in our reminders for the post. Post new list row. What this does is it will create a new list item with that reminders list that was passed in from the input field. It will make it the selected list, and then it will return whatever get reminders grid is. If we trace this function down, get reminders grid, it will build the full page context, which is all the reminders lists and the selected item, build the context, and then push that into the template for the full content. So essentially it regenerates the whole thing, and that will regenerate this. And now when it comes down to get the reminders list, there's that one new list that happens to be selected. And that's how everything gets dynamically rendered. And that's basically all there is to it for dynamic interactions with HTMX. HTMX democratizes front-end web development for all tech stacks, and it works wonderfully with Python. It embeds basic HTTP calls directly into HTML, and requests just need to return plain old hypertext. You don't need to learn complicated front-end frameworks just to make basic dynamic web interactions. Unfortunately, I can give only a brief introduction in this lightning talk. If you want to learn more about how to build and test full-stack Python web apps like Bulldoggy, please watch my keynote addresses from PyTexas 2023 and DjangoCon 2023. And thank you for watching today. Again, I'm Pandy Knight, the Automation Panda. Check out the Bulldoggy repository yourself, which has a QR code here, and give it a GitHub star to let me know if you like it. Thank you so much.
Hello, my name is Connie Skommer, and I want to thank you for joining me on this lightning-fast run-through of Python's magic for machine learning in 15 minutes. This is going to go fast. So you're going to come away with a broad and general understanding of the process of machine learning, how Python can be used with data to make predictions, and the general steps involved in doing so. There are 2 prerequisites you're going to need in order to follow with me. One is setting up a mini conda environment, and the other one is loading it with Jupyter, Panda, NumPy, Pickle, and scikit-learn. So once you do that, you can activate your environment and follow along. But before we get started, I want to accredit the course that I went through to learn all of this and more, and that is the Complete Machine Learning and Data Science Zero to Mastery course on the ZTM platform. Okay, that said, let's go ahead and get started. So over here I have the Jupyter Notebook environment, so which you would also have. I have this data folder that has a heart disease CSV file. That's all our heart disease data in there. What we want to do first is go ahead and load up a new Python notebook, and we're going to name it, let's just name it PyOhio for now. So rename it PyOhio. In this first cell, I'm going to change it to Markdown because I have something on my clipboard I'm going to paste in here. That's the accreditation that I just mentioned, along with the scikit-learn workflow we're going to go through, which is these 7 steps. Getting the data ready, choosing the right estimator or model, fitting the model to the data, evaluating the model, improving the model, saving and loading the trained model, and then we'll do a final review. All right, so let's get started. First thing we want to do is load the required import. So we're going to label this required imports, and that would be import pandas as PD and import numpy as NP. Go ahead and run that to import it. Okay, the next thing we want to do is step number 1, getting the data ready. So let's label that number 1, get the data ready. And to do that, we'll start with a variable called hdData equal to pd dot read in that CSV file, read underscore CSV, and should find it for me. And oops, tab. So there it found it. Okay, and let's just load that in there and see what we have. And there's our matrix. So we have all of the labels, or excuse me, we have all of the features, and the label here at the end will be the target column. So that's the data loaded. What we want to do is split that data up into features and labels, and so the features will be all of the columns except for that last one. So we're going to label this column or this cell, create what we'll call X. That will be our features matrix. And to get that, we're going to say X equals that hdData, which is our variable, has all the data in it, drop that last column called target, and it's on the axis equals 1, so it's on that first axis. And let's see what that looks like. Run that cell, and there we have all of the columns except for the last one. And then we want to just get that last column, and that will be our Y label. So let's label this cell, create Y labels. So Y equals hdData, just the target column. And let's run that and see what we have. And there's that last column. Okay. What we want to do is split the features into training and test data. So the training and test data, we're going to call it xtrain, xtest, ytrain, and ytest equals. Okay, before we do that, I'm going to come back up here. We need to actually import something first. sklearn dot model selection import train underscore test underscore split. So we want to split that up. So xtrain, xtest, ytrain, ytest equals train test split. And pass in x, y, and test size. So test size will be 20%. 0.2. So 20% of the data will be the test data, and the rest will be our training data. Run that. Okay, so that was number 1. We're going to do number 2 now, which is choosing the right model. So let's go ahead and label this. Choose the right model. Now, for expediency's sake, I've already chosen the model to use, and that's a random forest classifier. And you can go on to Scikit-learn's website and learn all about that. But for our purposes, we're just going to say CLF, which is the variable we use for classifier, random forest classifier. But before we do that, we actually have to import it. So from sklearn.ensemble import random forest classifier. And then we can say CLF equals random forest classifier. And then with that, we're going to keep the default hyperparameters on the classifier. The hyperparameters are the things the little knobs that you can tune the classifier or the model with. We're going to just keep the default, but in order to see what that is, we can do clf.getParams. And okay, so now you can see that here are all the parameters, and we're just going to be focusing on the estimators for our purposes. Okay, so number 3, we're going to label this number 3, fit the model to the data, which is where it finds the pattern in the data, any patterns. So clf.fit, pass in xtrain and ytrain. Run that, and we're going to put a semicolon at the end so that, yeah, there we go. Okay, so once it has it's fitted, then we can do make predictions using the test data. So let's say make predictions. Ypreds, we'll call it, equals clf.predict, pass in xtest. And let's just see what that gives us. And there's all the predictions. Okay. And then number 4, let's label this cell number 4, evaluate the model using the training data. So there is a method called score that we're going to use for that. clf.score xtrain, pass in xtrain and ytrain, because we're going to score it with the training data. And that gives us 100% result, which it should be since it's the training data. And now we want to give it data it has never seen before. Evaluate the model using the test data. Not seen before. Okay, and that's going to be clf.score and pass in the test data. x_test and y_test. All right, so that gives us a result of about 82%. Okay, so number 5 is we want to try to improve the model. So let's go ahead and label this. Number 5, improve the model. And remember, we're going to try to use different estimators. So we're going to use a for loop for that. So for I in range, and we'll start with 10 estimators and go up to 100 at increment of 10. And we'll start with printing a formatted string that says trying model with I this many estimators. Okay, and then the next line will be actually calculating CLF equals, so setting that to that random forest classifier, setting in estimators equal to I, and then we need to fit it, dot fit, and pass in the training data, x underscore train, y underscore train, and then we're going to print another formatted string that says model accuracy on the test set, and print that out. So we're going to calculate that to be CLF.score, pass in x underscore test and y underscore test, multiply that by 100 to give us a percentage, and format that by, let's say, 2 decimal places, and put the percentage sign on there. And then we'll print an empty line. Run that, and now we see we have our estimators at 10, 20, 30, etc. And looks like the best one we got on this one is about 86.89. Not too bad. Our original one was 82. Okay, so finally what we want to do is save the model and then reload it. So that's number 6. Save the model. So we'll use pickle for that. So we need to import it, import pickle, and pickle.dump. And we're going to dump the model, and we'll dump it to a file. So we use the open function. Let's call it random forest model.pkl, and we need to write binary. Okay, so if we go back over here to the home screen, we can see that it actually wrote the file, but we want to load it. So let's say and load it. And to load it, we're going to use pickle again. We're going to call the loaded file rf model equals pickle dot pickle dot load. Open the file. Open random, there we go, and we need to read binary this time. And if we use it or score it, let's say CORE, score it, we can say rf model dot score, pass in our test data, well, x test, y test, and run that. So we have a score of 85, about 85%, where we started out was at 82%. So a lot better that time. Okay, so to wrap this up, let's go ahead and recap. We have just went through a full scikit-learn workflow, and we're going to, what we did was got the data ready. We chose the right estimator or model. We fitted the model to the data. We evaluated it, we improved it, and we saved it and loaded it and scored it again. So that's it. Thanks for joining me.
Hello, everyone. Good morning, afternoon, evening from wherever you're joining in. My name is Said Mohammad Aushrazali, and I'm really excited to be here at PyOhio 2023 with the topic of not so precise float arithmetic in Python. This is going to be a small talk, so let's jump straight into what is going to be. But before that, who am I? I'm primarily a software engineer contractor working at Arbisoft, Lahore, Pakistan. Arbisoft is primarily a service provider company, and it has like a diverse set of talents. I primarily have been working with Python and Django for quite a while. If you want to get in touch with me over LinkedIn, read something that I've written at Medium, or see some of the work that I have or GitHub, the links are here. I'll be sharing the slide link at the end of the presentation as well. And with that out of the way, let's jump straight into our topic. So let's start with what is this talk about. So here are like 4 one-liners of Python that we can execute on any shell. So they're just 2 are simple arithmetics and 2 are simple assertions. And let's guess the outcome. What will be if we were to run each of these line individually on shell? we would expect that the first two are simply assertion. We are adding so not assertion, like equality checking. It's like 0.1 plus 0.2 plus 0.1 equal to 0.4. The second is that's 0.1 plus 0.1 plus 0.1 equal to 0.3. The last two are simple. We're subtracting some values, and these should be the result that we would expect. They're simple maths. But if we were to run this on shell, we'll see a bit of different result. If we were to run these, only the first and the last one will give us the expected result. So 0.1 plus 0.2 plus 0.1 will 0.4. That's true. But this one is false. 0.1 plus 0.1 plus 1, 0.3, it's false, strangely enough. And for this subtraction, we were expecting 100.0, here's 100.0. But for this one, we were expecting 100.5, but it's 100.49, and it's like long repeating value after decimal. So what's happening here? So this is what relates to the topic of not so precise arithmetics float. And this is mainly happening because of float point representation in hardware. But before I jump into that, float or like these rational numbers, they are always some of them have some sort of approximation, because when we represent the fractions in floats, some of them will have finite digits after decimal, but some will have infinite repeating decimals. So we the concept of finite repeating decimals and infinite repeating decimals, this tends to lead to approximation issues when it comes to infinite repeating decimals. So let's say the fraction 1 by 2 can be easily represented as 0.5, but the fractions such as 1 by 3, it can be represented as 0.333 or 0.33 or 0.33. So it's infinitely repeating 3 after the decimal point. And the more 3s we have, the more closer it will be to 1 by 3. But it won't be the actual value, it will always be the close approximation. And same holds true for these other two expressions. So it's just to give the example of that. When we are talking about fractions, there will be an approximation error in general. And since this issue is in base 10, it will also be present in base 2 as well. So like other numbers, floats are also represented as base 2 or binary on hardware. So the pattern of finite and infinite repeating decimals that we saw with base 10, that also exists with binary as well. The process of converting floats into binary, that's like a totally different process. I'm not mentioning that here, but I will mention that at the end of the week. You can see that. But coming back, so the same repeating pattern that we saw with base 10, that is present for base 2 as well. So we're representing 0.25 in binary is 0.01, but simple value of 0.1, there is some sort of pattern that is repeating, and further there might be a pattern that is repeating for a while, and then a new pattern, and then what's not. So the idea again, that approximation that we were talking about in base 10, the inherent approximation error or problem with the fractions of floats, that's present in base 2 as well. And why it tends to happen on Python, and again coming back to the point of hardware, in hardware the floats are represented in typically in 32-bit fashion, following IEEE 754 standard. And because this is hardware, like limitation issue, that the approximation error that we have seen with Python, it tends to happen with every programming language as well. So in 32-bit, the first bit is reserved for sign, the next 8 are for exponent, and the remaining 23 are the like after decimal or fractional part called mantissa. So whenever that part increases 23 bits, rounding off happens, and this rounding off leads to some unexpected approximation errors with float when we are working with any sort of application. So since this is inherently a hardware issue, how do we like work around with that? So first and foremost, if we were to go back to the initial examples, our expectation were like if we were to add 3 like numbers and we were comparing it to the result, we expected it to work, but because of the limitations, we got a surprise. So what we can do is we can use Python's built-in route function to manually round off the values and set our expectations, like how we want the results to be. So instead of relying on the let's say round off that is done by Python behind the scenes, we can do the round off by ourselves in our code. So we are aware of the results that we are expecting. So built-in round function takes 2 arguments, number and the precision, and using that we can get the results that we wanted. So the examples that we have at the start, if we round those two precision places, we get the as expected result in the first case, and if we round off to like 1, we get the same result here as well. If we want to work with the fractions, there's also a built-in fraction module, so we can represent those rational numbers as fractions, perform arithmetics on those fractions, and then we can format those fractions to floats wherever we need that. So this is a built-in module. We can represent like all of the rational numbers as a fraction, and we can easily perform all the arithmetics like plus, minus, multiplication, division, and whatnot, and we can easily do comparison there as well. And once we have the expected expression, or if like what sort of application we have, we can format it in the string or the float as we want to. If you want to see how close some values are, there's also a built-in math.isClose function. So we can provide the 2 values and calculate their closeness and set our expectation accordingly. And there we have 2 levels of tolerance that we can have when doing that comparison. So maximum and minimum difference that we can add in there. And using different level of tolerance, we can get different level of result. As for unit testing, the built-in unit tests also provide 2 assertions: assert almost equal and assert not almost equal, and they also work in a similar capacity as math.isClose. So the signature is take 2 numbers, the decimal places till we want to check the almost equalness, the message we want to display, and the like threshold or delta. So again, the idea is that it will take the difference of those 2 numbers, round off to the decimal places that we provided, and compare that value to 0 and raise assertion based upon the assertion that we have in code. Like if we're checking if the values are almost equal, and if they're not, raise that, and vice versa. And if we don't want to check against 0, but against some other value, we can also provide delta there as well. So using these workarounds and techniques, we can set our expectations in the code. The main goal when we are working with float is to avoid any surprises, because surprises can catch you off guard, and that tends to spend a lot of time in debugging and frustration. So approximation is weird, and because of hardware limitation, that will remain there. Like we can use long floats, 64 bits, but still the approximation issues will remain there, and that can cause our application to behave unexpectedly. So idea is that we should use the workarounds to align or set our expectation explicitly in the code so that there are no surprises. The slides are on my GitHub. I've also added my Medium article that like inspired this talk, and in that article I've like covered over the issue that describe, and also the float to binary conversion process there as well. And there are some other links in the slides as well. If you want to read more about that. Thank you everyone for listening. If you have any feedback, questions, you can get in touch over LinkedIn. I'm really looking forward to the feedback. Thank you for being a really great audience. Have a nice day.
Hi, everybody. My name is Moshe Zadka. My website is cobadism.com, where you can find every way of reaching out to me, known to humankind. And today I'm going to talk to you about iteration in Python. And the first part is explaining the difference between two very closely related things that have an important nuance between them. And that's the concept of an iterable. An iterable is something that has a method under iter, and it returns an iterator. What's an iterator? An iterator is an iterable that has a method under next that returns an item or raises top iteration. It is an instance of iterable, so it also has a method under iter, and one thing that you cannot specify by the type system, but it is true, the iter method on an iterator returns self. And so the dunder iter method is idempotent. You can call it as many times, and it will only, kind of change the value once, and that's going to be important later. As usual, we don't call dunder methods directly on objects, and often with Python, just like say with int, right? You don't call dunder int directly. You call the int function, and it will either call the dunder method on a Python level object, or it will call the right method on a C level object. So that's how you actually use those. You run iter or next. Right, those are built-in functions. You don't actually have to define them. And so let's define a simple iterable. So remember, iterable only has one method, or only has to have one method that has dunder iter. And in this case, we'll just hand off it to something else as the iterator. So we'll build a list of two things, and then we'll ask for the iterator of that. The iterator of list, as you can imagine, will return the two things. So let's see how it works. We'll call next on the first one, then next on the next one, and we'll get 1 and 10, which is the two ints that we had. That's great. Now let's write an iterator. So as you can see with an iterator, you actually have to have a state. You cannot have a frozen class. So to simplify things, I'm just going to hardcode. This iterator will always return just 1 and 10. And the way I'm implementing next is I return the first thing in the list, and I also remove it from the list. And if there are no items in the list, I raise a stop iteration. So that follows the iterator protocol almost, because I didn't implement dunder iter. But as always, Python is going to give us some leeway. So in order to fit in on slides, I'm not going to implement dunder iter here. And as you can see, we call next, it does the same thing. This time we didn't have to call the iter because it's already the iterator. And just to show that it does the exception correctly, if you call next again, then it will raise stop iteration. And that's true whether you use the iter deck via just iterate on two items, or if you use any of the iterators that we've returned so far. So in order to show how for does it, I'm gonna use the same iterator that we wrote before, but this time I'm actually gonna implement dunder iter because I have to, and I'm also gonna put a lot of prints in dunder next. So as you can see, this time I'm getting the ret value and not returning it directly. If I get an exception, I print that this is the end of the iteration, and I raise the stop iteration exception, and then I call dunder next, and then I make a print that I'm returning the value, and then I return the value. All these prints will make it really easy to see what's going on. And as you can see in the for loop itself, I'm also going to put a lot of prints, right? So I put a for before and a print inside the for, and a print after the for. And as you can see, before it, right, I have a print. You'll notice that like dunder next is not going to get called, right, until I actually call the for. So then the first time I go there, I return 1, and then the value is going to be 1, so I get 1. Same thing with 10. And then the next is going to be end of iteration, which means I'm not going to go for another iteration, right? I don't have a value for that. So we end the loop. And this is how loops are connected to iterators or iterables. In fact, this is why I needed to have the iter methods, because for always assume it's an iterable, so it will always call the equivalent of iter internally. The other way of using iterators or iterables is to call list or any other sequence constructor that will just consume all the items in the iterator and will put them in the sequence. Easiest is list. And as you can see, we have all the prints before we get the result, and then the result is the item. Those are the two main ways that you'll naturally be using iterators or iterables in Python. Now, what's the connection to generators? Often people use generators and iterators in closely related ways. An iterator is a protocol. It specifies what has to happen when you call under iter, what happens when you call under next, and so on. It's annoying to implement. If you remember, like when I tried to implement it myself, it was unpleasant, right? I had to write complicated states. I had to recover from exceptions, and I even had to cheat a bit by putting stuff in a list so that it will be easier for me. And if I had to do it in production, that would potentially take up a lot of useless memory. It's not pleasant to write iterators. Generators give us a mechanism to build iterators that is much more pleasant. So I promise it will be much more pleasant. Here's how much more pleasant it will be. This is the same iterator that I wrote before, right? Remember before I had to implement dunder init, dunder iter, and the dunder next was this kind of complicated try and accept. This is the same thing, right? It has the same equivalent prints, right? Begin, middle, end. And that's it, yield, and 5 lines instead of the 20 odd complicated lines I had to write before. And if we use it in a for loop that's very similar to what we've written before, then again, we have the before, begin, got 1 middle, got 10 end. After the end, it raises stop iteration error, and the loop ends. So generators are a much faster way to implement the iterator protocol. And one other thing that I want to cover in using generators is that you can use yield from, and that's often a way to use another generator in a generator or any iterable. It will work, right? So if I want to, I have the old list of 1 and 10, and I like that, so I got the 1 and 10, and so I yield from to iter, and then I yield the 100. And now if I use the list, right? Remember that's the other way of using iterators. Then I get 1, 10, and 100, and the prints all come before I get the list. I already explained that to consume an iterator, you can use a sequence constructor. What if you want to consume the sequence and you're not interested in the actual value, only interested in the side effect, in this case, the print? Then there is an interesting sequence type in collections called DQ, double-ended queue. And one of the useful things about it is that it has a max length. And if you give it a maximum of 0, then it will consume the iterator. It will add each item as it goes, but it will add it to a 0-size DQ. So it will add it and throw it away immediately. And so you'll end up with an empty DQ and the side effect. So this is a nice way to consume a generator just for the side effect. So a lot of functions in Python accept any iterable and return an iterator. Now, if you remember, any iterator is an iterable, which means all these functions can be composed together, right? Because the return value of one function can be fed into it or any of the other functions, and that can be fed into any of the other functions, and that can be fed into any of the other function. So let's give some examples of functions that you can use in your own life that will probably be useful. The first is a pretty cool built-in called enumerate. If you go enumerate an iterable, then it will return an iterator with tuple of the original value and the index. That's very useful if you need the running index to say print every 10th item, makes it much easier. Map takes a function and an iterable, and it will return to an iterator that does the function one step at a time. So I add 1 to an iterable of 1020, and I get 1121. Filter, right? So map modifies the element. Filter doesn't modify the element. You get the original element, but not all the elements. So in this case, I ask for all the things that 5 is greater or equal to. So in other words, things that are smaller than 5. So on a list of 1, 10, and 3, I'll only get 1 and 3. Zip takes any number of iterables and just returns you a tuple of the elements from all the iterables as an iterator. And if none of these work and you need anything that consumes an iterable and returns an iterator, you can make a generator expression, right? So double plus 1, it means 2 times a plus 1. And then I just give it 1 and 10, and I get 3 and 21. If you added if, it will also function as an ad hoc filter. Now, I showed you how you can have some built-in functions. I can show you how you can define your own functions. But there's also a whole module built into the standard library, which is just dedicated to give you even more functionality like that, and that's itertools. I'm not going to go over all the functions in itertools because it's a lot, but I'm going to give you a little taste so you can see what kind of thing to expect. But basically, it gives you a lot of useful advanced iterator algebra things. First thing, chain, right? That's very useful because you can have 3 items and then say another 2 items, then you'll have one iterator that goes through the first one and then the second one, and you can have third and fourth, and you can have any number of iterators there. So it's a very useful kind of iterator addition operator. iSlice is basically the equivalent of slicing a list, but for an iterator, right? The nice thing is it doesn't build the list in advance, right? Like it's an iterator, so it will only consume as many elements as you will need it. And it's very useful because you can also use it on infinite iterators. Itertools count is an infinite iterator that just counts. And I can slice the first 5 elements so I can have a finite iterator that counts. And then I give it to list to kind of consume it so you can see what's in it. Let's say none of these things help you out. There's a third-party library from PyPI called More Itertools. You can imagine what's there. You can imagine that I'm still not going to tell you all the functions in it, but I'll give you a little taste. So when itertools is not enough, for example, you can have chunked. Very useful if you have an iterator and you want to work on things in batches. Maybe like you want to edit into a database in batches or use a REST API or something like that. You can use distribute, which will kind of separate it into a few streams. That's useful if, say, you want to distribute it among several threads or maybe even several CPUs or anything like that. You can use pickable, which will let you pick into the future so that you can say, as soon as you see 3, don't give me any of the items. So stop at the item before 3. So as you can see, I get 0, 1, and I don't want 2 because 2 is the one preceding 3. So this is nice, right? I can pick, and I didn't consume the 2. So if I give the iterator to something else, it will consume it. Windowed, my favorite thing to do with windowed is just get like the list of differences, but you can also do it for like rolling averages or something like that. So what do I want to leave you here with? Iterators and generators. Iterators are useful interface. Generators are a useful way to implement that interface. If you use them together, you can code Python in a much more powerful way because you get an algebra of just in time. You basically have a whole lot of functions that accept and return iterators, and that gives you composable just-in-time tools. There's a huge ecosystem of them. So before you need something, or before you use something, do your research, use whatever you find, and if you find you have something new to contribute, some other primitive of iterator algebra, contribute it back to the ecosystem, and you make everyone better off. Thank you very much. I hope that was useful, and have a great rest of your conference.
Hi, and welcome to this talk on making our Python code more accessible. First, an introduction. My name is Dmitry Chukin, and I'm a developer. I've been working as a web developer for the past 9 years, building web applications primarily in Python and Django, but also working in other frameworks and languages. One of the things that I've enjoyed the most about my time as a senior developer and our team lead has been mentoring other developers, helping them to grow, asking questions, answering questions, and figuring things out together. And one of the things that we've been figuring out together recently has been the idea of accessibility and how to make our web applications more accessible to more people. Accessibility is important, both ideologically as well as helping the business. And so I'm going to talk about how to make Python code more accessible.
Hi, everyone. I'm Janelle Bouchard. I have a background in design, customer service, and user experience, or UX. And after many years of dabbling in some code configuration and really loving it, about 2 years ago, I completed a full stack software development bootcamp. A fun fact is that when I got my first development job after I graduated from bootcamp, Dmitry was my mentor, and honestly still is to this day. We've talked about this a lot, and accessibility is something that we're both very passionate about. For me, from my perspective, I believe that accessibility is a fundamental aspect of UX. I don't think that there's any question about that because ease of use and user experience, really go hand in hand with how someone is accessing your information and your tool. It became more and more clear to me on my tech journey that accessibility is fundamental to all aspects of any business. And I've done a lot of self-study with some great resources that I've had. And more importantly, I have made friends with some incredible people in this community, in this industry, who are much more knowledgeable than me on how to make things more accessible. But I'm a huge believer in the concept that you have to start somewhere. And the only way for us all to be better is for all of us to share the knowledge and experiences that we have. So, before we really get into it, let's go over some high-level definition type things to get everybody on the same page. So we've said the word accessibility several times, but what does that actually mean? The definition is the quality of being easily reached, entered, or used by people who have a disability. There are some synonyms and similar concepts, including ease of access, ease of use, availability, comprehensibility, understandability, those kinds of things, regardless of ability. So then the next logical question is, what is disability? And that's any condition of the body or mind, an impairment that makes it more difficult for the person with that condition to do certain activities and interact with the world around them, which is a lot of words. But these things can be categorized into 4 different types. There's behavioral and emotional, sensory impaired disorders, physical disorders and disabilities, and developmental disabilities. Now, disabilities can be permanent, temporary, situational. They can be visible or invisible. They can be known or unknown. So, for example, on a personal note, I was diagnosed with ADHD very late in life. I had no idea growing up that I had it. Some idea. But the point is that I didn't realize what that meant. I didn't realize that I had a disability necessarily. And so when I encountered things that were difficult for me to comprehend, I felt like there was something wrong with me. But in reality, it's that things were not accessible based on how I processed information. And that's really important to remember. And honestly, everyone, everywhere can move into or out of a state of disabledness at any moment. And that's why creating things with accessibility in mind from the beginning is so important. And in reality, when you create something for people who have a disability, it's going to benefit everyone else too. There's some really concrete examples of this that we see in everyday use. For example, the most well-known one is the curb cut effect. That's the area in the curb that's a little bit lower down. You probably use it when you are grocery shopping, or if you have a dolly and you're pushing something heavy, Or, if you're in a wheelchair, then that was made specifically for people with a disability that required a wheelchair. But I mean, if you've got a stroller, it's going to be helpful for you too. So that is just one great example of how things that were created for people with disabilities in an accessible way really benefit everybody.
There are a lot of accessibility concepts, but the most important ones that we've come across from our time working on web applications are the following. Number one, accessibility is an important concept for each person on the development team, whether that person is a designer, the front-end developer, the back-end developer, the quality assurance person, project manager, or anyone else on the team. Oftentimes, it's easy to think that accessibility is something that just the designer or the front-end developer should focus on, but actually everyone on the team is a part of making accessible features and contributes to making an application more accessible. Number two, it's important to have accessibility as a regular part of the development process and not just something to add at the end. Speaking from experience, if it's something that we leave until the end, it probably won't get done. And actually, it's a lot easier to make accessibility a part of the feature if we think about it as we're working on it rather than trying to make the feature accessible after we've done everything else. For a lot more concrete examples, you can view the Web Content Accessibility Guidelines, which have a lot of examples about concrete details like images and color contrast and many more examples. Front-end code in JavaScript and HTML ends up being used by end users, so it's more obvious what sorts of accessibility implications it has, but Python code typically isn't. Nonetheless, accessibility still applies to Python code that people write, whether it ends up being explicitly seen by end users or not. And it's still an important concept. I'm going to mention three things on this slide. The first one is having an accessibility mindset and thinking of accessibility as something that's important in the things that you write, whether you're adding a feature to a project or fixing a bug. In some way, your code will be used by another person. And so it's important to make your code accessible to that person, whether that's an end user or whether it's another developer. Number two is thinking about the user visible changes in your code. If you're working in web development, that may mean something like making error messages readable or accessible, or thinking of the data that's returned from an API, or even thinking about the amount of data that is returned. Number three is making your code accessible for other developers. In a way, other developers that read your code are users. They may not be the end users of the application, but they are people who will be working in your code. And so it's important to make your code accessible for them. Here are a few examples of how we made our Python code more accessible. First, we've written comments and docstrings into our methods and functions to make sure that when somebody is reading that method or function, they can quickly see at the top what this method does or what this function does. And we've added comments to each section of logic to make sure that that piece of logic can be explained. If there's something that's confusing, then it can be explained in the comments. Another thing is giving variables meaningful names, so not using variables like A, B, and C, but using variable names that have meaning to what is relevant in that logic. Another thing is we've added linter settings to make sure that we can capture anything that may make the code less readable. So that includes things like the length of a line, but you can also customize your linter settings to catch many more things. We use pre-commit so that whenever anyone is adding a commit to a repository, we run a bunch of linter settings, and if there's something that the linter decides is not acceptable, then the person has to fix that, whether it's making lines shorter or any of the other things. Another important one is choosing your code editor. There are many code editors out there, and they have varying levels of accessibility compliance. A popular one is VS Code, and one that we use on our team. And VS Code has a long article about the way that they have tried to implement accessibility into VS Code, from things like syntax highlighting and using different colors with an appropriate color contrast, to showing a hierarchical view of the code base and of a particular file, and many other things. And I recommend that you read that article as well as whatever settings your particular code editor might have. And if you find that there are issues, certainly feel free to point them out to them, and I hope that they will improve the accessibility of their code editor, whatever code editor you're using. Another thing is thinking of the specific end user examples, such as having readable error messages. When we write Python code, it's actually the Python backend that's returning error messages to the front end. So if the Python code has messages that are not readable by people, then that is actually an accessibility issue that can be fixed in Python. Another thing is supporting non-Western data, such as names that are very long or have characters that are not in the ASCII set, or supporting names that don't have a first name and a last name, or many other scenarios which people around the world may run into, but people don't typically run into in the US. And so we've tried to think about those things in the way that in a way that a user might be affected by them, whether that user lives in the US or not, and to make sure that the backend supports making sure that the backend supports an accessible front end, whether a person has characters in their name that are ASCII supported or not, as well as many other examples. Another thing that's listed here is an accessibility checker, and there are a number of accessibility checkers available out there. One of the things that we've tried to do is also to write some unit tests in Python that do some basic checks of accessibility on web pages, things like color contrast and checking the HTML tags and checking alt text for images. And so that is something that you can include within your automated unit tests in a repository. There are many other examples, but these are just a few that we have added. And if you have other examples that you have added or that you're interested in, certainly feel free to reach out to us, and I would be happy to hear your examples and try to improve the code that I write through them as well.
Thank you so much to all of you for watching our presentation. We really appreciate it. Love the support for the accessibility community at large. And we want to give a very special shout out to our friends, Louis Lee, Sage Putnam, and Ronald Luna. They were pivotal in helping us put this together, and are incredible support and great developers who are also fighting the good fight. So thank you guys all for joining us. Thank y'all all for joining us. And hopefully, if you have any questions or feedback, please let us know. Thank you.
everyone. So today we're going to be talking about OpenSearch, Python, and serverless. My name is Laís Ochoa. Today I'll be joined by Yulia Barabash. We both work at NordCloud. We are both located in Munich, which is currently snowing a lot here. And we're going to be talking about OpenSearch with you today. So let's dive in. So what are databases? So databases are used for store, manage, and retrieve data. We have a lot of data, different kind of data in this world. That's why we have so many databases, and that's why we have so many types of databases. So there are graphical databases, there are key values databases, there are relational databases, document database, and so on and so forth. If we take a look about a real scenario of using database, that could be something like we have experience. So we had a DynamoDB database that is a NoSQL database, key value database that we use to send the data from an application by triggering a AWS Lambda function, and we send this data to the DynamoDB. So at DynamoDB, we also fetch this data. But at some point, our client wanted to have search capabilities. So our client wanted to be able to search across all fields and across all documents. And maybe DynamoDB has a key value database is not the best choice for that. So this could be frustrating to have it using DynamoDB. So we need something that actually has search power and can help us in this mission. But it does not mean that we need to replace DynamoDB. We can still use DynamoDB as a source of truth, and also because we don't want to change all the architecture to just have the new feature, the search feature. So in this case scenario, it would be great if we can add something new. In this case, we choose to add OpenSearch. OpenSearch is an open source database, and it's a search engine as well. And you can use in the scenario. So instead of when we send the data to DynamoDB, we would then trigger AWS Lambda functions to send this data to OpenSearch. And for the API, we can also trigger Lambda functions to fetch this data, and so on and so forth. This would be great, and it would make our client happy, and also our user experience would be improved because OpenSearch solves search problems. But what kind of search problems does OpenSearch solves? So we live in a beautiful world where people are talking different languages. I am a polyglot myself, so this is a nice feature to have. The thing is with human language, when, for example, languages like German language, there is a use of composed words where two words become one word. And this is maybe different in other languages, like in Portuguese, this is not so common. So the way that you would index data from different languages can be different because the way that also you query this data. So you have to think how the language works. And for that, OpenSearch has such a feature called multilingual. So you can actually choose which language you are indexing your data, and OpenSearch will make sure that relevant results will be brought for you on this language. Another great capability of OpenSearch is that, for example, when we are typing, we make mistakes. We are not a robot, and we make mistakes, and could be that there is a typo. It does not mean that your OpenSearch cannot understand you. It's like in human language as well. Even though I can make a mistake while I'm talking, you will still gonna get the message. And OpenSearch is able to do that by having fuzzy searching. So even if you type something wrong, you're still gonna get results. This is quite excellent for a user experience. Another cool thing is that OpenSearch can read your mind. So you start to typing, and OpenSearch will look into the data, it will look into the relevant fields, and try to autocomplete what you are thinking, what you are typing. And this is quite nice feature. Actually, today you are lucky because you're gonna learn how you can implement autocompletion. So it's a cool feature that you have with OpenSearch. Another one is that if you're coming from a relational database that requires a schema, you are quite like restrict on that. You need to have a schema, you need to declare your types, and so on and so forth. But with OpenSearch, you can just send your data, and OpenSearch will figure out through dynamic mapping. And of course, if you know how your data is, you don't need to do that. You can, you are sure about your data, you can just specify your data types. That would be also nice. So this is cool. We have all these features that OpenSearch have: multilingual, fuzzy searching, auto-completion, dynamic mapping, and more that I did not introduce here, but just for you to know how powerful is search, OpenSearch, and how powerful OpenSearch is in the context of search. But now we're going to talk about auto-completion with Yulia Barabash. She will introduce this topic for you.
So, thank you, Liza, for your part. And now let's dive into more the practical part. And we will start with auto-completion and how we basically can implement this. So let's assume we want to create application where you want to search, for example, for movie. What kind of movie you want to watch this night? And for this, we want to implement auto-completion. Basically, here you can see the demo where you type Harry and application gives you some examples. So how it can be implemented? There's 4 different types how it can be implemented, but we just focus on 3 of them. The first one is prefix matching. It's one of the easiest one because for this you don't need to create additional index. You don't need to create to do some kind of the index mapping. Basically, you even can reuse the existing one. And for this, you basically what you need to create a query. Query that will just search for prefix. For this, you define the client that communicate with OpenSearch. After that, you define your body, query. Inside your query, you define, okay, I want to match the prefix with the title Harry. Nice. And this will give you results where the title will have prefix Harry, and later in the demo you can see this. The next one is more complicated one. It's called complete suggester. With complete suggester you can implement in the way that you need to define a type for your field. For example, for title we want to define you need to define the field completion, and after that OpenSearch will create in memory tree where field will be present as a tree and it will look like this, for example. And during search, if you search for Harry, OpenSearch will traverse the tree and will start with the first letter H as root. After that, it will go to A, and after that, it will go to R. At the end, it will just analyze the rest of the nodes and return some results. It's very efficient way, and I think the fastest way, because you basically what you do, OpenSearch just traverse the tree and return results. And for this, you need to create the type of the query suggest. You need to define the name of the query suggest title, because you can have a few suggestions. And then you define the prefix Harry and the name of the field that you want to query. Great. And the last one is the search as you type. With search as you type, what you do, you also define type for your field, search as you type, and OpenSearch will create some hidden fields, some sub fields for your field. For example, we define a field for a type as you search, and OpenSearch during indexing, processing it, and will keep in the memory this processed information. For example, for title, it will just, for a regional field title, it will split words and will keep the word as an array of strings. And additionally, it create different n-grammars and keep in the also as memory. And during search, it will match again these subfields and original field and will return the best result. How you basically can use it? For this, you also need to define the query. And inside the query, you can use one of the multi-match queries where you just specify the query, what you want to search for it. You also need to define the prefix, and at the end, you can define what of the fields you need to use, and also you need to define also these fields that was created by OpenSearch. So during query, it will match against these fields. Great. Now let's talk about our demo. And for demo, as I mentioned, we create a simple application, and let's assume we want to search for a movie, but I don't remember the name. For example, the proper name of the movie. I just remember that it has word Harry. And we can see with the prefix match, we match against our index and we return all fields where there's word Harry. But maybe I don't know the proper spelling of the Harry, and I spell like Harry. And you can see that in this case, I don't get any results. So to be sure that your user will get some results, we can implement more powerful search. For example, completion suggester. Where completion suggester understands that people do mistakes, and even person do not do proper spelling, it still returns some results. For example, maybe it can be Harry is snowman or Harry the Skype. And in this way, people still will get some results and they can still select them. Okay, great. And this all was for our demo. And if we do some kind of conclusion, how OpenSearch works, we can tell that OpenSearch is very powerful because it has different integration with AWS services. Also, it's possible to have serverless OpenSearch where the AWS can take responsibility for operational overhead. Also, it's very scalable. Additionally, you can do performance optimization. It can be very fast. And OpenSearch also great for data analysis and for aggregation. Great. And the final and most the best suggestion, if you want to do search, is the best to use OpenSearch. And thank you for your attention.
Hello, my name is Drake Pasacco. I'm a senior consultant with Slalom right here in Columbus, and this is how to test your cloud code confidently. So the agenda for today, we'll start off with a brief introduction to who I am. We'll go into a technical background about the problem we're trying to solve. Then we'll go into what that problem is before moving into the stubber, the solution to the problem, and then ending things off with a live demo. So now let's do my introduction. Again, my name is Drake Pasacco. I'm a cloud senior consultant with Slalom right here in Columbus. I've been with Slalom for just over 2 years, and I focus primarily in AWS Cloud. Now, I live in Columbus, Ohio, and I'm originally from Pittsburgh, Pennsylvania. I'm an Ohio State grad of the class of 2019 with a degree in computer science and engineering. I've got 5 years experience with AWS and 9 years experience on and off with Python through my college and professional career. So now let's get into the technical background on the problem we're trying to solve today. AWS is one of the largest cloud providers around the world, offering hundreds of different services and products that devs and engineers can leverage to build and host their applications. Cloud-native applications will regularly utilize multiple AWS services. An example of this would be an API that uses API Gateway with a Lambda function to upload to an S3 bucket or update a Dynamo table. Building these apps with Python is made possible with the Boto 3 SDK that is maintained by AWS. This SDK serves as a client to invoke other AWS services from your code. So now that we have an understanding of the technical background, what's the problem that we're facing? That problem is, how do you run unit tests on code that interacts with other cloud resources without actually affecting those resources? We can't guarantee the state of any other resource that's in the cloud at the time we run our unit tests, and we may want to run these unit tests locally but are unable to access the cloud environment while running those tests. And running these tests with the possibility of actually invoking real cloud resources introduces the possibility of a unit test failure due to networking or security reasons. And it is very important to test and validate your AWS networking security, but unit tests should be focusing on the functionality of the code itself. So now that we understand the problem at hand, what's the solution? That would be the stubber. The stubber is a class of Bodo core that allows you to stub requests made in your code while running unit tests to allow you to test without actually interacting with any deployed cloud resources. And as a note, Bodo core is the low-level interface to many AWS resources, and it's the backbone of the AWS CLI and also the Bodo 3 library that we're using in our code. Now, what does stubbing actually mean, though? Stubbing a method means to use one piece of code to stand in for another piece of code while executing. So what this means is, using the stubber, we are able to intercept code while running our unit tests and have the results replaced with whatever our code says instead. Now, this is not to be confused with mocking in unit tests, but mocking is a separate topic that we're not going to go into today, and I highly recommend you look into it if you're more interested. But knowing that, why should we stub? What's the point of replacing code with other code while running a unit test? It sounds like that's not actually testing our code. Well, using the stubber, we're able to test that all the Bodo 3 methods we're calling in our code are called correctly. This means called with proper arguments, we're validating that these calls actually happen, and we're validating that calls can happen in the correct order. Additionally, we can also validate that we're getting the expected exceptions raised when things are supposed to go wrong and be caught. The stubber also allows us to guarantee the result that every method will return, allowing for every single unit test to operate with the same response every time they are ran. This allows for consistency of runs and ease of your assertions. You no longer have to worry about what happened to the dynamo table when running a unit test if you're always going to get the same thing. And this allows us, especially when replacing Bodo 3 method calls with the stubber, we don't have to be testing AWS's code for them. We can just get the results that we are expected to get based on their API documentation, allowing us to focus on the code that we're writing. Now let's get into a brief demo and we can show how the stubber works. For this demo, we'll be starting off with the basic AWS SAM CLI use case example for Python 3.9. This includes a Python Lambda function called hello world in this app.py file that as of now just returns a 200 and is invoked via an API gateway deployed through the CloudFormation template here. However, today we're going to be focusing more on the unit tests, so we'll start off by looking at our test handler here. We have a mock API event that we'll be using as part of this test, and we'll start off by running this test. We will run PyTest on this, and you'll see that we get a pass. However, if we go back to our app, and then we add in the DynamoDB call, and try to run that test again, we get a failure because it's trying to find my AWS credentials to locate this resource in the cloud. However, since I don't have my credentials file activated right now, it's not able to find that. So this unit test fails. Now, how do we add in the stubber code? So we'll come back here to the test handler. I'll make the screen a little bigger, and I'm going to expand out this commented box here. So the first thing that's required is setting up a Bodo 3 client. What a Bodo 3 client is basically just an object that is used as a client to interact with the AWS resource in question. In this case, it's DynamoDB. Next, we create our stubber. For this use case, we'll be using a with statement to keep the stubber and all of our calls encapsulated instead of having to activate our stubber. So we're creating this stubber using our Dynamo object, and we're calling it stub. With there, we then can add a response to our stubber. What the add response method does is it will look for this method being called in our app.py or whatever we're calling. So we've got app.py here, and we're calling dynamo get item. So we're adding a response where wherever stubber, after we're going to replace that client with our fake client, it'll be looking for whenever it calls get items, it'll be returning this exact format as its response. The second argument is always the response value that our fake method will return. And then this is the input it's expecting. So you'll see back here, we're looking for this input of demo ID as an ID, and the table name is fake table. Both of those line up. So now we can then replace the call for our actual Boto3 client in the code. So now whenever we make that client in app.py, it's replaced with the one we made here that has the stubber attached to it. We can then uncomment the regular unit code and get rid of the duplicate code here. So you'll see that we are just getting the response from the application handler, loading the response, and then just asserting that everything's correct. So now we've got the stubber in place. Let's run PyTest again. And we get a passing job because we've replaced what it's showing with what we're showing. And if we run this with additional prints on, you can see that we're printing out what we're getting. And you'll see that it lines up exactly with what the stubber defines in its method that we wrote is going to return for us. Now, we can't just define whatever we want as the response value for get item. For any stubbed response, it has to match the specification as defined in the Boto3 API specification. So we've got this item here, which is the top level key for any dictionary returned by the get item call. However, if we change this to items and try to run our tests again, it fails because unknown parameter and input items. It must be either item or consumed capacity at that level. So we can't have outputs that would potentially mismatch the definition provided by Amazon, which is another thing that makes stubbing very valuable to ensure that we're getting and working with responses that we are going to be guaranteed to get in the format of. Additionally, the input to our function that we're stubbing needs to match what's coming from the input in our app.py file. So right now we're both expecting this table name of fake table, a key which is a dictionary of ID, and then S and then demo ID. If we come over here and change this to demo IDs and try to rerun that test, you'll see that we get a failure because these do not match. It's expecting demo IDs but received demo ID. So this allows us to validate that we are going to be giving the functions from Boto3 exactly what we expect to be giving them. Now, that was a fairly simple example with only one Boto3 call being made from our app.py file. But what happens when we start having more calls? Let's go into our app.py file and we'll add in this DynamoDB describe table call to describe information about our fake table. If we run our test again, though, you'll see that we get an unstubbed response error. So you're seeing here in our test handler that we're intercepting and replacing the expected client with our fake client that is used by the stubber, but it doesn't have a stub for that additional method call, so it fails our test. This is a good thing so that we can validate that all of our calls are actually being made and being made in the correct order. So now let's add in the stub for this new function that we've added. I'll come in here, I've already pre-written this, we'll paste. So again, we're doing stub.addResponse. We're using describe table because that's the method that we're calling. The expected response we have is this table with table name. The output for DynamoDB describe table is actually much longer than this, but one nice thing about the stubber is that you do not need to define all of the optional arguments and other things for a response. You only need to define exactly what is required for both the input and the expected output. So we're just doing the table name, and the expected input matches up with our app.py of this fake table. So we can go ahead and run our test again. You'll see that we get passed with the same print statement from earlier. So now that we know how to deal with multiple API calls, how do we deal with multiple Boto3 clients? Because currently we're only making a stubber for our Dynamo client. So if we go back to our app.py, we come down here. I've created now a Lambda client. I'm using Lambda as the name since Lambda is a keyword in Python. Then we're calling Lambda get function about our fake function here. If we run our tests, see that DynamoDB has no object attribute get function. That's because since we've only got one stubber, and even though we're making a second client here, when we're making this second client, we've already told our test to replace this Boto.3 client with this Dynamo value every time. So it thinks that that's a DynamoDB client. We don't want this, so we'll need to make another stubber and update our patch. Through the power of conference magic, I've updated this test to have our new stubber. You'll see first, we're creating a client, much like we do in both our app.py and for our DynamoDB here. We're then adding to our with statement here this stubber lambda as lstubber. This will give us another stubber that we can use within this with block. And we'll scroll down a little bit, and you'll see that we're stubbing this get function call here. We're doing the same sort of deal here where we're not including all of the possible outputs from a get function call, but we're doing what we're expecting and what matters for our test. So we're verifying here that we're using the same input from the app.py fake function, and we're expecting this fake function back. Now, how do we deal with the mocker patching the Boto3 client call? Well, Magic Mock, a feature of PyTest, will allow you to use this side effect here and give you an order for which this call will return values. So the first time we call Boto3 client, it will return Dynamo, and the second time it will return our lambda objects, which we both have stubbers for. So now if we go to run our test again, you'll see we get a passing value. The last thing I'd like to talk to you about today is the importance of the assert no pending responses method within the stubber object. So if we come to our unit test here, you'll see that I've added a couple of new responses, one for describe table for fake table 2 and fake table 3. However, back in our app.py file, we don't actually make those calls. So let's go ahead and run that unit test and see what happens. And it passes because we're not making those calls, so who cares? And you might be thinking to yourself, why bother? What does it matter that these extra responses are here? Think about if your code has branches in it, and you might be expecting a certain function to be called as your code goes down a certain branch. If this passed and your code wasn't called, then you might not even know that there was a failure at foot. So that's where assert no pending responses comes in. If you come down here, you can make some room, and we will do stub dot assert no pending responses, and the same for our other stubber, lstubber, assert no pending responses. Now, if we run that test again, you'll see we get a failure because there's responses remaining in the queue, and this would tell us that if a function we were expecting to be called wasn't called, that it was not being called, and we would be able to go debug what was happening that it was being avoided. So this wraps up what I have time for today, talking about the stubber and Boto3. I hope you enjoyed this presentation. There's many more things the stubber can do, such as defining assertions and exceptions that you should be expecting, and it is a very helpful tool for locally running unit tests on your cloud code. I hope you have a great rest of your PyOhio, and enjoy the day.
Hello, PyOhio 2023. My name is Jack Bennett, and this is my talk, Orchestrating Workflows as a Chronic Systems Problem. Airflow is the modern solution. First question, what is Airflow? The answer from the documentation is Apache Airflow is an open source platform for developing, scheduling, and monitoring batch-oriented workflows. So what's a workflow? A workflow is a set of related tasks that we want to run automatically in a specified order on one or more hosts. So, what's a task? A task is basically something that we want the computer to do. And 3 examples are get a file from S3, export data from a table, process a data frame in pandas. Basically, computer, do this. When we say related tasks, these tasks have dependencies on each other or on external conditions. And this is really where Airflow shines. So dependency, thing 1 has to happen before thing 2 happens. This could be internal to Airflow or external to Airflow. Typically, when it's internal, an upstream task finishes running, and that allows a downstream task to start. In the external case, data arrives, a service becomes available, a server load reduces, or the classic case that we see in cron, as well as in Airflow itself, time reaches a particular point, the clock strikes midnight, and we can run a particular job. Now, here's a case where it's simple enough that we could actually run it from cron. We have a little graph of 4 tasks, A, B, C, and D. A starts when A completes, B and C can start, and then when B and C are finished, D can start. We'd have to wrap these tasks in scripts and manage a bunch of lock files, but in principle, it's possible to do this with cron jobs. Now, here's a case where that would be really terrible. This is a graph of 40 different tasks. The different dependencies are very complex, so it's not something where you would want to do the wrapper script plus lock file cron job activity. It would be really, really quite painful. And this is actually a screenshot from Airflow. It's in this type of complex task dependency situation that Airflow does really well. Here's a comparison of the two. Fundamentally, cron is a much, much older piece of software. It was started in 1975, almost 50 years ago, and it was in a single host environment. It's meant for scheduling jobs, independent jobs in walk clock time, whereas Airflow was first created in 2014. It grew up in the world where web UIs were common, and really an interesting aspect of Airflow is that almost everything is programmable and specifiable in Python. So you can create very complicated graphs of interdependent tasks, which would be really, really challenging, if not impossible, in cron. So it's not that one is better or worse than the other. They're really just two different tools that were created for handling similar but yet not identical situations. Cron is used for running independent tasks in series on a fixed schedule. Airflow is used for running a complex workflow of interdependent tasks. So what's a DAG? This is the conceptual model really at the heart of Airflow. And that is a directed acyclic graph. This is a complicated example of one, showing nodes in the blue ovals and then edges between them showing task dependencies. So if each node, each blue oval represents a computational task, then the edges show how one depends on the other. So for example, 41 here on the left would have to have number 52 complete before it could start. So this is a DAG, or a directed acyclic graph of different tasks showing dependencies between them. Why do we use DAGs? Essentially, it's the flow of time and dependency. We show a graph because tasks are individual nodes and they have relationships. So a graph is the natural kind of data structure to use here. The graph has to be directed because things happen before and after other things. There's dependencies and time ordering. And it has to be acyclic because there has to be a starting point. Cyclic workflow would not be able to start or might possibly never end. That's not the situation we want. So a workflow with a definite start and a definite end has to be acyclic. So let's get concrete for a little bit. We'll take a look at what this actually looks like in the browser. So here is the Airflow UI showing two different DAGs. These are just rows in a table. So we'll click on an example. This is provided within the standard install. So on the left here, these bars represent the time taken by the DAG to execute. And these little squares show success, or in the pink case, these tasks got skipped. So you have a rich capability to control the execution of different DAGs. And you can view it as an actual DAG. Here's the DAG representation of this particular workflow. Here's the code. And so we have Python imports. We have the definition of the DAG in a context. These are individual tasks. And then this bit shift operator shows the dependencies between different tasks. So this
DAG, represented as such, is actually defined completely by this Python code. So we can run this. We'll click on it, hit trigger, and a new column appears here. Light green means it's running, dark green means it's succeeded. It runs very quickly because these are very, very simple tasks. We have a bash operator that runs a bash command. We have empty operators that do nothing. And so this shows how a simple DAG will operate. Here's a slightly more complicated one. And this gives you an idea of the capabilities of Airflow. Here's 40 different tasks in a single DAG. Each of these is an empty operator, so they're individually trivial, but the connections between them are quite complex. We start this, and we can see them running and immediately succeeding. We have a code here showing the standard pattern of defining a DAG in a Python context. And all of these tasks are defined within 20 lines of code. Most DAGs with 40 different tasks would not be so simple because we're not actually making them do anything. But this is a useful way to lay out your tasks before actually going and writing the code within them, to define the relationships between the tasks before the specifics. So that's a quick little introduction to Airflow and the UI. So that was run from Docker. You can see the web UI and some functionality and how workflows are defined as code, how you can view the code, as well as the actual DAGs themselves and how they operate. So what's the architecture of all this? It's fairly straightforward. Over here on the right, we saw the UI and the web server. Under the hood, there's a scheduler and an executor that handles ingesting the DAGs, verifying that they're well-formed, dealing with the database where the metadata is stored, and then parceling out different tasks to different workers. The workers may run on different hosts. So in a large install, you might be running on multiple different virtual private servers or physical servers, depending on your preference. You're going to see in Airflow certain terminology that recurs over and over, including operator, sensor, hook, connection, XCOM, provider, and plugin. We'll take a look at a few of these quickly. An operator is basically a common Airflow task that you've bundled together as a Python class. So the operator is the class, and a task, you instantiate that class and it becomes a specific task. Really, the purpose here is to factor out redundancy for very common tasks. For example, the bash operator we saw executes a bash command. And similarly, Python operator calls a Python function, email operator sends an email, and there are dozens and dozens more already defined operators that you can use for your purposes. A sensor is actually a more specific category of operator. It will look at an S3 key or a Jenkins build or any number of things. You can look at databases or different hosts or an API and detect when a condition is met so that you can then launch a DAG or a task. A hook is an interface, so you can have an SSH hook, a FTP hook, Postgres hook, and these are used extensively within operators themselves. Connections, this is really useful because Airflow has to be kind of this nerve center that connects to so many different resources. This is a mechanism for collecting your credentials to connect to different resources. And each resource has its own unique identifier called the connection ID. And so instead of storing passwords in code or in plain text or other insecure ways, you essentially use this connection ID as a handle to talk to these different resources. So it's a very effective way of centralizing all of these necessary credentials. XComs are an important part because when you specify the DAG in code, that code doesn't actually execute sequentially on the same host. Tasks can execute anywhere. So data created by one task isn't necessarily available to the next task unless you follow this mechanism. You can store data using XCOM push and retrieve it using XCOM pull. And that way tasks that execute on different containers or different hosts are able to communicate and pass data from one to the other. A key thing to note about this is that you should only use it to transfer small amounts of data. You shouldn't be pushing around gigabytes of data between different tasks. In the case of big data tasks, you probably want to write out to a database, write out to a data store or S3 object, something like that, rather than push it through Airflow proper. Airflow is not designed to move around these big data components. Instead, you should use more appropriate tools for that. Alternatively, if you already have a shared data store, you can use that instead, write to that within a given task, and it'll operate the same way for you. So zooming out, what is the big picture here? Airflow is a very active, very well-developed open source project. Almost 800,000 lines of Python code, over 20,000 commits, tens of thousands of stars and forks, and almost 3,000 contributors. It's mostly a Python project, although the front-end UI is written in TypeScript, JavaScript, HTML, CSS, all that stuff that you'd expect. And it's coming up now on about 10 years old. So if you decide you want to use Airflow, how would you pitch it to your CTO? These are points that you might want to make. It's a well-developed open source project, has a long development history, very active user community, a lot of good documentation, tutorials, and examples. There are a lot of resources out there for getting your devs up to speed, and managed solutions are available as well. So it really is ready for enterprise use. It's in use in large and small companies all over the world, and it could be in use in your company as well if you have a need for it. In terms of learning, lots of good references. The official documentation is really good. And there is one published book so far if you learn better through that. Likewise, there are tons of videos, YouTube videos, tutorials, etc. online that you can leverage to learn more about Airflow. So I hope that's been a good introduction. Thank you very much for your time.
Hi, welcome to my PyOhio 2023 talk. I'm going to talk to you about digital signal processing and why you should be doing it in Python as an alternative to the very classic approaches and methods in MATLAB. My name is Meg, and I have a background in biomedical electrical engineering. I've worked in the medical hardware industry, specifically looking at a lot of biosignals and processing them, digitizing them from analog, and making them ready for machine learning use cases. Currently, I work as a research engineer at the Cleveland Clinic, where I also espouse the importance of using Python, oftentimes as an alternative to R. So I'm a big fan of Python, and I think the digital signal processing world can definitely make use of some of the functionalities that have come up in Python and its associated libraries, something I'm going to talk about today. So what exactly is digital signal processing? Digital signals are commonplace. We see them everywhere in our modern world. Some examples include biosignals, and this is really tied to medical applications, such as an ECG or electrocardiogram waveform shown here. We have a electrical activity of the heart that can be measured. There's also signals like electroencephalogram that track brain activity, as well as electromyography, which looks at electrical activity of muscles. So there's different ways of studying human physiology and function through the signals that are acquired. And these, in these particular cases, are analog signals that are sampled and then turned into a digital waveform for us to then study. There are a lot of other signals, though, that cross domains, such beyond the medical domain, such as mine, such as audio signals. And you guys might be familiar with this when you listen to headphones, and they're tuned and they're filtered for different frequency responses. And so this is a very interesting field with a lot of signal processing work being done in the digital realm. Typically, MATLAB tends to be, the electrical engineer's mainstay in this space. There are a lot of specialized toolboxes for filter design, as you can see here, just for visualizing the signal, looking at the different kinds of amplitude changes and frequency responses. We can also perform a lot of signal analysis, and there is some availability of machine learning plugins to also do predictive work. However, I'm in this talk making the argument that Python is really a fantastic alternative. And number one, I'd say it's open source. MATLAB is costly. It also requires installations of separate toolkits, such as the digital processing toolkit, to get your work up and running. And that's not the case in Python. In Python, it's a very simple pip install, which really makes that addition of a new type of analysis you want to do very seamless. It's also the lingua franca of data science. And as our analyses and development of tools and hardware technologies become more data-driven, I think it's very important to keep up with the language most engineers are using. And there are so many fantastic libraries like matplotlib and Seaborn for visualization, NumPy, SciPy, Pandas data frames that have become the norm for the kinds of processing tasks that involve digital signals. The other thing I really like about Python is that it's also ID agnostic, and if you're familiar with MATLAB, that ID, it's not the best, and I think it's a lot easier to also deploy easily in a web app, and much more seamless integration with the kinds of predictive machine learning applications in PyTorch and TensorFlow. So now that I've hopefully made an argument that there are a lot of good things about Python, let's walk through an example of what does digital signal processing look like. So here's an ECG waveform, a raw ECG waveform, so it has not been processed. And what we often see in this kind of waveform is that there are noise sources. So the signal is not as clean because it's picking up during the signal acquisition process sources of noise that could be motion artifact or a power line interference. And we really want to clean that up before we start extracting interesting information from our waveform. But there is a lot of interesting stuff that we can extract and then, feed into ML downstream to classify it. And here's an example of a lot of the features that can be extracted that are of physiological meaning and importance. So the waveform tends to be broken down into these waves, the P, Q, R, S, T, and we can extract things like the QRS complex or the RR interval between ECG signals. And this is very interesting because there's a lot of tooling that allows us to even find, well, where is that peak of the R wave? And in SciPy, there is a function very synonymous with the MATLAB one called find peaks. In scipy.signal.find peaks that allows us to pinpoint that peak of the R waveform. We can also perform filtering, and here you can see the ECG waveform. Originally, the raw waveform is in blue, and then the filtered processed waveform is in orange. And we can remove and smooth out some of those noise sources and end up with a better signal that's easier to work with for any kind of downstream analysis we want to do. An example of a library that is very, very useful for this kind of work is PyWT. It's the wavelet transform library, which actually applies time frequency transforms. So it doesn't just look at the time domain or the frequency domain of the signal, but actually processes it in tandem. It's very, very good for addressing the kinds of noise we see in biosignals that happen during the acquisition process. And that's what we've done here. So I'm going to walk you through just one example of the kind of filtering that's available here in this open source library. So for wavelet filtering, we'll really just start with a very quick pip install of the package of interest and perform a decomposition of that ECG signal to get its coefficients. And this is a very traditional step, if you're not from the signal processing world, to do the processing on the decomposed coefficients. So wavedec is that method that allows us to do that. Moving forward, we then set a threshold, as it typically is done for filtering, and apply that threshold to our coefficients. And here's where reading the documentation of PyWT can be really helpful if you want to make modifications on how it's applying that threshold. So I also really recommend going to the Library of Interests website and reading more about it if the default settings of or configurations of that method are not giving you the results you want. And I think plotting it out using Seaborn or Matplotlib is a really good way to see what's happening to your signal. Next, we then reconstruct the signal. So WaveRec allows us to quickly, very cleanly reconstruct and get our original waveform. And that is what you see here in orange. So beyond things like filtering, there's so much more we can do in Python that are really correlated to the kinds of functionality we see in MATLAB. One is the fast Fourier transform, and I think this is a very classic type of application that I use all the time. And that's actually in SciPy itself, so you don't have to go into another library. You can import FFT to do the fast Fourier transform and IFFT for the inverse. We can also do Bode plots, and this is really fantastic if you're playing around with the transfer function itself. I've plotted a really basic one here, but you can examine it both the magnitude and the phase using like a one line to pull out the magnitude and phase components. And this is just so fast, so intuitive, and very similar to how you do it in MATLAB. Another thing we can do is design the filters ourselves using the signal toolkit. And here I've shown a Chebyshev 1 filter with a few parameters shown here. And it's very easy to quickly plot that, see how it's looking in Matplotlib without having to tinker around with the filter designer like you kind of have to do in MATLAB. So in summary, the classic signal processing methods are available in Python just as they are in MATLAB. MATLAB was built before Python, so the designers of SciPy and all these other toolings have taken the nomenclature of MATLAB. So it's a very easy switch from MATLAB to Python. It's open source, which makes it so much more economical, and it's very, very well maintained. So you're not worried about becoming out of date and using an older version of the software. So I really think there's a lot of positive benefits of making the switch from MATLAB to Python for your digital signal processing work. And if you're new to the signal processing field, there are a lot of fantastic and very easy to learn ways of processing signal for your other types of use cases, such as data science or machine learning applications. So thank you very much for listening, and please do follow me on Medium, where I enjoy writing about these kinds of topics, and connect with me on LinkedIn. Thank you very much.
Howdy, PyOhio. Thanks for tuning in to Storytime at PyOhio 2023. I'm really excited to get to read to you the latest by Dr. Seuss, Mommy, How Are Objects Made? So, let's dive in, shall we? As little Leo Python was tucked up in his bed, "Mommy, how are objects made?" is what he said. "Well," said his mommy, "that's not so easy to say. How would you answer that question on that day?" She thought for a moment on her answer the result and wanted to start with something about consenting adults, but nuance is often lost on the young, so that wasn't something that rolled off her tongue. "Well, first it takes a class," is what rolled off of it. "Oh, I know," said young Leo. "It's dunder init." "Yes, but," hissed his mother as her tongue flicked and twisted. "It participates, of course, but self already existed." "Oh, huh," said the snakelet. "I guess that's true. So who made the object all fresh and brand new?" "Hush," said Mama, "and I'll tell it to you. That object was delivered by the classes dunder new. When a user wants a new object made just for them, the return value of dunder new is what's given to him. A new int, a new elephant, or even a new bagpipe, the return value doesn't have to be of that class's type. And if it isn't, it just goes back to the caller without a gripe. But if it is, then as the new fresh baby object cries, it becomes self in dunder init to be initialized." Leo then asked, "So dunder new is kinda like a stork?" Mama answered, "Yes, I suppose that's true, my little dork." "But Mommy," Leo asked, as children do so often, ask endless questions to their parents until they reach the coffin. "Who calls these methods? Who invokes dunder new in init for me when I type a class's name in a pair of parentheses?" Mommy Python sighed at Leo's endless quest for knowledge. But she answered, of course, because she wanted her babe to be smart for college. "Well, when you see parentheses, what does that mean, Mr. Question-It-All?" Said Leo, and after a long pause, "I think a function call?" "That's right, my dear." Mommy Python was proud of his response. And to understand what function exactly takes a bit of nuance. If something is to be callable, it defines a dunder call. So that's the function that calls those methods after all. Leo continued to question, "But isn't dunder call a class's magic method? So what's the callable object here that is being requested?" Mama Python exhaled, took a very long pause, then took off her glasses, Everything comes from something. Objects come from classes. Classes are objects too, so they come from metaclasses. The type class itself is the most common metaclass of all. So the parentheses are handled by its dundercall. To make an object the type has the wherewithal. When invoked, its first responsibility is calling dunder new and choosing whether to return. The value is to dunder init pass through. And finally, back to the caller, the value is returned to. Oh, wow, said Leo as he yawned. His imagination started to swell. But does that mean when my class's types instance was constructed, it did this dance as well? Well, yes, but also no. Please stop, was Mommy's response. The question soured her mood. Metaclasses types can't really be changed, so that's where the type chain concludes. Now, since thinking about metaclasses very often raises one's cortisol, Mama Python was relieved to see at last Leo's eyelids fall. And so, my friends, please do take it from Leo's sweet, wonderful mum. It's probably best not to think about exactly where objects come from. The end. Thank you for tuning in and listening. Have a great rest of your conference.
Hey everyone, my name is Kaushik, and I'm here today to talk to you about serverless Jupyter Notebook functions. So a bit about me, I work at Microsoft on the Azure Cosmos DB team. You can find me on GitHub at KOEK67, and I also have a blog where I write about systems programming, Python, and a little bit of Zig. So we're talking about Jupyter Notebooks today, and I just want to give a shout out for how awesome they are. They are a great way to take your code and turn it into this interactive document with charts, tables, and other kinds of visualizations. Great for learning. It's got excellent tooling. It's very easy to debug code in this environment. And if you have not used a Jupyter Notebook yet, I highly recommend you try it out. But the problem comes when we want to take our notebooks to production, or really when we want to share our notebooks with anyone in general. The way that you would have to do this is you either can ask the person to download your code and download Python and download all the dependencies that are required to run your notebook, or you can take your notebook code and deploy it as a web service in Heroku or Azure Functions or something like that. But when you do that, you end up losing a lot of the cool things that make a notebook awesome. So what I wanted to do is find a way to bring Jupyter Notebooks to production without losing the cool parts about the notebook. And that's what I'm here to talk about, and we're going to talk about JupyRest. So JupyRest, it's a Python library that can convert your Jupyter Notebooks into serverless functions, essentially REST APIs. It lets you define inputs and outputs for every notebook. And just a little background, this has been something I started at Microsoft, and it's been in production since 2020. And we do have it on GitHub. You can check out the link on the screen there. So getting started is real simple. You do pip install, and then you run this command here to start the web server. All you got to do is give it a path to where your notebooks live. And that's pretty much it. So rather than go through a lot of the things that are already written in the documentation, I'm going to make this talk very demo focused. And if you want to know about how any of the specific features work, I highly recommend you go check out the documentation on the GitHub. All right, so let's take a existing notebook and see how we can turn it into a REST API with JupyRest. I have a very basic notebook here, and the first thing I'm going to do is to designate my parameters cell. So we can do that by adding this cell tag. This will basically tell JupyRest that this is where all of our inputs live. So for this notebook, we have one input and its name. The next thing we need to do is to define what our outputs are going to be. So when I mean outputs, what I mean is, think of it like a API response, or maybe like the return value of a function call. So to do that, we will import this save output function from JupyRest, and then we'll pass in whatever we want our output for this notebook function to be. So once that's done, you can save that. The next thing we'll need to do is to include this config file alongside our notebook. The config file has 3 sections. So the first one here is the ID, which is the name of the function itself. And then we can also define an input schema and output schema. These are written in JSON schema specification, like OpenAPI and Swagger. These are optional, of course, but any well-designed production web API should have a input and output schema for all of its endpoints, so that's why we have that here. Once that's there, we can open up our little web page here. This is actually included with JupyRest when you install it. And here we can select our notebook and then execute it with certain parameters. So I'm going to do PyData Ohio. Oops, my bad. PyOhio 2023, like PyData as well. So we have that, and let's submit the execution here, and I'll show you what we get back. So execution's finished, and we get 2 links here. The first one is the HTML. So let's take a look here. This is the executed notebook in HTML form. We see here that our input parameters have been converted into a code cell and injected into the notebook. So, that means that our notebook is now using name with the value that we passed in, which is nice. The next thing we'll look at is the response. And so this is actually the API response for this notebook. And you can see here that we have this output object here. And this is exactly what we sent in through that save output call in our notebook. So whatever we put in the save output call will show up here. And there you go. We've basically turned a Jupyter notebook into a REST API just with that. Another cool thing that you can do is, if for whatever reason you have some error in here, like a key error, then when you execute the notebook, you'll get the failure, of course, but you can also view, instead of having to wire up any kind of telemetry or logging system, metrics, Prometheus, all that stuff, you get that stuff for free, because I see the notebook's failed, and then I just have to open the notebook by getting the HTML output, and I can see the error here right in my notebook output, which is nice. So next, what I'm going to do is take a little bit of a more involved notebook and show how we can turn that into a notebook function. So I've taken this portfolio analysis notebook here from this GitHub repo. It does some cool stock analysis here, and it's got some graphs and charts. So when we take a look at this notebook, I've made a few changes here. The main one being that when I've defined my parameter cell, I've actually defined it using a Python object. So the input to the notebook is actually a Python object. It's this portfolio object here that has a start date, an end date, and some holdings. Plain old Python object. And then in our config file, what I have done here, I don't have an output, so I don't need to specify an output schema. The ID is portfolio analysis. And for the input schema, I'm actually referencing something here. This described more in our documentation, but basically what I'm doing is I'm referencing the schema of a Python object in my code. And this is helpful because when you have lots and lots of notebooks, you often want to share input and output schemas across those notebooks. And so this gives you a way of actually using your code and using it to define your function definition, your notebook function definitions, which is a great way to make scalable notebook development here. So that's what I've done. Now that I have that, let's go ahead and execute this notebook. So I've selected portfolio analysis here from the top, and I'm sending in my own parameters. It's basically the same as what I've done in the notebook, but I've just made Apple half of my portfolio because I'm really smart at trading stocks. So let's execute it. Actually, instead of waiting for this, I have, oh, actually it's done. Let's take a look at our HTML, because that's really where the cool stuff is. So what you can see here is this cell here. This is where these are our injected parameters. What you can see is that our request, our input here, which is JSON, has been automatically converted into Python code using the Python class that I wanted to, in our notebook, which is fantastic because I don't have to deal with JSON serialization, deserialization, or anything like that in my notebook. My notebook can be written without any knowledge that it's being used as a REST API. So this is a cool feature of JupyRest that has been very popular at Microsoft when we have so many different notebooks that we're trying to deploy and run. But it lets you use plain old Python code inside your notebook, and then from a client perspective, you can call these notebook using your own HTTP client using straight JSON, and everything in the middle just works as is. So that's pretty much all I had for my talk here. I wanted to say thank you all for listening and coming and attending PyOhio. It's been a lot of fun. You can find me on LinkedIn here, and again, this is the GitHub link to the code here. And yeah, go try it out, install it. Let me know if you like it, and yeah, have fun writing those notebooks, everyone. Take care. Bye.
Hi everybody, thank you for coming and attending this talk. I'm so grateful to be here, and thank you to the PyOhio team for giving me this wonderful opportunity. Before we get to the main presentation, let me quickly introduce myself. Hi, I'm Ria, and I'm currently working as a software engineer in the fintech industry. Over the course of my career, I've worked with multiple database systems and evaluated different technologies. I particularly enjoy sharing my learnings and knowledge with the community and breaking down complex concepts into easy, understandable bits. I'm also very passionate about organizing outreach initiatives for women in STEM and giving back to the community in whatever way possible. When I'm not involved in any coding adventures, I love to read fiction and play music instruments like the ukulele and the harmonica. So about 3 years ago, when I started my journey in the professional world, I quickly realized the importance of communication. Throughout my career, I've seen that it is not just important on what you work on, but it is equally important to be able to share and communicate that with others. Be it the exciting new feature that you're building or the super cool product, if other people don't understand it, it's probably not good enough. And improving your communication skills will open many doors for you in your professional career. Which brings me to my next point, that documentation is communication. I feel that it is one of the most important aspects of software development, and we developers often view it as the unnecessary, boring post-coding task that just needs to be completed. But trust me, documentation is more than just information. It's a way of communicating understanding. But the question is, why should I care? And to convince you, I have picked up some points that have personally benefited me. starting with knowledge sharing. So whenever I have to start a new project or work on something that I've not worked on before, it's the well-written docs that come to my rescue. They help me get started, make progress, or get unstuck. And when members of my team or new joiners come and thank me for the docs that I have written, it's honestly a great feeling. So documentation creates a knowledge hub that not just guides you, but also others in their career journeys. And trust me, all it takes is just that one call in the middle of the night that makes you realize the importance of documentation when you have to solve that production issue. So well-written documentation is crucial for essentially resolving the annoying bugs and issues. And also, I know many of us feel that holding the code hostage where only we understand what it can do and how it behaves is a power move. But trust me, it'll backfire sooner or later. In fact, you should do just the opposite. You should set it up in a way so that others, not just developers, but even non-technical people can understand it. With this transfer of ownership, delegation, you are able to take up new exciting projects and others are able to help themselves. And most of the times, the docs that I have written have been so helpful for me. When we are resolving that painstaking, annoying task, we assure ourselves that this is something that I'll never forget, how I conquered this. But trust me, we always do. And at that time, documentation comes to our rescue. It's a lifeline for your own memory. It not just guides others, but also you. It's for future you. So document all the pain areas that you felt while getting unstuck from that issue, or the number of steps you had to navigate through to reach that solution. Documenting that will be a savior for you, trust me. And finally, showcasing your work. It just enhances your work visibility at your workplace. It tells others what you have worked on, but also instills their faith in your ability to be able to explain the concepts in an understandable manner. With this, I hope I was able to convince you how important documentation is. And now I want to share the top 10 tips that I have learned by writing multiple docs or from others, and hope they are helpful for you. Let's get started. Starting with the first, conciseness matters. Users appreciate clear to the point information. When you open a document, you don't want to get overwhelmed with the information that you have to deal with. You should aim to write the shortest, most practical self-contained document. I know, easier said than done, but that balance is very important. Too long, nobody reads it. Too short, it doesn't cover the important aspects that the user needs to know. In some cases, length doesn't matter. You can write lengthy documents like tutorials or when you're documenting a feature, but in other cases, try to avoid unnecessary details. Try to supplement it with links which the user can go and follow and read what they want to know from there. Maybe you could have a prerequisite section at the top of your documentation that would help the users get started and then proceed with the document that you have written. Prioritize readability. Your document becomes 1,000 times better when it's more readable. Nobody wants to read a blob of text. Your documentation is not a novel. So it is very important to prioritize readability. And I've read this somewhere that users often scan that read. Whenever we go to the Stack Overflow website, we don't even read the question sometimes and directly search for the answer that will help us get unstuck. A beautiful way of prioritizing readability is through lists. Firstly, they are simple. You can organize your ideas clearly. Your readers won't get overwhelmed, and they will in fact appreciate you for the clarity and the ease of understanding. Other things that you can do to focus on readability is have a table of contents in your documentation. So as I just said that users don't read, they skim through the document. Table of content will help them understand if the documentation is useful for them or if they'll find what they are looking for. Using headings and subheadings that relate to the content of the text. Having cool funny subheadings is nice, but at the same time, they should highlight what the text is all about. Using spacing in your favor. Having properly spaced document doesn't make it overwhelming and it's more readable. Using bold font for keywords. You use bold to grab attention of the user, telling him or her that this is something that is very important. But don't overdo it. If everything is highlighted, then bold loses its purpose. Use visual aids wherever you can. So, I honestly love to add screenshots or diagrams, which wherever I can in my documentation. And I think that really enhances the readability and the overall user experience of the docs. Format your code samples. I think we all know that. Consistent indentation, proper syntax highlighting, a beautiful example there on your screen. Do this, don't do this. Properly indented, clear what it's trying to communicate in proper boxes. Just like that, the user can come and skim through the information they are looking for and use the code for their own purpose. If you have a command, add that to a separate box. Maybe that'll also make it neater and cleaner and easily scannable. And it'll just help the user find the information quickly, what they are looking for. The next point, I think most of us struggle with it, at least I do, understanding the audience. Sometimes it's not very clear who will read this documentation. Is it just for the internal team, or non-technical people would also be reading that? If it's just for your team, of course, go ahead and write it the way that you want to. But if you do not know who your audience would be, always assume it to be for beginners and write it in a beginner-friendly manner. What that means is avoid technical jargon. Don't assume that your readers are familiar with industry-specific terms. Define acronyms. For example, rather than saying it's an RPC mechanism, say that it's a remote procedure call mechanism, so that at least you are telling the user what that acronym means. And if possible, link it to another document so that they can go and read it themselves. It is very important to keep the flow simple so that the users are not overwhelmed with the information they are dealing with. Because simplicity always wins. Opt for simplicity over complexity. Straightforward, easy to follow language always for the win. An example on your screen, avoid using complicated language, complicated keywords. You are not giving a GRE exam. This documentation's purpose is to be able to make other people understand about what you know or what you have worked on. And it should be written in plain, simple language. Many of us are not even native English speakers, so for us to understand that would be difficult if we use complicated language like that in the example above. Use plain language. One of the other points that I wanted to highlight is that when we are starting to write the document, oftentimes we are just overwhelmed or intimidated by looking at that blank page, that how should I exactly start? A tip that has worked for me is that I just convince myself that the first draft would be bad. And that just helps me get out of that perfection rut. So that helps me basically to define the outline, that what exactly will this document contain? Do I need to have a prerequisite section? Who is this document for? What is the aim of this documentation? And post that, once I start writing, I continuously keep refining it through multiple iterations, and trust me, it gets better. But the first draft, let it be bad. It's okay. Also, write in a way that you speak. So write in a conversational and approachable tone. Imagine you're explaining the information to a colleague in just that manner. I mean, I use you a lot. You will go to this page, a drag down would appear, enter the configurations over there. Keep the tone conversational and approachable, because remember, this is also for the future you. The way you have understood that concept, later when you revise it, it'll be easier for you to remember what you had learned. So document with future self in mind, because trust me, this document would come as a savior, as a lifeline for your own memory, as I discussed this earlier. So keep yourself in mind while also documenting, and use easy straightforward conversational tone in the documents. Trust me, that will help you and the people who are reading it. Finally, seek feedback and test. Feedback can reveal areas that need improvement. So, oftentimes we just assume, oh, this point, everybody would know that. I don't need to elaborate or highlight this. But getting constant feedback from your juniors, seniors, or whoever is using that documentation can reveal those gap areas. And you need to constantly update that documentation in order to make it better. Testing and verifying the instructions that you have added to your document is also very important. While somebody's using your documentation, following a tutorial, and they are stuck somewhere, it's honestly a very frustrating experience. I'm sure you can relate too. So test and seek feedback, constantly refine it, and I'm sure your documentation will get better with each iteration. So, concluding with this, I learned to write by writing. Practice is what you need. The more you write, the more you get better. I still am learning new best practices, making some mistakes, improving those, and trust me, getting better and better as I write more. So I wish you happy documenting, and thank you so much for coming and attending this talk. I'm happy to connect. If you have any feedback for me, any questions, please feel free to reach out. Or if you just want to bond over tech, books, or music, happy to connect. Thank you so much and have a wonderful evening ahead.
Good documentation shows users your software, but interactive documentation gets them hands-on with your software right away. Hi, I'm Jeff Glass, and today let's look at making your existing documentation interactive with PyScript. I should say right off the bat, all code, slides, and demos for this talk are available at jeff.glass/PyOhio 2023. We'll talk today about what PyScript is, how to integrate it with any HTML-based documentation system, specific plugins for mkdocs and Sphinx, publishing to GitHub pages and read the docs, and we'll wrap up by talking about all the things PyScript can do, plus a few that it can't. So what is PyScript? PyScript lets you write Python code into your HTML. If you include PyScript on your site, any Python code inside of a script tag with a type of py will be executed in the user's browser when the page loads. There's no cross-compilation to JavaScript, no pre-compiling. It's the real deal CPython interpreter compiled to WebAssembly, shipped to the user's browser, running real Python code in the page. There's no special backend server trying to run user code in an isolated way. All code is run client-side in a fashion sandboxed by WebAssembly, which makes it a great match for static documentation builders. We can't fit a full PyScript tutorial into this talk, so here's the basics. To install PyScript, simply add a script tag with a type of module to your page that points to the latest version on the PyScript CDN. That's it. Any script tags with a type of Py will then run Python code when the page loads. To install Python packages at runtime, include a pyconfig tag on your page, whose contents can be either TOML or JSON, your choice. Either way, the packages key is a list of packages on PyPI you'd like to install, or URLs of wheel files that you've built yourself. Some of the PyPI packages have special pre-built versions that are meant to work with Python on the web. These will be automatically installed for you if you give their names. One last thing. The PyEvent syntax is used to hook up Python functions as event listeners on HTML elements. For instance, this bit of code uses the PyClick attribute to hook up the foo function as an event listener on this button. The foo function will be triggered whenever the event click is seen on that button. With those techniques under our belt, let's use PyScript to add some interactivity to a generic piece of documentation like this one, with some sample code blocks. Wouldn't it be nice for the user to be able to run that code immediately in their browser? Let's focus on just the first code block. The code for the site will be on the left, and the live example will be on the right. In this first demo, this is just a static HTML document that we've written by hand. Let's add some PyScript to it. To run PyScript on a simple page like this, first make sure the script tag which loads PyScript is present on your page. Next, write some Python code inside of a script tag with a type of py that achieves the effect you want to see. In this case, we'll just use the same code from the code block above. Now, it would be nice if this code ran when the user triggered it and not just on page load, so let's add a button to the page, which we'll label run code. We'll wrap our previous Python code in a function and have it exec our previous code snippet. Then we'll add the PyClick attribute to the button to execute the named function when that button is clicked. Finally, we'd like our results to appear on the page, say in a div with a specific ID. PyScript includes a utility function called display, which is exactly for this purpose. Inside our code snippet, we'll import display from the PyScript module, then call it to send our output to that div. Notice how the target argument to display matches the ID of the element where we want the output to appear. To make things even more interactive, we can use an editable area where users can enter their own code. We'll replace that code block with a text area, then modify our function so it grabs the contents of that text area and executes them. This is really just scratching the surface of the possibilities of interaction between the browser window and Python, but long story short, you can basically interact with any browser or JavaScript object from within Python. Really cool. That's the most basic version of PyScript integration, running some hard-coded or user-inputted code in response to some events. But thankfully for those of us writing documentation, we have much more advanced tools than handwriting our HTML nowadays. Let's look at two popular tools, mkdocs and Sphinx, and see how we can use PyScript within those. Here's a basic mkdocs site with the same example content as before. We'll install the mkdocs PyScript extension by running pip install mkdocs-PyScript, or install it in your virtual environment of choice. Then inside of mkdocs.yaml, add mkdocs PyScript to your plugins key. By default, every code block with a language of Py or Python gains a load button. When clicked, that code block is transformed into a runnable code editor where the user can look at, modify, or write their own code. When the run button is clicked, that code is executed using PyScript. In this case, it's actually run in a separate worker thread so as not to lock up the documentation's UI, no matter how bad the user's Python code is. There are a couple of additional configuration options that can be set in mkdocs.yaml. The PyScript version key specifies, unsurprisingly, a specific version of PyScript to use. Say if you want to run the bleeding edge unstable builds or a specific technical snapshot. The selective option means that only code blocks with the additional PyScript class will have the option to be loaded as editable code blocks, and other Python blocks will be ignored. This is nice if you only want users to be able to run some of your code. And it's just that simple. One plugin installation lets users run code inside your mkdocs site. The installation process for the Sphinx PyScript extension is similar but not identical. With a Sphinx site set up, run pip install Sphinx PyScript, or install it in your virtual environment of choice, then add Sphinx _ PyScript to your extensions list inside of conf.py. The Sphinx PyScript extension adds several new directives, which can be used inside of the restructured text format to add interactive elements on the page. Use the pyrepl directive to add an interactive code editor, whose output attribute specifies where the output for the editor should go on the page. You can also use the pyterminal directive to add a terminal to the page, similar to a console. Feel free to sprinkle these liberally throughout your Sphinx documentation. Once again, with Sphinx, it's pretty straightforward. Add one plugin, and away you go. Let's talk about deployment. Because PyScript runs in the client's browser, it can run pretty much anywhere you can host a static site. In fact, all three of the demos we just looked at are running live right now in some version of static hosting. The vanilla HTML demo lives in an AWS S3 bucket. It's literally just an index.html file, and that bucket has static site hosting enabled. No additional configuration is required. The mkdocs demo is running on GitHub pages, again with no further configuration required. If you use mkdocs' gh-deploy command, you could be running PyScript on your GitHub pages right now. Finally, the Sphinx demo is running on readthedocs. The only configuration required here is that readthedocs needs a requirements.txt file to tell it what Python packages to install so it can build your site. In my case, just Sphinx, Sphinx PyScript, and the readthedocs theme. As you can tell, PyScript will run under just about any kind of hosting. There are lots of Python things that just work in PyScript thanks to the amazing work of the Pyodide team upstream of us. Under the hood, PyScript uses Pyodide, which is the CPython interpreter compiled to WebAssembly, plus an FFI layer which handles all that cool interacting with the browser stuff. PyScript can also use MicroPython compiled to WebAssembly, but for today, let's take a look at what parts of CPython do and don't work in the browser as it relates to your documentation. Almost all the Python standard library works, with a couple of key exceptions I'll talk about in a sec. The scientific computing stack, like pandas and NumPy, works fine in PyScript, and lots of additional Python utilities, like OpenCV or Pillow, display widget packages like Bokeh and Panel, Python tools like PyTest and MyPy, all work fine in the browser. That said, there are some limitations worth noting in basically 3 categories. First, you can't spawn additional processes or threads from Python, so packages which rely on the threading or multiprocessing modules may need to adapt to a single-threaded environment. Second, because the browser is not a typical operating system, packages that rely on the OS's window or UI tools like tkinter, turtle, or curses are unlikely to function in the browser. And finally, client-side code running in the browser doesn't have the same ability to make network connections as Python does running in a typical OS, so opening sockets isn't possible. If your code relies on the requests or URLlib packages, I recommend looking at the pyodide-http package, which monkey patches requests and URLlib to work in the browser, but opening sockets and SSL are right out. Other than that specific limitation, though, the sky's the limit. Whether you're crafting your documentation by hand or using tools like mkdocs or Sphinx, no matter where your documentation lives, your users could be running code and learning better with PyScript. Thank you. Again, all of this talk's slides and demos are available at jeff.glass/PyOhio2023. Also on screen now are all of the other places you can find me on the internet. And hey, go run some Python in your browser.
We're going to talk about slaying software zombies. So, because I'm registered with the SEC, Optimal Investments here are some disclaimers. I'm not giving you financial advice. Alrighty, so the conceit of this whole talk is that metacode, so the things that are associated with your code, like docs, tests, configs, requirements, etc., are organic the same way that code is. They grow, they rot if they're left unattended, right? They have another function to them that make them, I think, even more challenging. Whereas if you go the agile methodology route and you say the best requirements are a working piece of software, you don't really have the same sort of thing with the metacode. So you can get to a situation where things represent parts of the truth that are in various different parts of the metacode or the artifacts in the metacode, right? So like a ticket, for example, may describe a system that was accurately described 2 years ago, but doesn't describe what it is now, but it's still lingering around. So it can be difficult to figure out what really is. I think this gets especially tough if you iterate a bunch, as you're supposed to in Agile. Don't worry, if you are a proponent of waterfall, you get the same boat because your software doesn't wind up looking anything like the stuff that you spec'd out in the beginning. So there's no real win there, right? The other, I think, interesting observation is that it seems like metacode grows exponentially. It seems like to me, along with the code base, particularly as companies mature. You've got more communications overhead, more need to do things like document things or run a process. So as a result, you really see this acceleration to what I term the zombie apocalypse, where you've got all of these partial truths that are sitting out around here, and you can reach a sepsis point at which the whole system collapses. So what could this look like practically? Maybe you've had one of these cases where you overwrite a config that with the stuff that's in your IAC repo, and you wind up having an outage because someone did something on the fly, or you wind up having automated test suites balloon around testing functionality that no longer exists or no longer is valid. Similarly, you can do this when you're patching vulns on projects that you may not need the functionality from, or where people can't stand up a service because it was documented incorrectly. I know that's super frustrating for new hires. So, getting to the core of what I am suggesting, at some level, there is sort of an underlying platonic truth, a description of what the system ought to be doing or is expected to be doing that lies at the center of all of the metacode and the code itself. So, tap into that, allow that platonic description as it changes to propagate those changes throughout this larger behavior graph. And I use the term controller, where you can think about it kind of like a control loop. So as you're iterating, whether you're doing this in an automated or a manual sense, you're going to continuously update those pieces. All right. So if you've heard this kind of behavior graph or the abstraction I'm describing, it may sound really familiar if you remember BDD and the Cucumber era of, say, 2010, I think, roughly. So BDD using examples at multiple levels of the system to create a shared understanding, and using that also as a bludgeon to try to surface uncertainty around how the system ought to behave. And we'll get back to BDD in a second. But the point being, this is not a new thing, right? Another diagram I feed from the internet, pointing out that examples, tests, and requirements are all interrelated, and they all kind of change and morph again. You can imagine, again, propagating. Let's say you have a new example that covers something you didn't have. Well, that propagates through to your tests and your requirements. I'd also include things like user-facing documentation, and also other things that are searchable, like PRs and tickets. Tickets are particularly interesting because they're usually showing a defect in implementation or a system not behaving the way that you would expect it to. So you can kind of, through implication, figure out what the system behavior actually is supposed to be. And I did want to show this. Kubernetes has a beautiful operator pattern where it uses controllers in order to control the drift of all these different interrelated pieces of code. So at some level, we already do have a structure that we can use to control drift that we can tap into. All right, so practically, how do we fight these zombies? I'll show you sort of 3 sections of this, and hopefully they'll be useful. The first is paring down your metacode. All right, so I think, like with everything else, this is definitely one of these 80-20 rules. Think about where the metacode that you have is best utilized. Oftentimes people think about this in terms of testing. I think that's that's one of the pieces of metacode. So it's a useful way to step into it. But you can think about it in terms of the documentation or whatever else that goes with it. So I always think about, hey, where am I trying to build trust with users? Because I work on a commercial product. This might be different. Your mileage may vary, but we'll use that. So where you have user-facing documentation, including how you go through a workflow, or if you have a library, you're providing examples for it. Hey, those are pretty good places to make sure that, if you're telling to the world that this thing works this way, that it actually does work this way. Another place, startup steps. If you're onboarding a new user and it doesn't work the way that they expect, or you have a new developer that can't get a service started up, I mean, those are places where people are already somewhat tenuous. Definitely, I think, worth typically investing the extra time. And then a couple areas we'll talk a little bit more in the context of this I think interesting book and article. Areas that are prone to change, places that are complex or really matter, and also areas that don't change much at all. And this book is called Your Code is a Crime Scene. And a lot of it is trying to, the author describes, intuition not scaling, and then the complexity measures that they use not working well enough. So having to have some other set of heuristics or tools to identify places where, you'd want to put your next incremental test. And I think, he lists out these three ideas or questions rather that should be answered. I think really interesting points out that there are 2 good predictors of bugs. One is the number of developers working on a module, and the other is the number of revisions. And I add a third one to that, which is areas where neither of those things are true. Those are areas where I think you definitely want to test or document. You get into those sort of bus number problems, where someone has never touched this piece of code or the system, and then it falls over, and you have no idea how to get yourself back out. So I'd add to that a little bit. So he's got this cool tool. I don't recall it working the last time I tried it, but that was a long time ago. But anyway, assume that you did. You get this really cool graph. I believe these are modules, and the individual items in there are methods. The height of the graph being the number of changes that happen, and the color being the number of authors. So visually, you can see within this code base where the next place you likely would want to put tests, or by extension, documentation or examples. All right, let's talk LLMs. I think of LLMs as being translation machines or like really enthusiastic and experienced interns. So what does this matter in the slaying of zombies? Well, you can use an LLM to better help you update items across this behavior graph. It's very useful for that sort of translation piece, because again, it's like that old adage about the elephant. People touching different parts of the elephant. Those are the different pieces of metacode that are coming together holistically to form your description of the system. So here's a practical example. At Opto, we had a whole bunch of playwright tests, which are in-browser tests like Selenium or Cypress. And I found this, this repository when someone left of, dozens and dozens of these, say, 700 to 900 line long TypeScript browser tests. And I discovered them because they were flaking out and were slow and were causing all sorts of problems. So here's an example, real example of this test to check whether a loading state was being brought up when something was loaded. They're spinning up a whole browser and spinning it back down to do this. It was failing 10 times a day on average, and that resulted in 300 minutes of developers waiting around for something that wound up failing and having to rerun it. So I thought that was kind of ridiculous. So I wanted to look holistically at, like, hey, are these tests worth the effort? And also, what kind of coverage do you have with these tests, which is actually a lot harder to do with these browser-based tests than if you were using a Jest or a PyTest or something like that. So I wrote this. I thought this was kind of a cool way of approaching it. I iterated the test files and then sent them to a GPT model with this prompt here, but basically saying, hey, can you describe to me the feature that you're testing, right? You iterate through. I dumped the description out to Markdown. I served it up with stuff that I also had ChatGPT write. And of course, I used Midjourney to make a cool image. Irulan, who is the biographer of Paul Muad'Dib for you Dune fans, and it produces this thing here where I've had to excise a whole bunch of the names of tests, but you get the gist, right? And here's an example of the workflow that it's able to develop. And I found this to be really useful, right? This is now translated into a language that I could use to assess what's actually going on in the workflow that's being tested, and kind of compare that to the workflows that I see actual people using. In this case, yes, certainly. You can extrapolate to all other things about how you would break these tests down into integration or unit tests, or data table tests, or where we should have been testing on the API level. But it was very interesting to go across the code base and realize, like, hey, places where, for example, it said we were testing such and such a dashboard, the test only made sure that the page loaded, right, or loaded without error. And other places that had this, this very significant description of an actual workflow that a user might do. And that got me thinking about living documentation. That's where we're going to turn to BDD. So here's that tweet again, BDD in a tweet. So basically, specification by example that's also testable. And part of the core here was this idea that you could use the language of the business domain so you can engage with business users in terms of writing a test and building or writing tests that verified that you had built a system that met with their expectations about what it did. And it was really cool a while back to find, hey, living documentation really is a thing. Here's an example with Concordian. You can see how it's set up. The examples here, they get translated into Cucumber tests, and they're sparsed within within the documentation of the product. So what's challenging with this, and why, as cool as I think that this is, to have your documentation generate your tests, it's going to generate your tests that are heavily reliant on regex. There's that old adage that if you solve a problem with regex, you have two problems. It got pretty messy and unwieldy, when I've seen Cucumber suites grow. So what is cool, I think, to kick around is this idea that you can use an LLM rather than a regex to do some of this updating. So here's an example covering the prior one of GPT models producing a data table test in the Python version of Cucumber, Behave, that uses the underlying large language model instead of regex, do that matching for you. So you can imagine a system like this where you're like propagating changes in the system behavior automatically through to generate the tests, or as I showed you, from the tests to propagate back through to generate the living documentation. You can imagine a whole bunch of other methodologies using LLMs and knowledge bases to try to create like a more holistic view of that sort of behavior graph that I was describing and make this all better. Okay, so much of the work wasn't mine. Well, most of it was whatever it is. Lots of people helped me. It was awesome. I'm tongue-tied. These Optonauts are fantastic. And here's where you can email me, pk@optoinvest.com, and some AI-generated Pythons because they're cool. Alrighty, thank you so much for your time. Look forward to seeing you all in person when this isn't virtual in Ohio. Cheers.
If you ask me, what's my favorite feature in Python? It's f-strings. If you don't know what f-strings are in Python, you're listening to the right talk. By the end of this video, you will know a lot more and you'll be able to start using f-strings like an expert. If you're already using f-strings, that's great. But did you know that there are more to f-strings than simply sticking variables inside curly braces and adding f in front of a string? Stay around so you can learn more. In Python, f-strings is a way to format strings, and you can start using f-strings in Python 3.6. Say, you're writing a script for sending emails and the content of your emails are all the same, but you want each of the email to be addressed to different people. You can do this kind of formatting using f-strings. For example, I could define a variable name, which could be the name of all the different people who I want to send the emails to. Then I would have another string as a template, and on this template, I would put an f in front of it. And inside this string, the part where I want to replace the name variable, I would put that variable and put a curly braces around it. So, when I print this template string, I would get the string with the name replaced accordingly. So that's a quick example on how f-strings work and how string formatting works in Python. So there are two parts of an f-string. Well, three if you count the f itself. F-string contains something called an expression. So basically, the thing inside the curly braces, the variable, this is called an expression. And everything else, that the things outside of the curly braces, the part of the string that is not a variable, that is called the literal. In my earlier example just now, I used a rather simple data type as the variable. Basically, I showed you an example how to put a string inside another string. So it looks more like combining strings together. So it's really basic examples. So now I wanted to show you some more interesting examples for using f-strings. For example, if you have a dictionary, you can pass the dictionary keys as f-string expression. You can also pass in objects or functions or methods. You can actually put in all kinds of data types into the curly braces. Now here's an interesting part about f-strings. Some data types in Python has a very special superpower when used in f-strings. For example, the datetime object. Sometimes you wanna display your datetime objects in specific format, like the month, year, day, as a string. Before f-strings, you might be using something like the datetime stirftime function to do that. And when you use the stirftime function, you would need to pass in the datetime format like %d, %m, or something like that. And after f-strings, you might be tempted to just put that whole thing as an expression inside the curly braces. That will work too, but there's an even better way to do this. So instead of using the stirftime function inside the expression, add a colon and then the datetime format. And this is how you would do it with f-strings. So what is this magic? This is one of the lesser known feature in f-strings in my opinion. This is called format specifiers. And you can read more about it in the documentation for format specification mini language. And you can do this with numbers. For example, you can use f-strings to format floats and decimals. You can use it to round numbers or to display percentage value. You can also use format specifiers to path strings. So there are a lot of interesting uses of this. So check out the documentation for format specification mini language. I know you all are debugging your Python code by using prints. I hope you're also doing interactive debugging using breakpoints, but there's nothing wrong with using print functions to debug your code. We all do it, I do it, and f-strings can help you with that. So, when you're printing and debugging, sometimes you wanted to know in your string, like you want to know the value of the variable, but you also want to know which variable was that was being printed. F-strings comes with something called debug mode. All you need to do is add an equal sign to the expression, and then it will print out both the expression and the value. And you can only do this if you have Python 3.8 or newer. Python 3.12 was just released in October 2023. There are new capabilities in f-strings in Python 3.12 that weren't possible before, so don't miss out on those. Let me share you some of the new features there. You can now reuse the single and double quotes within f-strings. Before Python 3.12, you can use the same style of quote inside the expression of the f-strings. For example, before, if you must do something like this, like if you opened your f-string with a double quote, then inside of the expression, you must use a single quote. Starting in Python 3.12, you can reuse the same quote style inside f-strings. So you can keep a consistent style and not having to mix things up. Before Python 3.12, you'd get a rather generic and cryptic error messages if you have errors when using f-strings. In Python 3.12, the error message will be more descriptive, so it will be more useful to you. It can help you with debugging errors with f-strings. You can now have nested f-strings in Python 3.12. Though I haven't personally found the need for it, but you should know that this is possible. If you do end up using this, let me know. I'd like to see what you do with this. Comments are now allowed inside f-strings expressions. This is another new thing that just wasn't allowed before. You get an error if you try to pass in the hash symbol in f-strings expression. But this is now possible in Python 3.12. But pay attention, you must do this as a multi-line expression, and your closing bracket must go to the next line. And the reason that it must go to the next line is that anything after the hash sign in the expression will be treated as a comment and will be ignored, even if it contains the closing bracket. Here's a fun, interesting trivia for you. You can use uppercase F in f-strings just for fun. I don't know why you want to do it, but it's fun. It's completely valid to use uppercase F in f-strings. So now you know. I hope you learn a lot about f-strings in Python now. My name is Marietta. Thank you for watching.
Hi, I'm Richard Shadrack, and in this talk, I'll be doing a brief demo of a package I developed as part of my work at 8451 called PyTest NDB. NDB here stands for Notebook Debugging. It allows you to run a PyTest test in a notebook and capture all of the local variables in that test so you can interactively debug them. First, I'll get into a little bit of my background. I have a PhD in mathematics, where I studied arithmetic geometry. I'm a Pandas core developer, and I'm a director of data science at 8451. 8451 is a data science and customer insights company wholly owned by the grocery store Kroger in Cincinnati. And there in my work, I specialize in large-scale optimization problems. Now, for optimization solutions, we have pretty much every one of our repositories utilizing PyTest for their testing suite. And we like to test on live data. Testing on live data allows us to identify issues before they occur in production. But it also means that some mornings you wake up and all of a sudden you have a failing test, even though no code changed, because the data changed instead. And now you have to figure out why that test is failing and how to fix it. Now, when it comes to optimization problems, it requires quite a bit of complex data in order to even just run the smallest of optimizations. We're talking maybe 5 to 10 data sets, each a couple thousand rows, maybe 30 columns. And my typical way of debugging a test, stepping through with a debugger, can be quite painful when there's that much data involved. What we like to do instead is we like to replicate the failure in a notebook, and then within the notebook kind of interactively analyze the situation and understand why our test is failing. But even that can be a little bit painful because you have to take all the code that is involved in that test and copy it over into the notebook before you can really get started. So let me just give a quick demo of that. And for this demonstration, I'm going to be using the Pandas test suite. So this is PyTest running on one of the Pandas test files. And if I run this, you see PyTest running, and you immediately get 2 failures with these red Fs here. Now, these are things I added to the test to make it fail just for this demonstration. At the bottom, you see a summary from PyTest telling you what tests failed. And if I jump over into the Pandas code, this is that test there that's failing. Now, if I wanted to run this test in a notebook, I would first need to copy all of this code and all of the imports associated with it. But then I would also need to copy this TS frame and this as index. So starting with as index, that's a parameter. You can see it up here, parameterize as index true and false. And PyTest will run this test twice, once with the as index variable true and once with it false. And you can actually see that going back to the summary. That's what this bracket true and this bracket false is. PyTest running it twice, once with each value. The other thing I need is this TS frame. And that you actually don't see here, and it's because it's actually defined in another file. So jumping over to that definition, this is the PyTest fixture TS frame. And what it does is it creates just a data frame with just some small test data. So I'd also need to copy this over to the notebook. And again, any imports associated with this as well. And I've done that here in this notebook. And so this is all that code that I needed to copy over for running the test. And I can run it here, and again, we see the failure of the test. Now, the alternative that PyTest NDB allows is to do all this without copying the code. So if I do a quick pip install for my PyTest NDB, PyTest NDB package only has one function called run, and to it you specify the package that you want to test, in this case pandas, and the string identifying that the test you want to run. Now if you notice, jumping back to the summary, all I've done is I've copied exactly the string from my failure summary over into the notebook. And now I can run this code here, and we again see PyTest running and a failure. But what PyTest NDB will do is it'll capture all those local variables, store them in a dictionary, and that's what being assigned to test locals here. So I can see test locals are all the different local variables from the test, and now I have them and their values within the notebook, and now I can play around, interrogate them, analyze them to my heart's content, understanding why the test failed. So that's what PyTest NDB allows you to do, and it just makes debugging with the notebook a bit easier. So if you'd like, go ahead, give it a try. You can just do a quick pip install, and here's the repository. It's just under rh/PyTestNDB. There's a bit of documentation here you can check out, and if you do try it and run into any issues, please put up an issue on our issue tracker. Thank you very much.
In 2022, the release of Python 3.11 introduced a new piece of syntax, and to me, the syntax changes are always the most interesting when looking over the release notes. What problems were people having that couldn't be solved with the available syntax? Or does it allow more powerful, concise, or safer ways to write code? Regardless, you should be aware of the changes before encountering it in someone else's code and being caught off guard. So come with me as I learn the finer points of slideshow animations as I take you on a deep dive into ExceptStar.
ExceptStar and friends are brought to you by PEP 654. See site and documentation for more details.
Here is the syntax. We can call something in a try block, but instead of our standard except, we use ExceptStar. You cannot mix ExceptStar and the normal except in a try block. You'll learn that very quickly yourself, as Python would raise a syntax error upon parsing your code. Likewise, you'll get a syntax error if you try to return, break, or continue from within an ExceptStar block. That is to say, you cannot jump out or leave the block early, unlike a typical except. It is technically parsed as two tokens, so you could put a space between the except and the star. Don't do that. Now the main feature. Unlike your typical try except statement, which will catch one exception and run the first matching except block bound, ExceptStar allows catching multiple exceptions, and will run each block with those exceptions matching the type. Said again, instead of something simply returning or raising either a value error or type error, we have the possibility of raising value error and type error. Or value error and value error, or any number of the two. Mix and match to your heart's content. Your broken code can now error out in so many ways. Isn't that great? This brings us back to the title of the talk, how can one line of code have multiple errors? Technically, it can't. There's no raise star syntax added, which would allow us to raise multiple exceptions at once, because the designers of PEP 654 came up with a better way. Exception groups. Exception group is a standard library exception added to the big tree of built-in exceptions in 3.11. You can find it in Python docs right here. I think they're fairly simple to understand. They comprise a string message and a sequence of one or more exceptions. The arguments are validated. Message must be a string, and exceptions must not be empty or contain non-exception objects. And it must be a sequence, no generators, dicts, or sets allowed. If you're not running Python 3.11, or you have a library that supports running on older Python versions, I have good news. There's an exception group backport package in PyPI which provides an equivalent exception group class, though you cannot use the ExceptStar syntax in older Python versions. Just as an FYI, there is syntax for including package dependencies only if your Python version meets given criteria. Here's the magic incantations for a few standard options. Now that we have access to exception group, let's use it. Our something code will just be raising an exception group containing a not very helpful message. Then, the list of sub-expressions with value error and type error. Here we are dealing with both a bad value and something that should have been an int. Typically, this list would be built dynamically, but this is all slideware. First, let's check out the behavior of not catching anything. Let's call it and see what happens. Neat. It's a little unclear because I'm using Jupyter Notebook for this example, but here's our traceback to where the exception is being called in the other cell. Then we get this little ASCII art diagram of the contained exceptions, ordered by their index in the exception group's sub-exception list. Let's see what happens when we try to catch it. Huh, we get the same thing. That's weird. Oh no, it isn't. I forgot the stars after except. This is a standard try except, so it'll treat the exception group as a standard exception, and no blocks match it, so it raises up. Let's add the stars. That's better. And run it. That's not very informative. Instead of just printing E, let's print its repr. There we go. you see the E variables are not the error type specified, but new exception groups containing the errors which matched that type. What happens if we don't match all the exceptions in the group? Let's leave only the except star type error, and we see that it is handled appropriately, and the value error gets raised as before, wrapped in exception group. Just like normal excepts, we can include multiple types in one except block. Note that type error is used twice, and when we run this, we see only the first block matched. Exceptions are effectively taken out of the parent exception group as they're matched, so exceptions will only be matched once. How does except star handle throwing a non-exception group exception? Let's just raise a value error. The exception is wrapped in a new exception group with no message. This is good, as the alternative would mean the type of E is dependent on whether the function raised a value error or an exception group containing a value error, and the whole point of except star is to simplify that ambiguity. We have a guarantee that except star always binds variables to exception groups, sparing us from collecting and re-raising exceptions from exception group oblivious code. But if we don't catch the value error, the except star block doesn't change the raised exception to be an exception group, which would cause a lot of confusion. Next, let's look at what happens when you put an exception group inside another exception group. I'll let you imagine the code which does the real validation of our x and y values, but let's say it finds some errors, and we're using exception groups to report those errors. Now we have nested exception groups. So what does this look like? We get further nesting of our little ASCII boxes. I really like this. Let's use except stars. The formatting here is a little unfortunate, but here's a little sketch to help. The full tree of exceptions is walked, and any exception matching the subtypes are extracted into exception groups, preserving the structure of the original tree. What if we try to match all exception groups? Type error. We're not allowed to except star an exception group. I guess that would be too ambiguous as to whether it's the raised exception group or an exception group within an exception group. Before you go and rewrite all your validation code, I want you to think about whether or not this output is useful. I think in most cases like this, we care more about the errors per value rather than grouping the errors by type. And if we're not grouping by type, then maybe simpler solutions should be used, like dictionaries or bespoke exception classes. I'd like to caution you against subclassing exception group because, as I've stated, those have the restriction that you can't catch them with except star, and that might surprise some of your users. Except for that box drawing stuff, that's great. You should find a way to hook into those routines for doing error reporting. This isn't a complete guide. Exception groups have other methods, but I'm not going to cover them today. So when do we actually use these features? I'd say pretty rarely. Typically, good code won't fail with multiple errors simultaneously. That might be a sign you're doing too much in one function. The PEP lists 5 cases where exception groups are intended to be used: concurrency, retries, callbacks, wrapping code. By complex calculations, they mean things like backtracking algorithms and parallel computations where many things could go wrong at the same time. All of these are functions calling other functions, user functions which may raise anything. In particular, concurrency. In async code, we often do have points where multiple things are happening simultaneously, and any number of any kind of error could be thrown while waiting for tasks to complete. You're most likely to experience a thrown exception group when using an async IO task group. If any of these tasks, A, B, and C, fail before the event loop returns to the calling function, the task group must report all of them, and you can see an example of the exception group here.
So there you have it. A new exception had to be created to indicate simultaneous errors, and new syntax introduced to handle those gracefully. It's probably not a tool that you need very often, but I hope that after this presentation you'll at least know what you're looking at when you come across an except star. Thanks for watching, and I hope you enjoy the rest of your special winter edition of PyOhio.
Hello, PyOhio. My name is Jeff Lehman, and welcome to my talk, Hamming It Up, using Python and ham radio. First of all, let's delve into a little bit about me. I have been an SQL developer for 20 plus years. I hold a bachelor's in data management and a master's in software engineering. I work for R&L Carriers on the business intelligence and architectural solutions team as a SQL developer. I have been a licensed ham radio operator for 22 years. My call sign is N8ACL. That's November 8 Alpha Charlie Lima. I mean, I have other interests as well outside of, ham radio. So I like to do software development. I enjoy gaming. I enjoy going fishing and camping, and I enjoy traveling. Since this is a 15-minute-ish talk, let's go over some of our goals here. I do want to touch on a brief background of what ham radio is. I want to touch on the methods of how I use Python to fill holes in my ham radio experience. I do want to present some examples of how others have used Pythons in their ham radio experiences. And I do want to take a moment to mention that all the slides, bibliography, links, and all that stuff will be in this GitHub repo if you want to go back and reference it at another time. Okay. So let's start with what is ham radio. In 1901, Marconi made the first transatlantic transmission, and this was a voice transmission. This wasn't just like Morse code or Spark Gap or things like that. This was the first voice transmission across the Atlantic. About 11 years later, Congress approved the Radio Act of 1912, and in it, this is what lays out the amateur radio service and required operators to be licensed. Prior to this, anyone could build a Spark Gap generator or a telegraph and talk on any of the frequencies. After this, you needed to be licensed. What is ham radio? Ham radio is a form of communication that allows for two-way communication between two or more licensed individuals on some designated frequencies. Ham radio is both a hobby and a service. Some people would argue it is just a service. It is both a hobby and a service. Within ham radio, there are so many aspects to it. It's been said that ham radio really is a hobby of hobbies. There are so many different things that you can get involved in that you could really just specialize in, that really just you could make a hobby within the hobby. Today, we don't use Spark Gap generators, obviously. We still do use telegraph keys for Morse code, but we use a lot of other methods now to communicate with each other. We use simplex, which is radio to radio, like walkie-talkies. We use repeaters, just like the police and fire departments. We can talk through a repeater and it will amplify our signal to a much wider area. Computers have been incorporated over the years. Things like the Automatic Position Reporting System, or APRS. This plots our location via the radio on computer screens. We can use packet radio. Packet radio connects two or more computers together and allows you to send files, send text, things like that via radio-connected modems. We use a lot of digital modes now. A lot of these same digital modes are ones that you might be familiar with from commercial uses, like DMR, like P25. Yaesu, the Yaesu Corporation has their own version called Yaesu System Fusion. We use the internet as a backbone for a lot of these. For example, DMR, P25, and AllStarLink all use the internet as a backbone to link repeaters and users together to let people talk across really the world just from a handheld. So now let's delve into how have I used Python and ham radio? What are some of the things that I've looked for to enhance my ham radio experience? First of all, I use Python to interact with a lot of APIs online. For example, I wrote a Hammy, or what I call the Hammy Discord bot. This is a bot that will sit in ham radio Discord servers or ham radio themed Discord servers and allow its users from any text channel to do an online call sign lookup. You can tell it, hey, I want to look up N8ACL. It will go out and pull all the information about me and display it right there in Discord for you, so you don't even have to leave the application. I wrote a lot of Discord bots for radio control. For example, I have one that will allow me to control my All-Star Link system. I can type some commands into Discord, and the bot will listen for those commands and then reach out to my All-Star system and connect my node to other nodes and let me talk across the internet that way. I've also used it to interact with APIs for APRS station lookups. This includes messaging and other notifications. What this application will do is it will listen to an API from one of the web-based APRS systems, and if whatever call sign you're wanting to listen for comes across the APRS information system, it will send a notification to a number of different social media services, Mattermost, Discord, Slack. It used to go to Twitter, Pushover, things like that. That way you can get a notification that, say, for example, a friend of yours is on the move and where they're located at and what the weather is like at their location, things like that. Other things I've used Python for. Pulling data off of data streams. Again, the APRS information system, or APRS-IS. This is a data stream that is on the internet that allows what are called RFI gates to send the data that they hear to the internet and then share it to multiple websites, other users of the APRS-IS, things like that. What I can do then is I can pull data directly from that backbone and parse that data out and then use it for various things. For example, in my APRS notify script that you just saw, that's what I use to send the notifications with. I can also put messages onto the APRS-IS system so that I could, for example, from Discord or Python itself, I can send a message to an RF station out driving around and things like that, and we can communicate back and forth that way using that. I use for DMR, the Brandmeister DMR network has an API that has a continuous stream of data of stations that were last heard on the DMR network. I can tap that data stream and listen for specific call signs, specific areas, things like that. And I can pull that data in and send it to things like MQTT, SQL Server, use it for notifications on Discord if I want to. Once I have it on MQTT or an MQTT broker, I'm then able to use that to send to other various endpoints and use the data how I need and how I want. An example of this is in one of my GitHub repos here. I do want to note that the logic behind listening for these call signs was actually developed by a gentleman by the name of Michael Clements. He's a ham out of Germany. I forked his original work and modified it so that I can put the data directly on an MQTT broker to allow me to use it in multiple places, and I know it's going to be the same data in all of those endpoints. I use Python to save a lot of data for ham radio to various databases. I have set up some ETL processes that allow me to pull in data from various sources, typically again by APIs, transform and then load that data into tables in SQL Server. That way I can then use that data to pull against for call sign lookups if I need to do analytics on, how many stations were last heard over a certain period of time. APRS information, if I want to keep local APRS information, I can store that all into databases. I use Python to pull all that information in on a nightly basis and update that data for me in my databases. That way I have a local copy of it on my network and can use it however I need to. Some examples of what I pull in. I reach out and I pull in the DMR IDs for all DMR users, or ham radio DMR users. Let me rephrase that. I pull in a list of the all-star link node directory, so I can search for quickly any kind of nodes that are on the all-star link network. I pull in talk groups from different DMR networks, the TGIF network, the Brandmeister DMR network. I pull those all into data tables. That way I can do lookups against those talk groups to find, say I see a talk group pop up, I can figure out its name and not have to go to the internet to find it. I also still store local things as well. For example, I store a directory of local RF net information. I kind of started this during COVID. And what this would do is that this was used to send notifications to like Twitter and Mastodon of local nets that were going on at specific times. That way, during COVID, hams who were basically in isolation would know, okay, now is a good time to get on the radio because I know I'm going to find people on this specific frequency and I'm going to be able to talk to them and be able to interact with people. I've kind of kept up that directory post-COVID because it is a good information source for other things, and I do tap that data source for other things. So I have that database set up as well. This basically, by setting up these databases and setting up these detailed processes, allow me to bring the data in and not have to constantly go outside of my network here at home to grab data off of APIs. It speeds up getting that data to me. Now, how have some others used Python in ham radio? Again, Michael Clemens created what he calls his QRZ logger. QRZ.com is a call sign lookup website. However, they have logbook functionality. He created a program in Python that interacts with their logbook, which is basically a list of contacts that a ham radio operator has made. He wrote a Python script that goes out and interacts with that logbook. That way you can do logging from the command line via Python to your logbook, and then it is updated and anybody can go to your QRZ page and see this data. Another group of users have created what's called Analog Reflector. This is written entirely in Python, and it's a web-based client that allows you to interact with multiple digital modes. This includes things like DMR, Yaesu System Fusion, P25, All-Star Link. And this allows you to interact from your phone, your computer, tablets, things like that. It's all written completely in Python, and they are keeping it actually well updated with that. So this kind of filled a hole for people who don't have the ability to, get a radio or things like that, or they're away from their house and they don't want to carry a radio with them. They can carry their phone, get back in, and be able to talk online or talk via the internet to other radio users. Again, going back to that radio linking. Again, I know this is a brief summary of this. 15 minutes is not a long time. Maybe in a future talk, I'll be able to get a little bit more in depth. But like I said, I just kind of wanted to touch on some of the topics of what we've used Python for in ham radio. If you have any questions, if you want more information, things like that, here's my contact information. Feel free to reach out. I will get back with you as soon as I am capable. Of course, life, work, and family all come, first, but I will get back with you. And again, I'll have all this information up in that GitHub repo I had earlier in the slideshow. But thank you for attending the talk. Hopefully you got a little something out of it, and enjoy the rest of the conference. Thanks.
Hi, PyOhio. My name is Dan Shelkoff, and I'm the Internal Services Group Lead at Tenet3, a company located in Dayton, Ohio. And today, I'm going to talk to you about the annotated type, which is a way of including typing metadata into Python. It was released in Python 3.9, but has gained a lot of popularity this year because of its inclusion into Fast API and Pydantic. And when I first read the documentation on how to use the annotated type in those packages, it was really confusing to know how this annotated type works behind the scenes and provides the functionality that they say it can give it. And so I hope that this talk can shed a little bit of light about what is happening and how it works, so it's a little easier to understand what's going on in those packages. So let's start by looking at how the annotated type works within the type system. If we look at our first example here, we have a variable called annotated int. I set the value to 2, and I have this big scary type hint right in the middle that uses the annotated type. The arguments inside the annotated type are broken into 2 different categories. The first one is just the very first argument. And this one is special is because this one is the one that the rest of the type system sees as the type for annotated int. If I hit play here, you can see that the type of annotated int is an integer. It isn't the annotated type. So anytime I use annotated int, it's considered an integer by the typing system. That leads us to the second group inside the annotated arguments, and that is arguments 2 through n. And those are metadata. They can be any type. This is a string, of course, but you could use a class for an example. And all of these are not visible by the typing system. You can see here, right, there's no evidence of metadata here, unless you go and specifically look for the metadata. And we'll talk about how to do that in a little bit. But the cool thing is, since this is considered an integer by the typing system, I can pass this into a function that only requires an integer and does not have the annotated type in the function. There's no errors here. There's no linter errors for type mismatches. And so I can hit play. Everything works as intended. Everybody's happy. And I can do the opposite as well. I can take an integer that does not have the annotated type, right? Of course, this is of type int. And I can pass it into a function that does have a parameter that uses the annotated type. When I pass in this unannotated integer, right, of type int into this function, the type system is only looking for int. It's not looking for annotated again, right? So there's no typing mismatch. Everything works as intended. We're good to go. And what this does, being able to go both ways like that, gives us a lot of flexibility to only have to use annotated where we need to. I don't need to change the rest of my code to make annotated work in specific sections of my code. I don't need a third-party package to fix their code to support annotated because it doesn't play nice with my annotated code, right? Because it goes down into that first argument and uses that type for the rest of its lifetime. It is backwards compatible. It plays nicely with the type system, whether it's a third-party package or your other code. So that's pretty cool and pretty useful. So we understand now how the typing system handles the annotated type, but now how do we get the metadata? There's a couple of different ways that we can do that, and that's through one of them is through the dunder metadata attribute. This is a special attribute that only the annotated type has. As you can see, if we hit play, the annotated type up here has that dunder metadata method, and the normal integer type does not have that dunder metadata method. What this returns is a tuple of the metadata. Again, this is arguments 2 through n of the annotated type hint. So the other way, or another way that we can use to get the metadata is through the get type hints function. This is available through the typing module, and it has to be used on a function, a method, a module, or a class. And what this returns is a dictionary where the keys are the parameter names, like first num and second num here in this case, and then the values are the type. So if we hit play here, we see that both of them are integers, even though that this one is using an annotated type up here. So there's a caveat to using get type hints if you want the annotated version. you have to include the include extras parameter and set that to true. And this is by default false to maintain backwards compatibility. And so if I hit play here, I get type hints, and I can use the dunder metadata attribute like I would with, like I showed you above. Now that we've gone through all of that and learned how the annotated type works, what's it used for? What's the purpose? What's the point? Well, I want to show you a basic validator that is going to work similarly to how Pydantic runs its validation logic when you put it into an annotated type. So we're going to show a bare bones example of what it looks like and how it works, so you can better understand what's happening with Pydantic. So the first thing that we're going to do is create this concept of a validator. And it only has one method, and it's essentially just taking in a value and then testing it against a constraint. And if it passes that constraint, we're going to return true. If it doesn't, then we're going to return some sort of error to make sure that the user is aware that it did not pass validation. And so in this case, we're just testing positive integers. If it's a positive integer, then it's good. If it's not, we're going to throw the error. And now we have our actual data class, and we're going to just take a simple square with one side. Of course, since it's the length, we want a positive value. And so how we're going to ensure that side is a positive value is we're going to put it into this annotated type. Again, this is the first argument. So side is considered an integer everywhere else. And then we have this metadata here. We have an instance of positive integer validator and just a silly string that is there for an example. If we look at the post init for this class, right, this is what gets called after all of these instance variables are assigned and created. What we're going to do is we're going to get the type hints. Again, the type that we get on the return is a dictionary of parameter names and the actual type. If we want the annotation data, which we do, we want to say include extras. Okay. And then we're going to go through each parameter and look at the typing information for each parameter. If it has the dunder metadata attribute, right, that means it's an annotated type. And then we can grab that tuple back out. So now we have a tuple of all the metadata for that individual parameter. In this case, we only have one parameter, but we have two pieces of metadata. So we need to go and run through each piece of metadata, and we only care about running validation on those that are an instance of validator. And again, that is our base class up here. So that's why we created this base class, is so we could easily run this isInstance function on our metadata to check to see if it's a validator type. Since it's a validator type, we know it has a validator method, and we can use that to validate the side in relation to this constraint. Okay, I could have multiple constraints, right? I could create multiple validators up here and add them up here. But then, right, it runs through there. If it passes validation, then basically the square object is good to go. If it doesn't pass validation, then we get that value error up here. So if we hit play, we get that value error. If we hit play here, everything works good. And I know this is a silly example, and it would be much easier just to write that logic in here. But this gives you an idea of how Pydantic works, and I'll show you how it works here in just a second. First, we're going to look at how Pydantic instantiates the model or the data class. It's equivalent to a data class. And so here we're just going to create a silly shape that we're going to call an even rectangle. And this even rectangle has to have a length and a height that are both even. and we're going to say that they both have to be positive and they're both integers. Okay, so it's a very simple class, but here we have two constraints, right? We want to make sure that the length is positive and that or that both values are positive and that both values are even. So we have two pieces of validation to accomplish. So with Pydantic, we can do that through the annotated type. We have an integer, right? And so that's what height is seen through the rest of the typing system is an integer. And then we have two pieces of metadata to help with that validation. One is this field object that ensures that the integer is greater than 0, GT, for greater than. And then we have this after validator that looks to make sure that it's even, because we pass in this function that runs on the value to make sure everything works right. And if it doesn't, we throw a value error. If it does, then we return it. This works very similarly to our basic example up above, right? Pydantic is doing very similar things here, right? It's getting the type hints. It's looking through the metadata. It's finding the metadata that is an instance of after validator, right? And if it is an instance of after validator, then it's running that class and running a specific method inside that class to make sure that it's even. And so that's how it's using this annotated type to provide that metadata and provide that validation. This is also equivalent to this. We just have a nested annotated type. So we just have a positive int type alias here with the field, right, greater than 0. And then we're putting this into here, right? And we're basically adding an additional piece of metadata here, right, to ensure that it's positive and even integer. And so we can use that here. You can see that it works. The validation is working as expected, right? Length is a -2. It should be greater than 0. Height is 5. It needs to be even. If both parameters meet the expectations, then everything works out okay. We're putting the validation info up in a type alias and not inside of the class. You might find it beneficial because then you can reuse those types in different objects without necessarily having to resort to things like inheritance. Here we want to create a pyramid, and we want all the lengths to be positive, just like we did with the rectangle. But if we put everything in this type alias, right, we can reuse this type alias and get the same validation. And so this is one way. It may not be as readable as other ways that you can create models in Pydantic, but it is a nice way to reuse some validation logic between different models if you need to. So it could be a really nice way to architect your Pydantic models to eliminate some code rewrite. It might not be applicable in all situations, but it's something to keep in mind. And so with that, I would like to thank you for your time and attention. I appreciate the opportunity to speak to you today. If you want to see this or want to reference this somewhere else, it is available in my GitHub account up here. Have a good day.
Hello, and welcome to my talk, Ada for Circuit Playground Express as an on-air light for PyOhio 2023. My name is Nick. I am a professional and unprofessional Pythonista. I have a website with a blog. I have a GitHub profile with some code. I have a Mastodon account where I occasionally post something interesting. I have an email address you can use to get in touch. And I may be available for hire. This is our project for today. We're going to be building this thing, not the one at the top, the one at the bottom, and it's going to be a customizable, affordable, on-air light. The reason I built this thing initially is because my desk used to be in the living room, close to the kitchen. And so sometimes my wife would walk through the hallway, go get a glass of water. And then sometimes she would also want to say hi because she's fond of me. And rather than making her always ask, is now a good time, is now a good time, I figured if I put a little light on there, she can just figure that out. Great. The platform we have to work with today is Circuit Playground Express, which is a small device you may already have if you went to PyCon 2019, macOS, which is what I use, and Zoom, which is what my employer has used. The hardware involved is the aforementioned Circuit Playground Express, a long USB cable so you can reach across my wide desk, and optionally, I got a plastic enclosure to prevent the device from getting too much animal fur or dust or what have you. The software stack is even simpler. It involves really just a bit of Python, all in the standard library, and LaunchD, which comes installed on macOS and allows us to control background tasks. The components of the software are fourfold. The first one is a status file, which is a file that's going to contain a 0 if there's no call, and a 1 if there is an active call. There is an LED changer script, which will change the colors of the LEDs on the device based on the status file. There's a call detection script, which will be running on your machine, figuring out if there's an active call and making changes to the status file. And finally, a LaunchD service, which will ensure that the call detection script is running continuously. Starting with the status file, it needs to live on the device, so it will be in /volumes/circuitpy. We'll call it state, and we'll just put a 0 in there for now. Moving on to the LED changer script, it also needs to live on the device, and it should be called code.py, because that is the file that will automatically get run when the device is actually powered. In the script, we will import the CPX module from the included library, which allows us to interact with the hardware. It allows us to work with all the inputs and outputs, specifically the LEDs, which we care about in this case. We will define a few colors in the tuple. We'll have a green and a red. We will set the brightness of the LEDs to 0.01, and if you've ever turned these on at this device without doing so, you will understand why. They're incredibly bright. And then we're going to write a small while loop that always continuously runs. Inside it, we will open the status file. We'll get the actual state. We will use the state to decide on the color, and then we will fill all the LEDs with said color. Simple enough. The call detection script should live on your machine. I have mine on this path. You can keep it somewhere else. If you have a repository to keep all the changes of the customized code, it's fine, wherever you'd like to keep it. It uses one module from the standard library, subprocess, and has only one function, detect. The function does start a little heavy, I admit. It uses subprocess.checkOutput to run a command called lsof, which is list of open files. It passes parameters I and then the value for UDP, which returns a byte string so we can run the code on it and then split it on new lines to get essentially the rows of the output. The second line, gets all the rows of the output that are relevant to Zoom. It's just a list comprehension looking for the word Zoom somewhere in the row. After that, we want to gather the states. The current state of the machine is determined by those Zoom rows. If you have Zoom not running, you have 0 Zoom processes. If you have it running, you probably have 1. But if you have an active call, you will have 2 or more. Therefore, we check whether we have more than 1. And then the device state is just initialized to none here. We then open the state file and get the actual device state from it. If it is different from the current state, then we go and write the current state to the file. Since this is a script that we're going to run for testing, We also add if name and main, detect, and then we'll actually run the detect function. The last part is the launchd service. It needs to live in the path above, which is your home directory /library/launch agents. The naming convention for everything I found in there always looks something like com.vendorname.projectname.component.plist. So I named mine this. It starts off with some boilerplate XML. I wouldn't worry about that too much. It gets interesting where you define the actual properties of the service. So the first thing we define is its label, which is really just the name, aka the file name. The second thing we define is the command that actually gets run. The key is program arguments, and it is an array of strings of the different parts of a command separated by spaces. So in this case, we use a Python interpreter and we run the detect script. Use whichever Python interpreter you'd like and wherever you have your script here. The last part of it is a keep alive flag, which we set to true, which ensures that this service will continuously run over and over and over again, so that a script will get run and rerun and rerun. After this is all done, the only thing left is to run it. To interact with launchd services, you use a tool called launchctl, and the command is launchctl enable, and then the name of the plist file. And so if you've done all that correctly, and you have the device set up on your desk, you'll have something like this. Once it's running, if I go and start a Zoom call, it takes a few seconds, but you can see the green LEDs eventually turn to red, signifying that there is an active call. And then when I go and I end the call, it again takes a few seconds, but you will see that the red LEDs will eventually turn to green, and there is our no call state. Pretty nifty, huh? There's some considerations about this as it's currently built. There may be other ways to detect calls. You can detect camera and microphone use, for example. I found this to be a bit unreliable because I'm often on a call and I have both off. If it's a big town hall at a company, I might not have my camera because no one needs to see me eating lunch and no one needs to hear me speaking. So it's not super reliable. A manual switch would be kind of neat, huh? If you could just set it to red instead of having to start a whole Zoom call in the background for that. This talk is too short to cover that, but it is a useful thing to do. And I used a tool called xbar and a shell script to give me essentially a menu bar item where I could click it and then click a script name and it would just toggle it. So it would toggle from 0 to 1, whatever it was. And that allowed me to turn it from green to red manually. And it would then kind of just keep going from there as calls were coming and going. And the third thing is other statuses might be helpful. At some point I did implement a yellow, which meant I'm not on a call, but I'm trying to focus. And that was kind of different from I'm specifically on a call, definitely don't interrupt me. You may have other things you'd like to include in some way and then account for in the code. The future of this project for me is sort of funny because it's actually decommissioned. I have since moved into my wife's office down this hallway you saw initially. It has a door, and that's a really great signal for do I want to be interrupted or not. I guess I could hang it on a door. It might still be nice to have it as a should you knock kind of indicator, but then I'd have to figure out how to power it, and battery, I just don't need any more of that. I have 10 devices on my desk right now that need to be charged, and I don't need any more charge anxiety. The takeaways from this, I think, are what I'm really trying to convey here. And the main one is that I had no real hardware experience before I did any of this. I've been a web developer and just a software person forever, and I've never really interacted with anything that was physical and tangible, and it was really a ton of fun to do that. It also really wasn't very difficult, which leads me to believe that you can probably do this too, especially with something as simple as this Adafruit Circuit Playground Express device. Because devices like this that have a lot of inputs and outputs are just really fantastically fun toys. This is a useful project we built here, but when I received the device in 2019 at PyCon, I think on the last day before I left the conference in the hotel room, I wanted to play around with it a little bit. And so I wrote silly scripts and I made a bad theremin where I would use the light sensor and pipe the value of that to the speaker so I could shine a light on it and then move my hand up and down to get different beeps to show up. Silly, but fun. And a really interesting way of thinking about, honestly, different kind of stuff than software considerations usually have. And speaking of those software considerations, that's probably what most of us are doing. I think just statistically, we're all working on things that are really big projects and have revenue and are web scale and what have you. And I think it's important sometimes to just play. I think a lot of us got into this in the first place because we like tinkering with something, and it's sad to lose it completely. And so if it isn't the day job, maybe it can be a little fun on the side occasionally. And so I think we should all play more. And with that, I want to thank you for watching my talk. I hope you had a good time. The slides and code for this will be on my website, /talks. Shouldn't be hard to find. You can send me questions, comments, and job offers, as I mentioned, to either Discord, I'm at Nick Huntar, or you can hit me up on Fediverse or Mastodon, or you can shoot me an email. And the very last thing I want to do is, in 2019, I announced the first edition of PyBeach, which was a Python conference in Los Angeles. And it happened in early 2020, and then we all know what's happened since then. So I'd like to take this opportunity to again announce, hopefully, a return of PyBeach next year, probably late in the year. And if you're interested at all, I suggest you go to the website and sign up for the newsletter. It is extremely infrequent. And with that, thank you for your time, and have a great rest of your conference.
Hello, PyOhio. I'm Christy, and I'm going to show you how you can create a web map with PyScript. I'm a geospatial developer, and fun fact, my mom is from Ohio, so even though I live in Seattle, Washington, I have an Ohio connection. I really like making maps with Python, so what I'm going to show you today is how to make a map using the GeoPandas library, and then we'll use the PyScript framework to share the web map and the Python code that makes it, all with a single link. So let's get to making a map. Now, I enjoy hiking, and I promise this is relevant. We are lucky in the state of Washington to have a lot of hikes to choose from. The Washington Trails Association is the main source for hiking information in the state, and if you go to their webpage, the options can be overwhelming. There are so many hikes to choose from that it's difficult to pick one, and sometimes I won't go on a hike simply because I can't choose. So to help make the options a bit more manageable, I've made a web map that just shows me 5 random hikes. I can hover over a trailhead location to get information about the hike, and I can reload the page. It will show me 5 different hikes. By the end of this talk, you'll know how I made this. So the Python library that I like to use to make maps is GeoPandas. If you haven't heard of GeoPandas, you've probably heard of Pandas, which is an awesome library that provides the data frame object and a lot of ways to manipulate and analyze tabular data. GeoPandas is built on Pandas and provides the GeoDataFrame object, which is like a Pandas data frame, but has spatial information and can be used to make maps. So let me go over the Python code we need for our project in a Jupyter notebook first, and then we'll use the same code with PyScript. So here is the Jupyter notebook. So I'm going to import pandas and GeoPandas. And I found a pre-scraped CSV file from Washington Trails Association website. So I'm going to go ahead and load that in. It contains all the information about hikes in Washington. Look at the first few rows, and we have lots of great information about each hike. We have the title, distance, elevation gain. We also have the latitude and longitude, which are the coordinates for the trailhead of each hike. So we can use that to make a geodata frame. So to make a geodata frame, we'll create a geodata frame object, passing in the hike's data frame, and then we'll set the geometry to the longitude and latitude columns. And then we have to set the CRS, which is the coordinate reference system, which for longitude and latitude is 4326. If you're using data that's in a different coordinate reference system, you'll need to look up the appropriate code. Now we'll look at our geodata frame, and it looks the same as our data frame, but if we scroll all the way to the right, we now have a geometry column, which we can use to make a map of this data. So to make a map, you can use the explore method on a geodata frame. So the explore method has a lot of different configurations, and you don't have to change anything from the defaults. So the first one we'll look at will just accept all the defaults. So that's as easy as it is to make a web map with GeoPandas. You can zoom around, zoom in and out. These dots represent the locations of all of the trailheads. If I hover over one of them, it will show me all of the information for that hike. So that's the bare basics of a web map with GeoPandas. Now I want to filter out the hikes a little bit more. I'm only interested in hikes that are between 8 and 20 miles. So here I'm going to filter out all hikes that are outside of that range. And we'll call the explore method again on our new filtered layer. So now we have a few less hikes. And I've also configured the base map to be different than the default, which was a little bit more colorful. This one is more of a grayscale base map, which I tend to like so that the data that I add on top of it pops a bit more. Next, we want just 5 random hikes, so we can use the pandas sample method to give us that random sample. And then we'll call explore on the sample hikes, and now we have our 5 random hikes. So I want to configure this map a little bit more. I want to add the state of Washington outline to the map. So I'm going to load in a layer that contains all of the United States, and I'm going to filter out just the state of Washington. So now I want to put 2 layers on the same map. So how you do that is you call the explore method on the first one. The first one is the one you should specify the tiles that you want to use for the base map, and then you can add any style configurations you want for that layer. And then you call the explore method on any additional layers, and you pass in that first map as your M. And then you can add any styling configurations. And I'm also going to say I only want to show these 3 columns in the tooltip because seeing all the layers was a bit overwhelming. All the attributes of each hike when you hover over it was a bit overwhelming. So here we go. This is the final product, 5 random hikes in the state of Washington. So what I just showed in the Jupyter Notebook was using a local Python installation, and to be able to create the web map, I had to do a bunch of setup. I had to install Anaconda, create a virtual environment that had GeoPandas. I had to open a Jupyter Notebook and run the cells. And I did get a web map in the end, but if anyone wanted to run my code or change my code, they would have to do a bunch of setup. And for beginners or really anyone, that's not always a fun, straightforward thing to do. So I have been using PyScript to make web maps, and it's great. So PyScript allows you to run Python code in the browser, so you don't need a local Python installation. And PyScript will also create a virtual environment for you with access to a lot of great Python libraries like pandas and GeoPandas. So it's awesome. So to find more information on PyScript, recommend going to pyscript.net where you can find examples and documentation. You can also find installation instructions, which are this cheeky instructions because you don't need to install it. You can create an HTML file and add these 2 lines to it, and then you'll have access to PyScript. But what I'm going to show you is how to use pyscript.com to make our web map. So I have my dashboard up. I've made a bunch of web maps with pyscript.com, but I have one for this particular talk set up. So this is your pyscript.com working area. So it comes with these 3 files. These come with set up already. So index.html is going to be your main HTML file, which will contain all the links to the PyScript that was instructed in the pyscript.com website. It has these links in it. And at the bottom, it has links to the Python file that you want to run and also the pyscript.com configuration file. So these are the other 2 files here. Pyscript.toml is where you'll specify the packages you need for your code. So I have GeoPandas here. Pandas is a dependency of GeoPandas, so I don't have to specify it. I need Folium, Matplotlib, and MapClassify available in order to use the explore method, so that's why I have those in there. So main.py contains the Python code that I want to run. And it's really just these 6 lines of code that are making my map, and these are the same lines of code I used in the Jupyter Notebook to make the map. Some differences here between my local Python setup are, in order to get access to the data that I need to pull it from the internet because PyScript doesn't have access to my local file system. So I'm using the PyOhio HTTP OpenURL method to load in my hike data and my state boundary data. And then I'm importing the display method from PyScript. I make the map here, but in order to actually put it on the page, I need to use the display method. And so over here, you may have noticed the map show up. So this is the preview pane, which will show any of your PyScript results. In my case, it's my map. And then I could click View Site here to get a page that just shows the map itself. And this link here is what I could share with others. Anyone can access this link with an internet connection. Down here, there's more information on pyscript.com. You can also view the code that was used to make this map. So that is how you can make a web map using GeoPandas and PyScript. So I have more information about all my code examples are on my GitHub repository for this talk, which is here in the lower left. You can also follow me on Mastodon. My link is in the lower right. I encourage you to try making maps with GeoPandas and PyScript. So thank you for listening, and I'll see you next time.
Hello PyOhioans, I'm James Walters, your Who's Your Neighbor, and today I'm going to take you on a web scraping crash course with Python and Scrapy. Let's get started. First of all, let's begin by asking an obvious question. What is web scraping? Web scraping is extracting data directly from HTML pages. Many times, if you're consuming a data source on the internet, there's a JSON API available to you. And these are nice because it's easy to tailor your requests to narrow the data you get back, and it comes to you as JSON, a data format that's pretty easy to import into your program so you can do things with it. However, there's a lot of data out on the web that isn't available through a JSON API, but it is available on web pages. The challenge here is you have to pull that data out of the HTML pages that it's in. That's what web scraping is. And even though it takes some extra work, the data that it unlocks for you is well worth it. So that's what web scraping is, but what is Scrapy and why should you use it to write your web scraper? Scrapy is a framework for making web scrapers. You can think of it as the Django of web scraping. It's this framework that comes with all these batteries included to help you scrape. And that's important, because it won't be long if you're doing a web scraping project of any substantial size before you start running into pain points. The first web scraping project I ever made is still in use today, but I just threw it together with the requests library and Beautiful Soup. Those are great tools, but as my project got bigger, I started running into some common issues with web scraping, and these were a lot more trouble to fix than they would have been with Scrapy. Issues like messing with user agents, creating JSON out of the results and sending an email, adding timeouts and waits for requests, making requests asynchronously. All of these things come in the box for you with Scrapy, so that's why I recommend using it for building your web scraper. So, now that we've explained what web scraping is and what Scrapy is and why you should use it, let's build a web scraper. For our example, we're going to scrape events from the event calendar on New York Public Library's website. This is a great idea. Your local library probably puts on a lot of free events that you're interested in, and this is a great way to keep track of those events and see what's coming up. And this is a great case for a web scraper, because this information, while publicly available on the web, isn't available to us via an API. So here's what we're going to do. We're going to go to our library website, nypl.org, and on the site menu, we'll click on Events. Then we'll scroll to our event calendar link. And then on this page, we'll filter down to the events we're interested in. So that'll be just the adult events, and let's say we live in Manhattan, so we'll only look at things in that borough. And as for what to look for, something that a lot of libraries do is film screenings of culturally or intellectually valuable films. This is a great way to see an edifying film for free. So we'll look at those. And looking at our results, looks like we've got over 130 films that are going to be aired in my area. This is some awesome information, but now we've got to figure out how to scrape this. So let's turn over to the code editor. So I've got a brand new folder here for our project, and I've created a virtual environment, and I've pip installed Scrapy. So the first thing that we'll want to do after that is run a command called Scrapy start project. This is going to scaffold out our entire project for us. And we'll call our project Event Extractor. And over here you'll see that that has created a project folder with all of this stuff in it. We're not going to talk about any of that today. We're going to try and keep our example pretty simple today. So the next thing that we're going to do is actually create our first spider. In order to do that, we're going to go back to our shell. We're going to go into that project directory that we just created, and we're going to run a command called scrapy gen spider. We'll call that spider events, and we got to give it a domain. That'll be nypl.org. And once we run that, you'll see that in the spiders folder, we've got an events.py file. And in this file, Scrapy has made a spider class for our spider with all the default configuration. It has a name, has a list of domains it's allowed to look at, a list of URLs for it to start scraping, as well as a parse method. This is where all of the logic for parsing our HTML response and pulling the data out of it that we want to scrape is going to live. So the first thing that we can actually do is go to our start URLs, and we can add the URL for this page that we're on. So if I go up here and grab that, go back to our code editor and paste this into the start URLs list, you'll notice that this URL has query strings for all of the special filters that we chose. So that we can give this URL to Scrapy and get all the events that match the same criteria every time we load it. Next, we need to look at our page and figure out how we're going to get access to the data that we want. I'm going to assume you understand how HTML pages are laid out and how CSS selectors work. If that's not true, go and do some research, but we're going to assume that for the rest of this talk. In order to take a look at this page, we want to get into our web browser's developer tools. I'm in Firefox, so I can do that with Control-Shift-I. And over here on the right, my developer tool window pops open, and I can now use this to inspect any element on the page, including this table that contains all of our events. That's the table that we want to grab. So I happen to know that this table is the only table in the page that has this views table class. So that's how we'll get it. Jumping back over to our code editor, we'll go into our parse method. And I'm actually going to use some code that I've already written for the parse method. I'll paste this in and explain it as we go. So back up at the top, in order to get our table, I take our response object that is passed into our parse method, and I call the CSS method on it to query our response HTML according to a CSS selector. And in this case, that's table.viewsTable to get that table with the viewsTable class. Once I've got my table, what I really want is the events inside it. That's going to be the rows of the table. So in order to get access to that list of events, I can take our new table object that we just grabbed and call the CSS method on that. So I can grab the tbody, that's where all the rows of our data is going to live, and then I can chain another CSS method on to grab the tr table row elements for that. So now we've got our list of events, and we can loop over them and scrape the data out of them. So the way that we'll do that is in this for loop for event and events, and we're going to write a generator that's going to yield a dictionary with data points for everything that we're wanting to scrape today. What I've narrowed our data down to is the name of the event, the date and time that it's happening, the location where it's happening, and the description information that we have there in the event. So the first thing we'll grab is the name, and if I go back over to our web page, I can use my element picker to pick the name of this first film. And over here in my inspector window, we can see that that is actually a link that lives inside a div with the event name class. So in order to query for that, I can write this code. I can call the CSS method on our event row and look for an element with the event name class, and directly inside that is going to be an A tag, and we're going to select the text of that A tag since that's the name of our film. And then we don't want an object like we've been getting from our queries so far. We actually want the data out of it. And so in order to get that, we're going to use the .get method. That's our first piece of data. The next thing we want is the date and time. So back on our page, I can select the date and time over here. And what I get is a table cell with the event time class. But notice that we've got multiple lines here. So when we query for the text of this element, what it's actually going to give us is a list of nodes, all of those different lines and pieces of what's inside the element. And we don't want all the different pieces. We actually just want to stitch it all together back into one string. And so the way that we're going to do that is we're going to use an empty string and call the .join method on that string. And then the list of things that we're going to join is going to come from event.css, query for that event time class, get the text of that element. And since we're going to get a list of nodes back, we're going to use .getAll instead of .get, and that'll give us a list of nodes that we're going to join together back into one string. All right, we're halfway there. Next thing we're going to look at is the location, and looking at that, we can jump back over to our web page. If I look at the location column, that's going to live in a table cell with the event location class on it. But looking at some of these, it looks like we've got some multiple lines as well. So we're going to do the same trick that we just did. We're going to call the join method on an empty string, and we're going to pass in event.css, looking for that event location with the selecting the text, and we're going to call getAll to get all of the nodes and stitch those back together. And then the last thing that we're going to take a look at is the description. Looking back on our page, use our element picker, click on the description, and we see that that description just lives in a div with the class description. So that's going to be easy enough. Go back over to our code window, and we'll call event.css, look for the description class, select the text, and call .get. And that's everything. That's all the data that we're scraping for. We're almost ready to go. We just have one more problem. If I jump back over to my event calendar page and I scroll to the bottom, you'll see that we're actually just looking at the first page of 4 pages of results. And there's actually a way that we can tell Scrapy about our next button here, and it will actually follow that link to the next page and keep scraping until it's gotten all the results. So in order to do that, first of all, we need to take a look at this next link and see how we can query for it. So if I select it with my element picker, I see that it lives inside a nav element with the pager class, and inside of it there's an A tag with the text next and the link to the next page. So if I jump back over to my code window, I can scroll down and we'll query for the URL of that next button. And in order to do that, we have to take our response object, and we're going to use the CSS method to query for that pager class, and then we get the nav. But once we've got that, there's no real easy way to get to that next link with CSS selectors. It doesn't have a class or an ID that we can grab hold of, and we can't just query for an A tag. That would get the previous link as well on the next pages when that shows up. So in order to select this, we're going to have to use an XPath. Now, if you don't know what XPaths are, I've got a post on my blog where I go into using XPaths with Selenium, and I explain the concepts there. I'll point you to my blog in just a moment. But in the meantime, we're going to use this XPath to grab our next link. And what we're actually going to select is the href attribute of that next link so that we get the URL of the next page. And we'll call .get to grab that URL. So if .get does not find that piece of information we're querying for, if it doesn't exist, it will return the none object. So what we'll do is we'll create an if statement that says if next link is not none, if there's a URL there, then we want to scrape that page too. But first, in order to do that, we need to put together the full URL, because what we got on that next button is just a relative path that leads to the next page. We need the full path to tell Scrapy what to request, and in order to do that, we can take our response object and call the URL join method, which will take the URL of our response and it will concatenate that relative URL for the next button onto the end of it so that we get the full URL for our next page. And once we've got that, we're going to write another generator that yields a Scrapy request object for the URL of the next page, and the callback function is going to be the self.parse method that we're currently in. That's the function that we want to use to scrape that page as well. And that's everything. Are you ready? We can go ahead and run this by going to the shell and typing Scrapy crawl events, it's the name of our spider, and we can use the capital O output flag to tell Scrapy we want you to put this information in a file called events.csv. And then there we go, it's running and scraping right now, and if we look at that CSV file in something like Excel or LibreOffice, we can see the name, date and time, location, and description of all of those films. So, that brings us to the end of this talk. Thank you so much for tuning in. I hope you've enjoyed this crash course on scraping the web with Python and Scrapy. If you want a link to these slides, the resources I've mentioned in this talk, as well as the repository for the code we wrote today, check out my blog at james.walters.click, where I have a post detailing all that information. Also, if you want to connect on GitHub or Mastodon, please reach out. Thanks again, everyone.
Hello everyone, welcome to this presentation about inequality joins and pandas with PyJanitor. Specifically, efficient range joins and pandas. My name is Samuel Oranyeli. I am a data engineer and an open source contributor with contributions to PyJanitor and PyDataTable. So, what are we going to be talking about? What are equijoins? And what is the difference from non-equijoins? What are range joins? Why are they slow? What is the faster option? And what is the evidence that indeed it is a faster option? This references contains articles I used in preparing the slides, as well as the algorithms that were used for the faster option for inequality joins and range joins. So, equijoins, equality, joining two tables on columns that are equal to each other. Non-equi, not equal, joining two tables on columns that are not equal to each other, in which case it could be a greater than, a less than, or not equal to. In the SQL code above, that is an equijoin. You can see the equal sign there on the on clause. Customer ID is equal to ID. In the SQL code below, you have a non-equijoin that follows the equijoin, in which case the created at field is greater than the 1 year anniversary date. So again, equijoin, equals, non-equijoin, not equal, and that is any of greater than, less than, greater than or equal, less than or equal to, and not equal to. If we look at it in pandas, an equijoin is typically implemented via the merge function. In this case, it's a method. And for the non-equijoin, it's usually a post-filter operation. Pandas does not natively have any implementation for range joins within the join itself. So if you have an equijoin, that has to be implemented first, get the data frame, and then filter for the non-equijoin. Now, notice that for this case, we have an equijoin. However, there are scenarios where you will not have an equijoin. There's no common column on which to compare an equality. That becomes quite significant, and we shall see the reason. It is why you have slow range joins generally. and we shall see the reason why. So what are range joins? Range joins are typically of two kinds. They are either a point and interval join, in which case you are looking for values between two other values. The SQL code there should shed more lights. We are joining the clicks with the IP owners and saying, give me or return only the rows where destination IP is between the IP start and the IP end. So I have 2 points and I'm saying, or 2 columns, and I'm saying, search if this column is between these 2 columns. So usually it's you're going to be saying it's greater than one thing, is less than another thing. The overlap join is give me the rows where these tables or these data frames overlap based on a set of conditions. The overlap join example, the SQL code should shed more lights, where it says give me only rows where the start from the left data frame is less than or equal to the end from the right data frame, and the end column from the left data frame is greater than or equal to the start from the right data frame. So there you have it. Range joins, either a point and interval or an overlap. Note that in both of these scenarios, there is no equijoin involved. It is strictly non-equijoins. In pandas, range joins are usually computed as a Cartesian join. So you compare each row from the left with each row from the right. And that becomes quite expensive memory-wise and performance-wise as your data set increases, or the size of your data set increases. Yes, pandas has an interval index option, which is very performance, but it's limited to scenarios where your intervals do not overlap. If your intervals overlap, you are restricted to using a for loop, and at that point you lose the advantage of that performance, or you lose the performance you were looking for in the interval index. So again, if your intervals do not overlap, fantastic, interval index will fit in nicely. If they do not overlap, then you're back to square one in a way. So let's have a look at an example. You've got a column, you've got a data frame from the left, a data frame from the right, and I'm saying, this is a point and interval join, and I'm saying, give me the rows where the pause column is between the start and the end columns. Typically in pandas, because there is no native implementation of a range join, the first thing you do is a Cartesian via the merge function, and then you do a post filter. Now you might be thinking, why can't we use an interval index? Remember I said an interval index relies on there being no overlaps for efficiency's sake. If you have a look at this, you can see the row 1, that's 5 and 11, overlaps with row 4, 7 and 25. So you've lost that advantage of the interval index in terms of efficiency. So we resort to this, the Cartesian join. Typically, this is what it does. Takes the values from the left data frame, compare it or combine it with the values from the right data frame, creates one large data frame, which is about 35 rows. So a combination of 7 and 5 rows respectively from the 2 data frames. And only after it has created this Cartesian, then it prunes it down to the results that we want. So again, look at that. 7 rows, 5 rows, you get 35 rows, and then you prune it down to 8 or 9 rows. If this was a large table, so you have 10,000 rows from the left, 10,000 rows from the right, that's like 100 million rows, and that is not good memory-wise, efficiency-wise. There must be a better way, in the words of Raymond Hettinger. And indeed, there is, with a conditional join from PyJanitor. And this is how the API looks. The key part there is the variable arguments, which takes a tuple of columns. So left column, right column, and the comparator. You have the number option and your regular NumPy. So the number uses a different algorithm altogether, and In some cases, it could be faster. It does not all cases, but again, it uses a different algorithm to what exists in your NumPy. As I said, the variable arguments is a left column, a right column, and a comparator. Let's just look at an example to see how First, you pip install PyJanitor, you import janitor, and this is how it looks like generally. df1 joins to df2, and then you pass the conditions. Again, look at that. That's a range join because you have a greater than, you have a less than, usually between something. So pause is greater than start, pause is less than end, and then you get your results. At its core, it's just sorting and binary search. There may be a few other things that go on in there, but at the core of the algorithms is sorting plus binary search. The core of the algorithms is reduce the number of rows that we need to compare. If at all we need to compare, let's not compare a Cartesian format. So look for the ranges of each of the values and then search within that space if at all we need to search. So if you look at that, you can see that we're not blowing up. We're just keeping everything as constricted as possible to get our results. And with this, we get significant performance compared to a Cartesian join. And because it can handle overlaps, it gives an advantage over the interval index. As I said, that's all it is, sorting plus binary search at its core. I've sold you, well, I hope I have sold you on the idea that conditional join offers more performance than your typical Cartesian join. And in a number of cases, it's comparable to interval index, especially when there are no overlaps. But let's see in terms of performance results. This is a 30,000 row data frame. And the aim here is to get overlaps. What are the overlapping events here? This is how the code looks. Again, start is just less than or equal to end is greater than or equal to start, and then you return your results. You have a multi-index if the columns from the left and the right data frames overlap. If there are no commonality, then you will get a single index column. It takes 19 seconds when we time it for this operation. This does not use number. I think when you run it with number, it's roughly the same speed. But keep an eye on that speed. 19 milliseconds on a 30,000 row. If we were to do this on with a Cartesian join, 30,000 rows, that's about 900 million rows. That is already crazy in and of itself. In terms of the size we need to blow up to, we need to shrink it down to 3,000 rows. I tried this on my computer. My computer wasn't powerful enough to deal with 30,000 rows memory-wise. So I just did a sample of 5,000 and it takes 2 seconds. So think about that. 2 seconds for 5,000, which when you do a Cartesian is what? 25 million rows compared to a 30,000 row data frame that the conditional join implemented in milliseconds, 18 milliseconds. So that's like 100 times performance improvements if you use a conditional join. Let's look at another performance option in terms of scenarios where your range join has an equijoin. Typically, when you have an equijoin in your code, it should give you more performance than just a non-equijoin. However, there is still room for optimization depending on the use case. This is a flight table. It's about 127,000 rows, and the whole aim of the range join here is get me overlaps or where I can get layovers in terms of origins and destinations. That's just the aim. Overlaps in terms of flights. Classic pandas merge and filter. You merge it, you create a data frame, and then you filter the data frame. It takes about 8 seconds. Not bad. Conditional join takes it a step further. It says, don't create the data frame just yet. I noticed that you have some non-equijoins in here. So give me the indices for the equijoin. Thank you. Compute the non-equijoins, get the final indices, and then create the data frame. So you're delaying the purpose, or you're delaying your computation, or you're delaying the creation of the data frame for as long as possible. And then you get 1.24 seconds. So hey, about 6 times improvement. Not bad. There might be scenarios where the non-equijoins would offer more performance than the equijoin. It could very well be, just as in this case, that the join keys on the equijoin are heavily duplicated. In this case, that seems to be the scenario, and if we force the conditional join to run the non-equi before the equijoin, we get a nice performance improvement of 329 milliseconds. So maybe another 2-3x improvements. I mentioned earlier on that it's possible that your equijoin keys are heavily duplicated, and if they are, the conditional join in the number version uses a sorting plus binary search. Simple, you have less number of rows to compare altogether, and it will give you more performance. A hash join has to match each value from the left to the right. And if they're heavily duplicated, that is going to be a lot of matches, only for you to not have to prune it down. Using the number version, we get 66 milliseconds. So what's maybe another 4-5x improvements? Again, there are various options depending on your use case, depending on your data, to get improvements for your range joins. This is what I was talking about, the duplicated keys. You can see how heavily duplicated they are. 6,000 rows for some of the values there, 3,000. So if you're matching 6,000 to 6,000, you're already getting 36 million rows, only for you to now prune them down. Why don't we avoid that and just use a binary search instead? Yeah, that is the end of the presentation. Again, conditional join is there. You can use it if you have range joins, or you have a combination of equijoins and non-equijoins. It will help you in terms of performance. As much as possible, it will avoid the Cartesian join. If you ever encounter issues using the conditional join, please leave a message on the PyJanitor GitHub page, and we will have a look at it. Thank you very much, and enjoy the rest of the conference.
Welcome to PyOhio 2023. I'm Rose Hooper, and I'd like to talk to you about Glacial refactoring, a Glacier-inspired approach to code cleanup. Why glaciers? Well, because the Glacial refactoring is a gradual process and composed of several distinct stages. And we can draw parallels between those stages and the code features and Glacial features. Glacial refactoring stages are composed of the codescape accumulation, which is the first part where we are now, the refactoring phase, which is the second part, which is what we are aiming to start, and then once we've established a cleaner code base, the evolutionary codescaping. All software has a shape, and I like to call this a codescape. Some code is easy to follow, and some is rugged and complex, just like nature. As the codescape accumulates, we start with the beautiful things. The initial concept and the startup or project is formed. The prototype is built, and people start adopting it. Features are added, and capabilities are changed. New developers, more contributors, more ideas, and more capabilities. Plugins, microservices, and third-party APIs. The ever-evolving ecosystem around us is influencing the shape of the codescape. Bigger, better, and faster. New hardware, new frameworks, new languages, new tools. New everything. Everything's amazing. But wait. The promised land of bug-free, performant, easy-to-modify unit-tested code doesn't exist. The unit tests are fragile. Some integration tests don't run. And there are magic sprinkled in the code and deployment toolchain. Even cosmic rays are causing problems. Software projects have an ever-evolving codescape. Gradually, the accumulation of cruft and code features encroaches. With well-intentioned refactorings and aborted features, team churn, rushed code, and magic dev environments. Misunderstood code and friendly and hard forks, broken dependencies, backwards compatibility and bugs and ownership changes and outsourcing. Business priorities and community pressure, cloudification and unsupported end-of-life versions of things, like Ubuntu 12 and Python 2.7, Red Hat 5, and CentOS 5. Oh, and Python 3.4. Database cruft builds up, and there's relics scattered around. We have unmaintained dependencies and performance fixes. And then we have scope creep, deadlines, break fix, community issues, and disagreements. My head hurts. Fortunately, all is not terrible, because glacial refactoring can help us. Remember, it's a gradual process intended to take time, with frequent small changes with minimal scope, and safe, easy to roll back changes, and self-documenting next steps. And it's easy to incorporate into any release lifecycle. The beginning here of the second phase, which is our first refactoring phase, we'll get to act like glacial detectives, looking for clues in the structure of our code, a lot like landscapes. Our goal? To gradually flatten and streamline the code, smoothing out those rugged code mountains we encounter. We have to identify our terrain, and the first step in glacial refactoring is understanding it. We'll look for and identify features in our codescape that have emerged over time. When we draw parallels to glacial advances and glacial features, we can see that there are some codescape features that emerge, like feature moraines, which are the accumulated layers of code, diverse and large, and each layer a testament to our evolving project. And code erratics, like the big boulders that are left behind. These are isolated pieces of code and remnants of past needs adrift in our current codescape. We have workaround eskers. These are trails of quick fixes and shortcuts weaving through the code, often born from urgent needs. And deadline scars, gashes left behind during rushed development and hasty patches, unpolished code, and the product of tight timelines. And then we find data kettles. These are pockets of data, scattered and disconnected, leftovers of the flow of information over time. And code mountains. Well, these are deeply nested, complex code structures resembling the rugged terrain carved by glaciers or looking like mountains. Let's have a look at some of these features. Well, if we look at feature moraines in code, we can actually see how these do resemble the moraine features from. Okay, so we have hints of legacy data and importing of that data with the import initial core analysis and legacy data cleanup. We also find system architecture clues like a separate data science database. This knowledge helps guide our refactoring strategy. Oh, and adding a core analysis with an external API. An important part of Glacial refactoring is adding Glacial notes. These are comments that document our observations and action items and help both our understanding and that of future developers. Here we have a couple of examples, one using a structured note format called a Glacial note, and then we have a dunder approach where we add an attribute to a class. In this case, we have an action item, flatten, where we want to pull the base class into the that class because it's the only usage of it. And here we also, a bit further down in the code, note that we have some things to look into, like this import initial core analysis looks to be unused and there's no refs in the current code. Our investigation action here is to look at the Git history to figure out where it came from and if it is truly gone. And then we have another one, a note that we added, and that was for that core API. And does it just use USGS? Then we go and look at some code mountains. What do these look like? Well, they're deeply nested code formations, and unfortunately, they're one of the most intimidating naturally occurring code formations to work with. These are usually full of code moraines and code erratics. The distinct shape of a code mountain is easy to spot. The left margin is shaped like the peaks and valleys of a mountain range. To flatten a code mountain, well, let's start by adding some Glacial notes documenting the findings before we make any changes. Here we've made a note that this appears to have been a closed issue from 2022 and that the feature flag from 2009 is no longer used. And the reason is that there is a release that fixed the issue in the presentation UI. We also note after a large block of code with an else that's looking like a valley that this is a good spot to flatten or extract functions. And we also make some notes on some of these if-elses about, well, maybe we actually want to put the validation first. Now, before we continue, remember we want to make small incremental changes, and this is where we want to commit our code. We want that history. Then we want to haul away those code erratics. Now that we have our intent committed, we can make fixes one at a time. And here's an example of hauling away a code erratic. Zap. Now when we removed it, we made a note here that continue. It appears to be unnecessary. Next up, we have our heavy-duty excavation tool, flipping of if-elses. This is a very powerful way to evaluate and understand and flatten code. This kind of an if-else that we have in front of us is where the main code path is second and that the exception handling is first. So if we negate the if and move the code from after the else to before it, we now have the main code path first. This is a cleaner structure, and it lets us flip off the else. Here we can tell the else to take a hike and use a continue statement to avoid having to deal with the secondary use cases. Evolutionary codescaping. Well, that's the Glacial retreat. And it's envisioned as an integral part of future software development life cycles. The opportunity here is using Glacial notes for continuous improvement and integrating our refactoring process seamlessly into our software development lifecycle. with the maintenance of the glacial refactoring principles and tooling to help us understand the code behavior and usage, and building tools like parallel code paths for risk mitigation. The journey for glacial refactoring is just beginning, and assistance is welcome. Join me in shaping this methodology by refining terminology and creating guidelines, writing examples, and helping align the principles with existing practices and terminology. One of the important parts of this project is to promote adoption of a positive perspective on all kinds of past code. And we want to build tools like helper libraries and reporting tools, integration into various CI/CD systems, linting tools, etc. Thank you for joining me on this exploration of glacial refactoring, and here's a bunch of ways to reach out to me.
Hey there everyone, welcome to my talk called Animations from First Principles. My name is Rodrigo. You can find me on Twitter /X/whatever at MathsPP blog. I'm a developer at Textualize, so I work on the textual framework, and whenever I have the chance I write about Python at mathspp.com. So writing Python code and teaching Python, those are my two main activities. And in this talk, I want to write some Python code to teach you how to make animations from first principles. So the title of the talk is exactly what we're going to do. Now, the idea for the talk is that I show you because I'm saying from first principles, what I want to show you really is the concepts that let you create any animation from scratch. And so, although we will be using the Pygame package to draw on the screen, we don't want to use the methods that Pygame has to draw specific figures. So what I want to show you is how you take the atomic operation of drawing a single pixel or coloring a single pixel, how you take that operation to draw arbitrary figures, then animate the drawing of those figures, and then animate morphing between figures. So that's our starting point. And in order to do this, we're going to create a black RGB tuple, and then we're going to take a canvas. So let's create a canvas from our Pygame. So pygame.display.setMode. Let's create an 800 by 800 canvas. This really is the screen, but I'm calling it canvas for this talk because it makes more sense. Now we're going to fill the canvas with black. And now we're going to update the display. Flip. And now we create an infinite loop just so we can have time to look at the canvas. So here you have it. This is the black canvas. And now what we will do is we will draw a circle on the canvas. And again, we don't want to use a method that draws a circle. We want to draw it ourselves. And so in order to figure out how to draw a circle and in general how to draw any figure is you need to think of it as, or the way I like to do it is think of the way I would draw it with a pencil. I'm going to open a canvas here and I have a pencil, and the way I would draw it with a pencil is I would figure out some point, maybe here on the right, I would put the pencil down, and then I would drag it over my canvas to draw a circle, right? This is how I would do it. And so we will mimic this behavior in Python, except that we cannot draw a continuous line. We can't do this. So what we will do is we will put the pencil down in a position and put a point there. And then we move the pen just a little bit and we put another point there. And then we move the pen and we put another point there. And then we move the pen and we move the pen and we move the pen. And by jotting down a bunch of points close together, we get the feeling that we drew a line. Although the only thing we did was draw single points. And the way in which we do this is we're going to define a function. We're going to define some function. Shouldn't have done this, but now I'll commit to it. So we're going to define a function that accepts a percentage of the progress of our drawing and returns the position of the pen at that point. So for example, if we've made 0% of our drawing, then the pencil should be right here. If we've made 50% of our drawing, then the pencil will be over here on the left, right? Because the actual drawing is to go like this. This was terrible, but the halfway mark is on the left. If we're at 25%, then the pencil should be right here. And if we're at 75%, the pencil should be right here. So what we'll do is we'll define a function that computes these positions. So let me call this function circle. So def circle. It's going to accept this percentage of progress, and it's going to return this position. Now, to compute the position, I need a little bit of maths, and in particular trigonometry, so the cosine, the sine, and pi. And so what I'll do here is I'll take the center of the screen, and I'll do a little bit of math, 2 times progress times pi. And then for the y coordinate, we're going to do a similar thing. 2 times progress times. All right. And now what I want to do is I want to make the drawing. And in order to draw something that looks like a continuous figure out of drawing specific pixels, what I need to do is I need to draw a bunch of points, because if they're close enough together, then it will look like a line. So we can do that. We're going to say that for points in range of, for example, 1000, this should be enough. The first thing I need to do is convert this iteration into a progress percentage. And I do that by taking the current iteration and dividing by the total number of iterations. And then what I can do is I can use the method setAt that accepts an XY position and sets the pixel at that position, in this case to white. I just need to set the color white, so that's going to be 255, 255, 255. And then the position is given by the function that we created. So now if I draw this and if I update the screen after drawing the circle, so let me take that and update the screen after drawing the circle, I should have a circle on the screen. It's not import math, it's from math. Silly me, sorry about that. So we can see there's a circle here. Now, the circle is very faint. It's very thin. So what I'll do is I'll create a small function that draws a thicker circle. So it's going to take an XY position and the color, and it's going to set the color on the canvas. Oh, that's the wrong thing to call, so again, let's draw. So we're going to draw on the canvas. The position is given by XY, the color is given by the color, and the radius is to be thicker. Are these in the correct order? No, they're not. And so instead of using setAt, let's call drawPoint. Like this. And now if I rerun the code, I should have a thicker circle. Alright, so the only thing I did was I had to cheat a little bit here, and this pygame.draw.circle, just think of it as drawing a thicker point. So that's why I called it drawPoint. So I draw a bunch of points, and because I show it in the end, it looks like a complete circle. Now what I want to show you is how you can animate the progress. And to create an animation, the only thing you need to do is you need to create a bunch of static pictures and show them in quick succession. That's essentially it. And if you draw enough pictures, and if the way in which you show them is quick enough, it's going to feel like it's animated. So in short, what we'll do is, as we go through the progress of drawing this circle, what we'll do is we'll draw a little bit and show the screen. Then we draw a bit more and then we show the screen. Then we draw a bit more and we show the screen. We draw a bit more and show the screen, etc. That's the way we will tackle this. So how can we do this? It's going to be similar to this loop, but now it's going to have 2 nested loops. So let's say that the FPS of our animation is going to be 60, and the duration of the animation is going to be 3 seconds, and so the total number of frames, the total number of pictures we need to draw is the number of seconds times the number of frames per second. That's right there in the name. And so this gives the number of frames we need to draw. And so for frame in range frames, we need to do something. Now, the something we need to do here is draw just a little bit of the circle. And so for each frame, we're going to draw 50 new points, for example. 50 new points. And now the only thing we need to do is figure out what's the progress we've made for each point. And the progress is given by a percentage of the drawing that was already drawn in the previous frames, that's frame over frames, and then a small advancement we make, we move the pen just a little bit, corresponding to the point we're at out of the 50. But this point out of the 50 is in relation to all of the frames that can be drawn. And then drawing the point is just the same thing. We just draw a point. And then what we want to do is we want to show progress after we've drawn each frame. So this draws the whole frame and this shows the frame. And so now we can get rid of this. If we run the code, we have our animated circle. Now it's going a bit faster than 60 frames per second, but then we can use Pygame to help us keep the FPS in check. And that's what this clock is doing. So tick FPS. So this just makes sure that we don't go faster than the desired frames per second. So there you have it. We're drawing a circle and we're animating the drawing. And I'll stress it again. One of the most important things here is that this function circle isn't special. This is just a function that accepts a progress percentage between 0 and 1 and returns the position of the pencil. So we can create any other figure so long as we create the appropriate function. And in mathematics, this is a parameterization of the circle. And so now what I'll do is I'll create a parameterization of the figure 8. And you're not supposed to, I don't know, come up with this formula by yourself or something. It's just you can look it up online. This part is fine. You can look up the parameterizations of the figures you want, or you can just play around with numbers and see what happens. And I look this up, and this formula is going to create a figure 8. So in here, in my drawing loop, instead of drawing a circle, I'm going to draw a figure 8. And so if I run the code, oops, I did something wrong. Sorry, I must have gotten the formula wrong. 8 return, sorry, this is not times, yeah, silly me, this is plus. Sorry about that. So then I have an animated figure 8. And the only thing I did was change the parameterization, right? Because the concept is the same. For each frame, we're going to draw a bunch of points, and we just need to move along the figure. So now what I want to show is how can you morph two figures together? How can you do this? So the idea, or the thing you need to focus on, changed a little bit. Before, for each frame, we wanted to draw just a portion of the figure. Now, on each frame, we want to draw a whole figure, but we want to move from a circle to a figure 8. We want to morph the two together. And so at each frame, when you freeze the frame, what you need to figure out is how much morphing has already happened. If the morphing can go from 0% to 100%, how much percentage of the morphing has already occurred? And then you use that percentage to go from the circle to the figure 8. So how do you do that? Essentially, you put the two parameterizations together. You just need to find a way to combine the two together. And in maths terms, what I'm about to do is I'm going to do some linear interpolation. So this morphing is a number from 0 to 1 that defines how much morphing already happened. And this progress, again, it just tells you the position of the pen. So the first thing you need to do is you need to compute the position of the pen for the two figures separately. You compute the progress, the positions for the two figures separately, and then you use a little bit of maths, again, linear interpolation, to determine how much from one figure to the other you've already gone. So how much morphing already happened. And this is the formula for linear interpolation. You can look it up later. And it's just morphing the two together. And so what I need to change in my loop is, for each frame, now I want to draw the whole figure. So instead of drawing just 50 points, what I'll do is I'll draw maybe 1000 points. And so the progress is again determined by the point over the 1000. And when I'm drawing the point, I don't want to draw the figure 8. What I want to do is morph the circle into the 8 with a given progress and with some given morphing factor. And this morphing factor is set by the number of frames that already elapsed. So now the number of frames determines how much morphing already happened. And in the end, we update the display. And the only thing that we need to do is to clear the canvas at each point. So for each frame, we need to remove the previous drawing and then draw everything from scratch. So something like this. Let's see. So this right here morphed two figures together. And again, there's nothing special about the circle, nor about the 8. Only thing we did was we parameterized both the circle and the 8, and then we used a little bit of linear interpolation to morph the two. So this is what I had to show in this short talk. I hope this was interesting, and if you want to take a look at a written version of the talk, and obviously the code, and some further things you can do, for example, animate with color and have gradients of colors along the figures, you can scan this QR code, which will take you to a written version of the talk. And you can also see my email over here at the bottom. Feel free to email me if you have questions, suggestions, if you have feedback. I will be waiting for you to write to me. So thank you very much for your time, and I'll see you around. Bye.
Hey friends, welcome to the SALT Project Test Clinic. My name is Wayne and I'm a core engineer here on the SALT team, and I'll be leading the test clinic today. Well, that's what I said twice a week for about 3 years as I ran the test clinics for the SALT project. If you haven't heard of the SALT project, if you're not sure what it is an automation framework that is typically found within the server automation world. So if you have 1 server, 2 servers, 5 servers, you can probably do that by hand without too much issue. But once you scale that up to 10, 100, 10,000, 100,000, you're really just not, you can't do that by hand anymore. You really have to have some automation. And that's where a tool or product like SALT comes in. So SALT is huge. SALT, at last count, had about 500 modules. And in those 500 modules, they ranged from about 100 to 10,000 lines per module. And that just includes the execution modules, not the state modules. So, and then it also doesn't even encompass the core of SALT, what all of this stuff runs on. So SALT is huge. And so SALT, being a large project, received lots of contributions from a number of different people with varying code quality. Some people, they're just not programmers. They're not software engineers or developers. They just want to get this one SRE task done, and they want to contribute back to the project. And this has gone on for nearly 20 years, and the current state, when I left back in January, was we had a little over 40% test coverage, which is not great. I mean, that's a lot of test coverage, but not great. So we had test coverage, but we needed more, right? And so as a core team, we decided together that we would put a moratorium on contributions to our code base that had no tests. We're just getting too many contributions, and the state of the code was such that we really had to do that. We had to say, look, let's stop. We need tests with contributions. We love your contributions. We'll kind of accept them and put them wherever. We just won't merge them in until they've got tests. And so we had a number of community contributors say, look, I would love to write tests, but I just don't know how. How do I write tests? I've loved tests. I've loved automation for years, at least since 2012, when at Arkansas, I actually live coded Uncle Bob's bowling kata. I think it was about 45 minutes is what that took. So super fun, super challenging, but I've loved tests ever since then. So testing, it's been in my blood for quite a while. And our community member said, hey, I want to write tests. Just help. And so we already had one of our core team members, Tyler. He was doing some other streams on Twitch. And I said, yeah, sure, I'll teach a test clinic. Let's see how that goes. And so that was how I got involved and how I got started running the test clinics. I held them one in the morning and one in the afternoon so that we could have a broader reach among the EMEA and the European GMT time zones, along with all the ones that cover the States. So the test clinics, I started that during the entirely uneventful year of 2020. And as I'm sure all of us discovered, we can embrace interruptions. I had interruptions of children, both the 2- and 4-legged variety, and one of the first lessons that I think I learned during my test clinics was, just to embrace those interruptions, and that informality, it can be okay, especially during a live coding test clinic sort of situation. I also learned to be kind, right? Both to those within my house and those outside of my house. We were all going through a lot. Many people still are going through a lot. And be kind. That's definitely the first lesson I think I can share. Some of the interruptions, they would be just momentary. Somebody would come in and say something in my ear, or other times it was something that even involved canceling the test clinic. And so just embracing that. The way that I started these test clinics, I could have had a powerful IDE set up with all the bells and whistles and just everything going everywhere. But I didn't. I actually would start with just a blank terminal. That's what I'd just bring up my terminal at the beginning of every test stream. And I'd be in my home directory, and I would CD to my code directory. And once I did that, then I would even source my virtual environment file, and I would even spell it out source instead of the dot spelling. And pretty much the only kind of fancy thing that I used was Git aliases. Now, speaking of Git, how many of you have written or seen Git commit messages like these? And I'm going to read these because they're pretty amazing. Did something. Blah. Oops. Minor changes. Fingers crossed. More fixes. Work in progress. YOLO! So, I too used to write similar and very high quality commit messages. And, as part of this test clinic, as part of running these streams, and adding tests to places where there were no tests before, a lot of times it required the question, but why? Why is this code written this way? Is there a reason for it? Was it designed this way? Did it just end out this way? Did it ever work correctly? What happened here? And so I would go and I would look through the Git commit messages, and there'd be nothing. There'd be nothing in our issue tracker on GitHub. There would be nothing in the pull request. All it would say is just added the fizzbaz. That's it. Just it. Added the fizzbaz. I mean, it got so bad that I would read the RFCs. I would get into some obscure man pages. I mean, it would get so bad that I even had to check out the second page of Google search results. So, as I looked through these Git commit messages, and that thought kept coming back, well, why? I started to learn about writing that in my commit messages. And as I would write these Git commit messages, and I started running these test clinics, the more and more I ran the test clinics, the better I actually got. Because I got better at articulating my thoughts. I heard it put that it's called thought knitting. And I love that. I love that imagery there, where you've got these threads that are in your mind, right? And you're taking these threads and you're knitting them, and eventually you end out with some socks or some pants or some gloves or oven mitts, right? And so that's what I would do, is I'd do these test clinics. I would go through and I would have to, I'd want to write some code, right? Write some tests. And so I could just sit there, but that's not particularly interesting to watch, right? So I would think about it and I would say, okay, what is it that I'm trying to do here? Okay, and then explain that. All right, I'm trying to add the FizzBaz. I say, okay, well, why am I trying to add the FizzBaz? Well, I'm trying to add the FizzBaz because we had a feature request for it, or it's a bug report, and that bug is that there is no FizzBaz, and we need that. We just have a FizzBuzz, and so we've got to make this change. And so I'm going to make this change in this particular place, not this other place, because... And I would go through and I would knit my little thoughts. And as I went through this process, as I explained what it was that I was thinking in my mind, when I explained it out loud, it became incredibly trivial to just write that down as my git commit message. And these messages got much better and much longer because I was starting to explain the why. I'd just spent 2 hours explaining why I was writing things this way, and now I just have to write it down again. So it was much easier to do that. We think a lot that writing code is communicating with the computer, right? I've got an idea and I want the computer to do this, and then everything as well. But honestly, that's not often the case. Really what we're doing is we're communicating with other people. It may be future you that you're communicating with, but we're actually communicating with other people. That's why we write code in Python and not assembly or Java, right? It's because we want to communicate with other people. We want other people, even if it's just, again, future us, we want to be able to take our code and look at it and go, oh, this is what they meant. And so the final lesson that I learned with the test clinic here is that there must be a reason. When I first started programming, all of the time I would have the thought, and even utter the phrase, this is impossible. What in the world? There's no possible way that the computer can be doing this thing, this behavior that I'm observing. It's absolutely, utterly impossible. It's a human reaction, I think, because we really just want things to work the way we meant for them to work. But if we don't tell the computer what we actually meant, the computer's going to do something different. And so that's where it boils down, or what it boils down to, is there must be a reason. If you are observing behavior from a computer will do exactly what you told it to, whether or not you meant it. The computer doesn't care what you meant. It only cares what you actually said. And so it will do that thing precisely. And so for us as developers, one of the best mind frames we can have is there must be a reason. When we see code, when we see behavior that's happening, when we see log messages popping up that should not be there, when we see behavior happening in our program that should not be there, instead of thinking, well, this is impossible because I totally, absolutely, completely accounted for this behavior, and it's totally impossible. I don't know how this is happening. They must have hacked it. Instead, think, well, I'm seeing the behavior. This is happening, and the computer is going to do exactly what I told it to, even if I didn't mean for that to happen. So there must be a reason that this is happening. There must be a reason. And as we look at it and we say, oh, there must be a reason, then it becomes much easier to start eliminating places and say, okay, well, I'm seeing correct behavior up until here, I can ignore that. I'm seeing correct behavior after here, so I can ignore that. So it must be somewhere in here, and then we start digging and digging, and we finally find that thing. So there must be a reason somewhere. But anyways, so as I ran the test clinic, I learned things, right? I learned to be kind with myself, be kind with others. I learned to embrace the interruptions. I learned to show the basics. And, I learned that there must be a reason. Communicating with other people is my reason, and that's why I'm here giving this talk today, is because I want to communicate with other people, and that is my reason. Thank you.
We'd like to thank everyone involved in making PyOhio happen on short notice this year. Thank you to the speakers and everyone who took the time to propose a talk. Thank you to the reviewers who provided feedback and helped us select the talks this year. Thank you to the volunteer organizers who put in many hours behind the scenes. Thank you to everyone who bought a t-shirt or donated to support PyOhio. And thank you to everyone for taking the time to watch along with us and join us in chat. And now, I'd like to introduce Kattni, our PyOhio conference chair for 2024. Kattni joined the PyOhio community when she gave a tutorial at PyOhio 2018. She gave a wonderful keynote at PyOhio 2019. You really should check out the video if you haven't seen it. After that, she started volunteering with the PyOhio organizers, and she's been the co-chair of the conference this year. PyOhio has been instrumental in my personal and professional growth. I've been chairing this conference since 2018, and my goal in that time has been to make sure that PyOhio continues to thrive and give other people that same opportunity for growth. And that's why I'm so happy to know that PyOhio is in the hands of somebody who cares so much about this community. And now here's Kattni with some very exciting news about PyOhio 2024.
Hello, I'm Kattni, your PyOhio 2024 conference chair. What a great day today. We had an amazing lineup of talks and a wonderful group of attendees. To echo Dave, thank you to all involved. I want to say a special thank you to everyone for helping us to put this together on short notice. We couldn't have done it without everyone's help. I, however, am here to talk to you about the future of PyOhio. I'm incredibly excited to announce that PyOhio 2024 will be an in-person event. Our virtual events have been excellent, but we're ready to bring everyone together again. The break between 2019 and now is giving us the opportunity to reimagine PyOhio. As we begin planning, we are keeping an open mind about how we intend to structure the event. With a change in venue may come a change in the format. I hope you will also remain open-minded as we work to bring you the best PyOhio possible. We believe it's important that PyOhio continues to be an annual conference in the state of Ohio that's free to attend, focused on the community in this region, and welcoming to those joining us from further away. The special and unique community that has evolved around PyOhio is a significant part of what embodies this conference. We're in the initial stages of putting everything together. Here's the information we have for you so far. PyOhio will be hosted in the summer of 2024 in the greater Cleveland area. We will keep you posted with any new developments as they become available. To keep up with the latest details, you can join the PyOhio Discord server, follow us on social media, or sign up for the mailing list. Links and sign up are available now at pyohio.org/2024. Thank you again to everyone who participated in PyOhio this year, and I hope you're as excited as I am for 2024. We hope to see you soon.